예, 아침 일찍부터 많은
Thank you very much for joining us from the early hours in the morning to participate in this Korea Arctic Science Research Center. We will start the seminar at 9:35. I'd like to ask you all to kindly take your seats.
요거는 5분 35분쯤 시작.
35분에 영상이 딱 끝날 수 있게
네.
34분에 멘트 시작하시면
네, 알겠습니다.
저는 오늘 방송에서 도착하고 나시면
네.
시작할 수 있어요.
예. 네. 오늘 저희가
We have prepared about 100 seats. Despite this early hours, we have a large turnout and we had to place more seats. Thank you very much for coming. We will soon begin under the topic 2 decades of Korean Arctic research contributing to sustainable and prosperous future of the Arctic. KOPRI's third Korea Arctic Science Research Seminar will begin. A few housekeeping announcements. This seminar revolves around the 20th anniversary of Korea's Arctic research. Once the seminar is concluded at 11:40, the Arctic Dasan Station 20th anniversary book launch event will be held. I ask you for your continued participation, and please stay with us for the book launch. And before we kick off the seminar, here is a video on the Arctic Dasan Station and its achievements.
북극은 지금 빠르게 녹고 있습니다. 바다 얼음이 줄면서 지구의 온도 조절 기능에도 이상이 생겼습니다. 대한민국도 북극에서 다가올 위기에 대비하고 있습니다. 노르웨이 북부에 위치한 다산과학기지는 2002년에 문을 연 우리나라 최초의 북극과학기지로 리알슨 과학기지촌 8번째 기지입니다. 다산과학기지에서는 극지의 변화를 관찰하고 미래 가치를 찾기 위한 연구가 진행 중입니다. 다산과학기지에 이은 아라온호의 등장으로 우리는 북극의 얼어붙은 바다도 연구할 수 있게 되었습니다. 1991년부터 2021년까지 극지연구소는 501개의 북극 논문을 발표했습니다. 다양한 연구 주제를 발굴하고 여러 선진국들과 협력한 결과입니다. 또한 다른 국가들에 비해 연구의 시작이 늦었음에도 양질의 논문을 발표하며 성장세를 보여주고 있습니다. 기후 위기 문제의 해결책을 찾기 위해 대한민국의 북극 연구는 이제 더 넓은 곳으로 뻗어나갑니다.
네, 그럼 지금부터 한국의
And now, under the topic 2 decades of Korean Arctic research contributing to sustainable and prosperous future of the Arctic, the third Korea Arctic Science Research Seminar will begin. Good morning. I am Choi Young-jun, Head of Policy Research and Development of KOPRI, and the MC of this seminar. I'd like to thank all distinguished guests, presenters, panelists, and online participants tuning in from across the nation and abroad. The first seminar was held in 2019, and today we hold the third seminar. marking the 20th anniversary of the Arctic Tasan Station. We will take stock of the current status and achievements of Korea's key Arctic science research and seek new ways going forward. Simultaneous interpretation will be provided, and all the presentations and discussions are live streamed online on YouTube, and a recording of the seminar will also be posted at a later time. Then let me introduce our honored guests. When I call your names, please rise from your seat and greet the audience. We have Director Do Jae-ok of the Marine Development Division of the MOF. We also have President Kang Sung-ho of KOPRI. Presentations will be delivered by lead researchers carrying out key Arctic tasks of KOPRI. We have Director Yang Eun-jin of Division of Ocean Sciences, Principal Research Scientist Kim Joo-hong, and Choi Tae-jin of the Division of Atmospheric Sciences. And we have Director Kim Hyun-chul of Satellite Remote Sensing Cryospheric Information Center. We also have panelists who will share insight on the presentations from a research expert perspective. The panel session will be moderated by Professor Lee Gi-taek of Post-Tech. From the marine sector, we have Professor Lee Sang-han of Busan National University, from the atmospheric sector, we have Professor Kim Baek-min of Byogyong National University. And on the environment, we have Director Lee Sung-hyup of the Green Technology Center Korea under the Korea Institute of Science and Technology. From the cryospheric sector, we have Professor Cho Young-hun of Busan National University. And now, let us begin the seminar. Let me first invite President Kang Sung-ho of KOPRI for an opening address.
Good morning, everyone. I am Kang Sung-ho from KOPRI. I would like to thank all distinguished guests who have come to the third Korea Arctic Science Research Seminar, where we will take stock of our science research results so far as we commemorate the 20th anniversary of Tasan Station and examine our research direction for the future. Furthermore, I would like to thank Policy Director Do Jae-ok from Ministry of Oceans and Fisheries for coming to this event despite the busy schedule, and also Professor KOPRI from Professor Lee Gi-taek and Professor Kim Byung-moon from Bugo Yongsan University, and other distinguished guests who are here with us for the presentations. I would also like to thank Dr. Yang Eun-jin and Kim Hyun-chul for participating in the expert presentations, and also Vice President Shin Young-chul for delivering the keynote presentation. 2022 is a meaningful year in Arctic science research. First, as noted earlier, it is the 20th anniversary of Tasan, established in Nielsen as Svalbard, Norway in 2002. And through the Tasan Research Institute, we were able to expand our research efforts, and this year we also built the next generation IBRV. And last year, the Act on Promoting Polar Activities was legislated, which covered both the Antarctic and the Arctic. And following up on this, we have also built the first master plan for polar activities, which were important milestones for Korea's journey towards the polar regions. Now, based on this historic achievements and meaning, we are now at a point where we have both the policy arm and the infrastructure arm to make greater leaps into the future. However, the Arctic environment is changing faster than our efforts to understand it. Temperature in the Arctic is rising 3 times faster than the global average, and this year research results showed that the Barents Sea near the Svalbard, where Dasan Station is located, is actually heating up 7 times faster than the global average. This change not only affects us in Korea, but is leading to disaster incidents in key areas of the northern hemisphere, such as heavy snow, heat wave, and heavy rain, clearly showing us that the changes in the Arctic are not just the business of the far north, but are palpable changes that we feel. The importance of preserving the Arctic and Arctic science research to predict and respond to rapid changes has become greater than ever before. For our research to take another leap forward, we must now have the independent capability to observe the Arctic. So today's seminar features key pillars of Arctic science research: ocean, atmosphere, environment, and ice, so that we can view the Arctic from the sea, land, and space perspective, and introduce the recent research trends for responding to changes. And we will have a discussion on future research direction. I hope that today's event serves as an opportunity to look back on the research results of 20 years and gain perspective to examine the way forward for the next 20 years. Once again, thank you very much for attending, and I hope we have a productive session. Thank you.
교회사를
Thank you very much. Please give another big round of applause to President Kang. And we also have Director Ro Jae-ho from the MOF for congratulatory remarks. Please come forward for the address.
여러분 대단
Good morning, ladies and gentlemen. I am the Marine Development Division Director, Do Jae-ok of the MOF. I would like to thank Professor Lee Gi-taek of Post-Tech, Professor Lee Sang-hun of Busan National University, Professor Kim Baek-min of Bugyeong National University, President Lee Sang-hyuk of Green Technology Center Korea, Professor Jo Young-hun of Busan National University, and all KOPRI scientists for your presentations. Thank you very much. This year is a very significant year for Korea's polar activities. In April, the long-awaited next generation IBRV was started being built. And in November, as a national strategy, the first master plan for the promotion of polar activities was established, envisioning to turn Korea into a follower to a leader of polar activities. And above all, we celebrated the 20th anniversary of the opening of the Arctic Dasan Station. In 2002, Dasan Station opened in the research community in the Allison, Norway. Since then, based on the passionate efforts of the polar scientists and the government investments, we were able to produce some of the world's first research outcomes. In 2014, Korea first identified the fact that sea ice loss in the Arctic leads to extreme cold on the Korean peninsula. And last year, we found that the global warming leads to an increase in Arctic microalgae that forms clouds that block solar energy from reaching the Earth and reduces Earth's temperature as a self-correction. And in 2022, we will take stock of Korea's polar science research, and we are at an important turning point of having to enter into one of the Arctic research leaders. At this time, under the topic 2 decades of Korean Arctic research contributing to a sustainable and prosperous future of the Arctic, we are holding this seminar, and I believe it is very significant. A leading nation of Arctic research uses cutting-edge infrastructure surveying the Arctic oceans and addresses global issues such as climate change by presenting solutions. As such, the master plan from last November plans to make Korea one of the first Asian countries to use the IBRV to lead international collaborative expedition, including the North Pole and the Arctic Ocean in the high north, as a polar frontier task. And we are also going to identify the impact of Arctic changes to these 4 seasons of the Korean Peninsula. We will pursue these frontier tasks and lay the foundation for Korea's Arctic research to make a new leap forward. In ocean, atmosphere, environment, and cryosphere, not only KOPRI researchers, but researchers from Post-Tech, BNU, BKU, and the Green Tech Center Korea and Alaska University, we have many experts to make presentations and discussions. I hope that we will have in-depth discussions so that Korea's Arctic research can play a key role in making a sustainable tomorrow based on the 20 years of achievements. I would like to thank all KOPRI staff for making this event possible and all presenters and discussions on behalf of MOF. For a fruitful future, I hope that the seminar sows the seeds of Arctic research today through meaningful presentations and discussions. Thank you.
Thank you, Director Nojeo, for delivering your welcoming remarks despite your busy schedule. Before we go into the topic presentations, we will now hear from Vice President Shin Young-chul of KOPRI for his keynote address. Please come to the stage. Hi everyone, nice to meet you. Keynote address, I think, is too serious for my presentation, but I just want to make a short introduction before I go into the main topic. My presentation is titled Rethinking 2 Decades of Korean Arctic Research and Going Beyond Academic Excellence to Making a Social Contribution. I was thinking about how our science research should look like, and it's a diagnosis of the current situation and an outlook. I don't have the solution for all the problems, but would like to talk about the status quo and the current challenges and the environment and the direction forward from my perspective. Our Arctic history, I think, looks like this if we go into the details. There were times when our vessels went near the Arctic, but not the Arctic. And there were a couple of people who ventured near that space as well. And there were students who wrote papers on Arctic. And then people went on board on a foreign vessel to go into the Arctic. And then we borrowed platforms from other countries to do trial runs. Then in 2002, we joined the IASC organization, an Arctic organization, and then in the same year, in the city of Lisan, we opened the Dasan station. This is a very early history of our Arctic research in Korea. So this is the article in Jungang Daily, which is referred to often when we talk about the start of our research efforts, where Korean scientists first stepped foot on the Arctic. It is near the Chokchi Sea. He went on board a Chinese ship, and that was the first time that China also went to the Arctic, and they invited us. So if you look at the photo, the left person is our current president of KOPRI, And on the right person is also an active member of a maritime organization. In 1991, 1 year later, the Aurora expedition reaches the North Pole. And at KMI, actually the previous body before the KMI, made efforts as well. And if you go further back, we can see these kind of pictures. This Baekhyang ship is only 389 tons, which is very small and was built in the 60s. And our fishermen went on this ship and approached the Arctic region. Remote sea fishing back then was a very strong export industry like the semiconductor chip industry is now. And these are some of the footsteps that we had. And as for overseas students, like Dr. Nam Seung-hee, there were a couple of students who did Arctic research as a Korean scientist. And before we had our ship, we borrowed Russian ships to do research. And in 2002, Dasan station opened. And this is the photo of the 10th anniversary of Arctic Dasan Station. We have the then Minister of Transportation Ministry and a much younger me also in this photo on the left. So to sum up, let's say our starting year is 2002 for Arctic research, and up until 2010, we didn't have much base to go on. For example, we didn't have a ship. And most of the Arctic efforts were just based on Dasan. If we wanted to go somewhere else, we had to borrow someone's ship. But then from 2010, we had our own ship called Araon, and we were able to expand our reach. And on land, we also went outside Dasan to go to other Korean bases, and computer-based modeling research activities were also improved and expanded from this point on. Let's look at the quantitative aspect of our growth. In the first year, maybe we had made around 20 expeditioners going to the Arctic, but now we have 100 per, much more than 100 people, because we go to a lot more places and more ships. Now we not only go to Dasan Station and Chokchi Sea, but we are able to go to many more places. And even season-wise, we don't only go in the summer, we also go in spring and late autumn. Now let's look at our themes, our research themes. Even if it's not conventional field expedition or studies, we look at the glaciers, the chemical side of glaciers, and for practical use, for example, we do academic research using satellites. So even in terms of our study themes, we have grown very much and have become diversified. And the University Professors of Korea, as they researched and studied Arctic, also added a lot of topics and themes that Korea was able to cover. And YOPP, PAG are some of the international partnerships that we are engaging in and participating in. As a result of widened engagement and growth, now we are really able to publish high-profile papers that has worldwide recognition. For example, the paper on Arctic amplification and Arctic geological evolution. And these days, we are now able to publish papers that gains the recognition. And we have many such excellent professors here with us today. Well, of course, everyone knows that Arctic changes are related to mid-latitude climate changes, but his paper was very significant in showing the specific link between these two events. And this kind of excellence in academia is continuing. And there were also key headlines that we were able to contribute in. On the left, it says mass occurrence of Pacific coepods. and it was a paper to understand why it happened, and also a research and study on microplastic of the oceans were featured in high-profile prominent papers, which is known by a lot of people. So let's look at the current situation. In 2013, Korea was recognized and accepted as an observer country of the Arctic Council, and this helped our efforts become a government-level policy. Before, it wasn't a statutory plan, but afterwards we now have a statutory plan, and uh, the the co-arc, which has both government and private involvement, was established, and with growing interest, the perception grew that we need a stronger scientific base to pursue this initiative. And not only research, but there are now more people asking that we have a stronger voice in Arctic governance as well. So the expectations for the Korean Arctic research is growing, but the actual support to drive the interest is not expanding or increasing as fast. So there might be a little difficulties, like there may be little difficulties, but we think that by 2026, our next generation icebreaker will be built, and by 2027, we'll be able to operate it. So we should fully capitalize on this as well. And the institutions or government agencies which provide research subsidies and funds, of course, need to be engaged more. It's a imperative that we have to do. And not only KOPRI, but other institutions need to do a good job of building up data so that later on, people, excellent people and capable people can access it and look at the history. And research opportunities and research infrastructure should be opened up. And this kind of mandate is not only on Korean institutions, but other foreign institutions as well. I spoke about a similar subject 2 years ago at this seminar, and I brought the slide again. I said in the 2020 APW presentation that we want to publish high-quality papers, which we did from 2020 onwards. And back then, I said mid to long-term responsibilities of KOPRI will be implemented as our obligation. And I said that we have to do research that is actually useful. And for the tasks going forward, I also shared that we need to expand our research scope or point from Dasan Station on Bering Strait to the whole Arctic to understand how the overall Arctic connects and impacts the rest of the world. And new discoveries unique to the Arctic, whether it's fossil or plant materials, are some of the subjects that KOPRI wanted to study more. So I would like to share 3 points regarding the diagnosis and also outlook for the future. I will talk about the direction going forward and also a diagnosis on whether we're doing the right job to meet that future direction. I will ask questions and provide answers, and also some supporting materials to the answers that I provide. First is we need to do excellent Arctic research that is unquestionably excellent. The quality of scientific research is not an area where we can compromise on. We always have to deliver excellent quality results. And secondly, when we do invest, we need to make future-oriented investment decisions, because if we do unplanned researches, I thought it would actually bring about a worse outcome for us. And whether it's on the policy side or government side or the industry side, I said our KOPRI organization has to stay relevant. These were the direction I thought were very important back then. So let's see if we are doing a good job of keeping up with those directions and values. And there might be bigger confusion caused if we lose sight of the bigger values and important researches. There are some long-term, long-pole researches, whereas there are new items, recent items that are surfacing as a recent trend. And I think finding a right balance in our research effort between the two is very important. And when it comes to having infrastructure, let's say if someone moves too fast for the infrastructure to catch up, then that is also not a good sign. So we need to take a breath and look at the situation again. And if there's any problems in us communicating with other circles such as academia and private sector, then it's also a bad sign and indicates that we're not doing a good job. So where are we on our efforts? I think we have to look at the current situation, and that's why I will speak about the checklist and also new developments. Of the tasks that we have, 2 or 3 of them are flagship projects of KOPRI. But they have been around for a very long time. And if there are too many experts, then they will be called a dying science, where it's like a red ocean and has been studied for too long. So if we just have this dying science, it's also not a good sign. So we need to have like a blue ocean study, 2 or 3 new burgeoning areas of research topics. I also spoke about large-scale campaigns that we, Korea, would design. And if our research, that we design does not contribute to international research, then we're also doing something wrong. Whether it's permafrost research or any other topic, we need to have a plan where we take the lead for international research. And I said that Arctic-based attempts need to continue. For example, community engagement and business. Let me illustrate. We say that we need to cooperate with the indigenous people, but exchanging name cards with the indigenous people or signing MOUs are not everything to the effort. That is not all. So it could be monitoring of the indigenous people, or an actual cooperation use case between Korean companies and the indigenous people. And we need to have these kind of new specific attempts for us to do a better job in this field. I think I laid the foundation for the next presentation. Thank you very much.
해주신
Thank you very much, Vice President Shin Hyung-chul, for the keynote speech. And now we will begin the presentations. The topic this year is 2 decades of Korean Arctic research contributing to sustainable and prosperous future of the Arctic. On the topics of ocean, environment, atmosphere, and cryosphere that make up the Arctic, presentations will be given in that order, followed by expert discussions. Presenters, please come forward when it is your turn to the podium. First, Director Yang Eun-jin of the Division of Ocean Sciences will present the topic Korea Arctic Ocean Warming and Response of Ecosystem.
안녕하세요.
Good morning. I am Yang Eun-jin from the Ocean Research Division of KOPRI. Today, I would like to talk about how, since the icebreaker Araon was built and the ice-covered waters of the Arctic Ocean, how Korea has been responding to climate and environmental issues through research, monitoring changes in the marine ecosystem triggered by Arctic Ocean warming, and present a future outlook. We must focus on the Arctic because what happens there are not irrelevant to the lives of the present and future generations. As global warming heats up the Arctic has become a key center of attention. As the Arctic warms up, the sea ice that used to cover the Arctic Ocean is disappearing. In 2020, the sea ice cover in the Arctic dropped by the second largest degree ever, as about 50% of sea ice were lost. What's even more serious is that the sea ice is thinning, as multi-year ice that thickly covered the Arctic is being replaced with the thinner first-year ice. The loss of sea ice in the Arctic Ocean threatens us, but also opens up resources and the Arctic Passage, presenting new opportunities. As you can see on the left, as sea ice retreats in the CAO, fishery and biological resources are exposed. So to preserve them and to ensure sustainable use of the fishery resources, 10 countries signed the KOPRI, which took effect in June 2021. To protect fish stocks in the high seas of the Arctic Ocean, science-based international joint efforts have already begun. And on the right-hand side, as you can see, as the sea ice is lost, the sea routes are opened up for container shipping. And we can expect the Northern Sea route to further open up for container shipping to be facilitated, which requires marine and meteorological information around the NSR for vessel safety. As the Arctic continues to warm and sea ice melts, the ocean system undergoes massive change. As you can see on the first picture, the temperature in the Arctic Ocean has been rising on an irregular basis to a historic peak in 2019. And as the permafrost melts, freshwater inflow from rivers to the Arctic Ocean is growing. And on the bottom, you can see that across the Arctic Ocean, we can see evidence of acidification. In particular, as sea ice disappears, open water area is widening, pushing up primary production in the ocean, which makes up the ecosystem in the Arctic. Meanwhile, polar cods that inhabit the sea ice in the fishing days may have no place to inhabit in the next 20 years. Against such a dramatic environmental change in the Arctic Ocean, what is Korea doing? The Arctic Ocean has two gateways of ocean currents, one from the Atlantic and another from the Pacific. The Pacific Gateway is where the melting of sea ice and the temperature rise are the fastest in the Arctic. The growing inflow of the warm Pacific waters and fresh waters from Russia and Canada have been transforming sea ice distribution and ocean current system of the Pacific Arctic. In particular, these waters also connect the NSR and are therefore geopolitically important. With the sea ice loss, the Arctic Ocean ecosystem, environment, Arctic passages, and meteorological events in the mid-latitude regions may also change, and so we are conducting research there. Utilizing RV Araon, every July, we leave Korea and pass through the North Pacific, reaching the Northern Bering Sea, Chukchi Sea, East Siberian Sea, and the Beaufort Sea, where we've been conducting research since 2010. The key question in Arctic Ocean research on the RV Araon is what will happen to the Pacific Arctic Ocean system if the current warming continues in the Arctic. We carry out research with a focus on the marine ecosystem and the carbon system. As the Arctic warms, sea ice loss, ocean temperature rise, and inflow of freshwater will accelerate, causing changes in the Arctic Ocean and current systems, as well as biogeochemical changes. So our goal is to identify ecosystem reaction and ultimately produce a scenario of the environmental changes in the Arctic Ocean. Over the last 5 years, we conducted KAOS project as step 1. In 2021, step 2 K-Aware project was launched and will continue until 2026. K-Aware conducts periodic observation, monitoring, assessment, and model analysis on the Pacific Arctic Ocean and sea ice, and has built a long-term monitoring network focusing on the ocean-sea ice interaction and its physical process, biogeochemical cycle, and the resulting ecosystem response. KOPRI also studies fishery biological resources and will produce a future outlook scenario on the environmental changes in the Arctic Ocean. In the end, our goal is to operate a web-based database and a visualization system. These are the long-term monitoring points operated in the Pacific Arctic Ocean, and on the right you can see the mooring equipment system where many different sensors are attached. These systems, as you can see here, are moored on the Arctic Ocean for an average of 1 year, and every year we download the data. So we are able to monitor the changes on the Arctic Ocean throughout the year. Most of them are operated in the EEZs of coastal states, mainly the US and Canada. The pink dots, the 6 dots, are sites operated by Korea's Arctic Ocean program. So most of the networks outside the EEZ are led by us, US and Japan. Next, one of the main purposes of Arctic Ocean research is national response to KOPRI, and we carry out research on fishery biological resources. Under the sea ice in the Arctic, in particular near the North Pole in the high seas, it was thought that marine organisms would be very rare. But the Mosaic program in 2019 and Sweden's program in 2021 conducted a fish stock assessment near the North Pole and acquired 6 Atlantic cons and squids to the surprise of the researchers. We do not have a similar program, but based on our own, we are able to do netting, dredging, camera observation, eDNA work, and eco-sounding. So we conduct research on the traps, AXFP, and more for the monitoring. So we are making efforts to acquire fishery biological information. And on the right, you can see the different types of organisms collected over the past 2 years, and we are currently analyzing the information. With the monitoring and observation data from the Arctic Ocean, we intend to produce future outlook scenarios on the changing environment in the Arctic Ocean. Based on the 6th IPCC report, we will improve the previous model that carried high uncertainty and produce a polar improved prediction model. Ultimately, we aim to produce scenarios on how the Arctic Ocean environment will change based on human activities. The observation data from the Arctic Ocean so far have been visualized on the chaos system, as you can see. In step 1, we built this chaos system, and in step 2, we are advancing the system for better user friendliness. So any researcher interested in the Arctic Ocean can easily access the system. In the last decade, our Arctic comprehensive research produced many results, as you can see here. We successfully led a number of international joint research projects with our own, and by carrying out continued science and research activities in the Arctic Ocean, we contributed significantly to the entry into effect of KOPRI, the Arctic's first international instrument. And we built the KAOS system, which is an integrated observation system tailored to the environmental changes in the Arctic Ocean that we share with the world. In science research, we have published more than 70 SI class papers, and in the area of evidence of Atlantification of the Arctic Ocean in the Pacific, microplastics accumulated in the Arctic sea ice, the cause of Arctic Ocean's acidification, changes in the ocean carbon system triggered by freshwater inflow, anthropogenic noise observed in the Arctic, Pacific planktons and phytoplanktons in the Arctic Ocean, and climate feedback on sea ice interaction. We produce many research outcomes. Next, research collaboration in the Arctic Ocean. To address current Arctic issues, a single institution or country independently conducting research is not possible, so research collaboration is essential. In step 1, targeting sea ice, we joined the UK and Germany in the Eagle Light project. And more recently, addressing the Pan-Arctic Ocean, surveying the Arctic Ocean for joint research on the climate and ecosystem under SAS program. The ARC2 program by Japan and EU's Arctic Passion teams are our partners. And in particular, 6 nations, including Korea, interested in the Pacific Arctic Ocean have launched the PAG to conduct research on environmental changes in the Pacific Arctic Ocean and share data through a series of workshops. The past decade of Korea's Arctic Ocean research has been led by KOPRI and RV Araon in an industry academia research collaboration format and research institutes around the world, 30 institutions from 12 nations to be specific. And the projects are ongoing. But IBRV Araon's limited ship type and icebreaking capability indeed very much constrains research in DCAO, which is why we are building a next generation IBRV to be launched in 2027. The new icebreaker will operate at 3 knots and break sea ice much better and will be twice as big as Araon, and will be operable in an eco-friendly manner throughout the year. After the next IBRV is built, we believe that the Arctic research will be able to respond to the upcoming climate change and environmental changes and address Arctic issues, opening up a new horizon of Arctic ocean research. Lastly, we have prepared a video about how Araon has been operated and how it supported research.
이상으로 발표를
Thank you. That concludes my presentation.
네, 발표 진행해 주신 양
Thank you, Dr. Yang Eun-jin, for your presentation. Next, we will hear from Dr. Kim Joo-hong from KOPRI on Arctic warming and weather extremes. Hello, everyone. As introduced, I am Kim Joo-hong from KOPRI. Today's discussion will talk about the weather extremes in the mid-latitudes and the prediction technologies of KOPRI for these abnormal weather events. This is the order of presentation. First, to start with, I will talk about global warming, which is a frequently discussed topic. And this is where the global warming happens fastest and sea ice is reducing rapidly. These changes are not only confined to Arctic area, but it also has an impact on the temperature of mid-latitude regions. So I think this hypothesis is one of the key underlying hypotheses as we do prediction. If you look at the center picture, when the Arctic becomes hot, the polar vortex and jet stream are formed, and it shows how these jet streams and vortex are impacted. On the left, you see where the jet is very quick and strong. In the center, it is curved, which means that the jet stream slows down. If the jet stream slows down and becomes weak, then it means the cold air pushes down from the Arctic to the mid-latitude countries, and the warm air goes up to the polar region, which is an anomaly, weather anomaly. So we need the technology to predict polar vortex movements and jet stream movement, which will be the key. So the major key issues here in this topic are when the Arctic, they're all connected to the Arctic becoming hot, and how this changes polar vortex, and because as the polar vortex breaks down, then the mid-latitude or the Eurasia continent countries experience colder weathers in the winter, and what is important is how well we predict such changes. Based on these hypotheses, we have built prediction models, and let me walk you through what we did. This is a weather climate prediction system model, and it is AGCM based. We call it, in short, KPOPs, our Korean climate prediction model. And we started this effort in 2016 and continued on until today. We kept upgrading the core model, and this is how it looks today. We use this model to predict climate and temperatures mainly in the winter season. So this shows the performance of our current model. I have a couple of graphs to illustrate the performance. This shows how the surface air temperature becomes warmer over the span of 30 years, 1990 to 2020. We are using the current model to go back in time to see what kind of predictions this model would give us if we go back in time. The red line is ERA5, which is the closest model to the actual observance, so I will call it the observance model, and black line is KPOP's model. So let's look at the trend of these two lines. You can see from both of them that global warming is happening, and KPOPs successfully captures that accurately. But in certain years, you can see that versus the actual, our KPOPs model prediction was off by far, which shows the limit that our current system has. And I said an important part of our hypothesis is when we simulate the mid-latitude areas and the Arctic areas. On the left, it's surface temperature, and the red part shows the hotter polar Arctic region, and the blue regions show the Eurasia continent growing colder. So it says warm Arctic, cold continental patterns. And if such things happen on the right left, you will see how the sea surface changes. The Barents Sea and the Russia-Ural Mountains, near those regions, high pressure zones will be formed, which are called Ural blocking zones. And with this, in the mid-latitude regions, colder air is formed. So in the far right bottom, you will see how KPOPs accurately simulates or predicts it, and you can see that it delivers good performance. So let's look at those areas when it's hot. It is our KPOPs models has successfully modeled what will happen in Eurasia, and the right bottom red zone is slightly less than the other zone, but it still shows that the mid-latitude countries are growing colder when the Arctic is growing hotter, and our model successfully captured that and predicted that. But this is the biggest struggle that our model has. It is the weakest spot. If the polar vortex dramatically breaks down, then our model has and is showing some restraints or limits. The polar vortex was strong and captured in the Arctic in the left part of in the left picture. But if the polar vortex breaks down, like you see on the right, it goes down or it gets split. That is a breakdown of polar vortex. And if the polar vortex breaks down, then the mid-latitude countries face colder winters. As you see on the bottom, these are the years where we had cold waves in Korea. And we had cold waves of winter and winter when the polar vortex broke down. This is also another limit of our model. On the far left, in the polar regions, the red part is when the pressure goes up dramatically in the stratosphere. So red is high pressure. As a breakdown happens, the cold air pushes down suddenly, and there's a big gap created in pressure, and that happens when the air pressure breaks down in the stratosphere. And we can predict this air pressure changes, then our prediction accuracy will be very good, but this is a current limit that we have. If you look at the right, our prediction goes well to a certain point, but it doesn't work well from a certain point on. And on the bottom right, it is a worst case where our model did a worse job of predicting. And because of such limits in prediction, if you look in the left, the actual picture shows that when there's such a breakdown in the Asia continent is a blue one, you can see that the cold air wave came down to the Asian continent, but this is when the prediction model did not do a good job of modeling and showed a wrong outcome. So the model failed to predict that the cold wave would go down to the Asian continent. But what would it look like if prediction went well? And we can simulate that in our modeling system. On the far right, you will see the outcome, the desired outcome, if the model did a good job of modeling, and it demonstrates how the climate or temperature would change if in a good modeling scenario. Let's look at this picture. The middle one is a bad example of prediction. And if we realistically model it well, then as we did on the right side, then it actually mimics and is very similar to the actual observance data that you see on the left. So this shows that if the modeling capacity is improved and becomes sophisticated, we can actually mimic and accurately predict what will happen, although it may not happen overnight. Let me talk about the plan going forward. We want to enhance potential predictability. Immediate improvements to predictability will be difficult, but if we switch to a new model, calibration is needed. We need to ramp up that new model. And to overcome the limits that our current modeling has, and to improve potential predictability, we need to be able to have a model that considers interactive processes between the ocean and sea ice and atmosphere. We have a project called sub-seasonal to seasonal prediction. And this is a prediction where we factor in various dimensions, including the ocean, land, and atmosphere. And ocean is a key dimension that we have to consider to improve our prediction and accuracy. And to enhance our potential predictability, we need a model that is able to couple ocean-related data. And I compared the existing modeling systems that we have. On the top, it, it, it shows our modeling capacity and performance. The righter you go, it means that the accuracy is higher, and on the left, if you go to the left, it means low accuracy. We don't have the systems for some systems on some areas, but there are some combination models that other countries have, and combination model is key. Because in these systems to predict the Arctic, but ours is atmosphere based, and on the red ones we did develop quite good systems to predict. So against the world performance, we are about there 40%. We will bring up this 40% so that we are at 16, 70, and 90% against the world performance and these other world's prediction models. So on the center, we have the prediction system, and we need a systems to input the observance data. We would call it data input system. And we have to now translate that language into a easily understandable language. And when we do prediction based on this, the potential prediction capability to yield more accurate results will be improved. Lastly, when we think about observation, on the polar side, observance is still very limited. It only covers a couple of satellites. There are not many on-site field observation systems. I think a key task that we have to work on is to strengthen and improve our observance system on the polar regions and use it more frequently. For example, we need to expand from the observance that we did on our own, and if our next RV is of course built, we'll be able to expand. And unmanned observation needs to happen more, and through a more active international cooperation, I believe having a sustainable observance system in the Arctic is very important, and we would like to contribute to that. And the observance system is of course important and matters, but that observance system has to be connected with a prediction model to make a key difference. So far, we created data and we took it home and did analysis, but having real-time connection, a data feeding and data prediction based on such data connection is another inspiring area where we would like to work on and our direction for the future. This is it for my presentation. Thank you.
네,
Yes, thank you for presenting what can be very difficult content in easy to understand manner. Thank you very much. And next on the topic of monitoring and future prediction of Arctic land atmosphere coast environmental changes, we have Dr. Choi Tae-jin. Hello, I am Choi Tae-jin from KOPRI. I would like to present our activities based on permafrost on the land of the Arctic. I'm actually not the lead researcher of this project, but thanks to many colleagues who helped me out, I was able to prepare this presentation. As you heard before, global warming in the Arctic has been intense, actually 4 times faster than the rest of the world. And such warming in the Arctic leads to a release of large amounts of warming gases frozen into permafrost. And this can seriously accelerate global warming. And also, Arctic warming will lead to coastal erosion, which may impact the lives of indigenous people. And we must understand the climate in the Arctic. And to understand the future environmental changes in the Arctic, we must go back in time and look at the changes of the Arctic paleoclimate. And so from these two perspectives, we are making various efforts to understand the climate in the Arctic. And this particular project has been conducted on the permafrost and fjord environment. And what kind of extreme events may take place. We have developed the observation system. And based on the high quality data, we want to predict the future. And we also want to secure technology to reconstruct the paleoclimatic changes from the fjords since the LGM, glacial retreat on Svalbard archipelago. As you can see, this is the changes in the vegetation across the Arctic. There are 5 major sites where we can divide up the vegetation. At around 2 degrees Celsius on average in July, that's where the vegetation changes take place. And going forward with climate change proceeding, we may see greater changes in the vegetation. And on the right-hand side, this is the 50-year outlook on the vegetation distribution, and you can see great changes coming our way. This diagram shows what our team does, how different research connects to one another. So we can build an observations node on the permafrost to do research on the flux of the greenhouse gases and how microbial activities take place and how the earth cooling aerosol interacts with the earth. And all this will be linked with the satellite data to look at the changes in the carbon system. Using the research vessel, we can conduct coastal research to restore paleoclimates. And based on the observation nodes, from the soil samples, we can look at the biological resources to look at the potential of further development of useful research and how the melting of permafrost can impact the mid-latitude or mid-latitude climate. So this has started in 2011, and currently we required a lot of administrative support, and it took a long time for us to carry out the different phases. And in time, we were able to secure more data. And based on the observation nodes, we began our research in full swing. So these are the 6 observation nodes. First, we have the Alaska node, and then one in Cambridge Bay, Canada, and starting on the left-hand side, and then in northern Greenland, and another one in Iceland in Storhofey. And we have, of course, our own station and the ARI in Russia. So all these nodes are placed in the Arctic states, and therefore we have to conduct a joint collaborative research with these respective nations. And along with Korean experts, we also conduct joint research. Changes in the Arctic permafrost, simply put, means that when the ground temperature rises and the upper layer of the permafrost deepens, active layer deepens, and this will lead to organic matter that thaws and is released into air, which will increase the atmospheric concentration of CO2 and methane and other global warming gases, which further increases the Earth's temperature. According to different models, as the Arctic warms, with organic matter being decomposed in the permafrost, this may increase the Earth's temperature by 1 degree, but this is just a modeling outcome and therefore is highly uncertain. As for carbon concentration level, which remains uncertain, really depends on the uncertainties of our modeling, and therefore we must conduct field research. So field research, modeling research, paleoclimatic research, and research conducted with useful organic resources are the 4 major resources. First, in Alaska, Council Alaska, we look at the CO2 exchange measurements and snow manipulation experiments and greenhouse gas flux. LED sensors also measure the different levels of the atmosphere. And we also do a snow manipulation experiment that looks at the soil temperature and soil moisture, as well as the interaction between the greenhouse gases and the soil. Next, in Cambridge Bay, which is about 10 degrees up north than Alaska. We also look at the greenhouse gas flux between the atmosphere and the permafrost. And in 100 years' time, if the global warms further, we do believe that the permafrost will be lost more. So we have the open top chamber, as you can see on the bottom right, that is only opened on the top. And we give regular water to the plant to manipulate to simulate an environment where there is regular rainfall, and how the CO2 flux impacts the vegetation. In permafrost in Canada, there are many ponds and lakes. These ponds are spots where CO2 in the atmosphere can be intensified. And in this observation node, we look at how in a pond, how much GHG is emitted. So we use these chambers on the pond to measure the volume. In Svalbard, we have an observation node near our Dasan station. In Zeppelin Station, we have many aerosol monitoring equipment to look at the biogeochemical properties and also the characteristics of aerosols. At the higher altitude, we have the Greenland observation node, where there is hardly any vegetation. But recently, we do see some signs of vegetation scattered across this region, and we conduct similar research here as well. In Iceland, Strofoy, we have another observation node to look at DMS, a main cause of aerosols, and how DMS impacts the global climate. And lastly, in Russia, Baranova, we started research, but because of the geopolitical situation, our observation there has been put on hold. In Svalbard, we are conducting research to reconstruct the paleoclimatic environment. And through this project, we have been obtaining great outcomes, and based on these nodes, we are able to secure environmental factors that are built into a database to look at the changes in the permafrost environment and what kind of processes are taking place. And the Arctic research, such as these, for example, about the chemical properties of aerosols in the Arctic, we can also better understand the PM in Korea. And our own changes in the Arctic impacting Korean climate, which is our own research, this is better enhanced by what we do in the Arctic, and this all contributes to Korea's performing better as an observer state. All these data are shared on KPDC, our KOPRI data center, and the data is shared with many. And just for example, in Alaska, the very first observation node, every summer we look at the vegetation, how how much and until when the vegetation absorbs CO2. This study is conducted every year, and we do have a certain level of database, and we are now looking at wider research of how much CH4 is emitted. And we submit data to international journals to better understand the properties of the vegetation in this region. As you can see, in the circum-Arctic region, not only Korea, but in many countries, in the permafrost, we look at how permafrost whether absorbs or releases GHG. On the graphic, it seems like there are many observation nodes, but in fact, there are very few. And by being a part of such international research efforts, our data is also shared with others to see where exactly carbon circulation is changing, and in relation to climate change, this can be a good source of information. This shows a combination of satellite data and physical best polar model. So we looked at how much carbon has been absorbed or released in the Arctic permafrost from 2020 to 2021. If you look at the simulated results, the total primary productivity went up by a large degree, and so has ecosystem respiration, but not as much as the GPP. From 2001 to 2021, in fact, CO2 has been absorbed more. The amount of CO2 absorbed by vegetation in the Arctic has increased. There are also research on the Arctic microbiomes, looking at the microbial groups and communities and how carbon emission or absorption can happen in relation to these microbiomes. This research has led to a slightly different type of results than previous research. We are interested in how permafrost freezes up and is melted and makes lakes and ponds, and how this can contribute to climate change. But the research shows that water lost can make permafrost contribute to the CO2 in terms of microbial perspective. So with the drainage, the modern soil carbon contribution will be increased, but in fact, where methane was previously released will actually start absorbing methane. And on the bottom, you can see that the permafrost melts, and in the lower layer, we expected the microbiomes to be decomposed and contribute to climate change, but actually the drainage can further increase the concentration of GHG in the atmosphere. And we have multiple research on aerosols. In 2007, the DMS, ever since the assumption that DMS may contribute to climate change, we have conducted many different research on DMS, and we found that because of the microalgae in the ocean, leading to the increase of DMS in terms of the size of clouds and also nanoparticles, and also the concentration of CCN, had a huge impact. And we found that the assumption was true. And on the bottom, you can look at some of the photos by Araon conducting field survey on the aerosols and using chambers to see how aerosols are formed. This is paleoclimate research in Svalbard, looking at how 16,000 years ago and up to now, how the ice has retreated and advanced. By reconstructing the paleoclimate and using the modeling, we also conduct research, and going forward, IPCC will be looking at the vulnerable sites to climate change, and we plan to conduct a more detailed research focusing on Korea. And lastly, research on utilizing bioresources from the Arctic are also underway. We look at the development of cold active PBACE from psychrophilic soil bacterium. And we will be looking at vegetation that can withstand the cold and droughts as well. Thank you very much.
Thank you, Dr. Chetejin, for going through a very detailed presentation. Lastly, we will hear from Kim Yeon-chul from KOPRI on remote sensing and its future. Hello, everyone. It is a great pleasure for me to present in front of you with masks off. It's nice to see you. As you have seen in previous presentations, especially in the Arctic and polar regions, the change in glaciers is very important, and I think we all feel that way. So as I start off my introduction, I was actually planning to talk about glacier changes, but rather than that, I would like to start with some key points that we need to remember about glacial changes. Glaciers are mainly only observed via satellites, and such observations are connected and used with other industries. So we think that the satellite data is very credible, but in actuality, there are a lot of uncertainties regarding satellite data as well. So our research is focused on improving the accuracy of satellite data and its reliability, and that is also the theme of my presentation as well. Monitoring the polar regions from space is a key pillar of our research, and I will specifically talk about how we predicted the thickness and how we improved it. Why is the ice thickness, important? I think many people know about the area, the scope of sea ice, but if we see it from the perspective of thick ice melts slower, then if we understand the thickness, then I think we can have more accurate models and accurate input data into the systems, because thickness is a key dimension as well. Sea ice thickness is also relevant to other environmental topics as well. So as suggested in recent research, ice thickness impacts other fields of academia and climate changes. As you see in the left picture, the average thickness of glaciers is about 2 meters, and this thickness differs region by region. In Greenland and Canada, that is the red part, you can see that there's multi-year ice, which is thicker, and in Siberia, the multi-year there is a bit thinner. And while there's diversity in the spatial distribution as well, but we also see diversity, if you see there below, the sea ice thickness is also changing dramatically. Recently, the thickness has halved, and the lighter colors are observance data gained from submarines, and versus that, the satellite data actually tells us the thickness is half of what the submarine data tells us, and all in all, we can tell that the thickness is decreasing rapidly. While we are aware of the importance of sea thickness, we are also making efforts for that end, and U.S. is also making efforts. They have a laser-equipped satellite to measure thickness, and it has a very little margin of error, so it's very accurate. But because they use lasers, clouds affect the performance very much. So their observance scope is very small. On the left side, you see the line which defines the scope that this laser-equipped satellite is able to observe. But on the right, you will see the concentration data that we can apply to wider regions of the Arctic, and also can go up to 20 years in the past. We have that data. So if the AMSR-based data and system, if we use this more, we believed that we could do research that improves the thickness of sea ice. And we use 4 channels of AMSR, and we also looked at ice type data from OSIS AF and the measurements of freeboard. We call it not thickness, but rather freeboard, because there's a limit of not being able to measure the actual thickness beneath the surface, which is the cause of a wide error of margin in the previous systems. But for ASMR, it has prediction capabilities that can yield accurate freeboard results, and through OIB, we are able to have more accuracy in freeboard. This is a plane equipped with a laser to do the measurements. So benchmarking of all these data and pulling all these data, we saw and checked how accurate our research is. This is quite simple. The error so far occurred because we premised the prediction thinking that ice is composed of only one ingredient, but there were various physical science related events that happened inside the snow, which gave it more diversity and diversity in components of snow. This really messed with the accuracy of our prediction, and we couldn't accurately measure sea ice. So we looked at the gap or difference and how light permeated differently and penetrated differently between the ice and the snow in this freeboard. And under this concept, we approached with a mathematical formula and developed it. We mostly use GR values in this mathematical formula, which looks at water and the ratio between snow versus ice. And on top of this, we projected the accurate freeboard values and measurements that existed, and we applied the regression equation as you see here, coefficient A and coefficient B, and we built this formula which is built on the regression equation. It is a statistical value based formula, and for each month from November, December, January, February, March, to cover these 5 months, we built 3 formulas to give us values, and these are the results from November to December, and from 2019 to 2020. These are the trends in freeboard or thickness of sea ice, and we saw how our values match or are off versus compared to the OSIS values. Ideally, it should be 1-to-1, and our values were about 0.9, which is 90%, and quite high accuracy. And because we used relevant data, our performance was good, but we wanted to re-evaluate the data and performance. And before I go into that, let me tell you how relevant our data can be. This is a spatial distribution from 2018 to 2019. On the top, you see ICIS data, and on the bottom, it's our data. As you see on the top, you will see a lot of white areas, and these are gaps. And in our model, however, you can see most of the white gaps have disappeared, while the spatial distribution data are quite similar across the two. This shows that our formula is quite relevant and accurate when we check against real data. And for seasonal changes, they are well incorporated into our formula as well. Not only for the time frame of 2018 to 2019, but we also did the same for the time frame of 2019 to 2020. And while the spatial distribution is very different, winter versus spring and summer, but the recreation went quite well. As you see here, the two data sets are quite similar, but we were able to produce a data set that has greater recreation capabilities. And to verify whether we recreated the past successfully, we looked at OIB accurate data and checked our data against the OIB data very accurately. And on the left, you can see the results. It's data from 2013 to 2017. OIB was not done, research was not done periodically, so there's a little bit of bias regarding space and time. So there is a bit of a scant in the graph that you see. OIB's accuracy versus our data, if you compare these two data sets, you can see that the accuracy is within the valid range in terms of statistics. So our data system, I do believe, has brought about big improvements in the prediction of sea ice thickness. It does not end with measuring thickness in winter season, but we want to utilize it to recreate and predict successfully the ice thickness in summer. So far, we weren't able to do the job well even for the winter seasons, so we were not able to even touch the summer sea thickness measurements. But going forward, because we have now good ground on the winter sea thickness measurements, we now, I think, do have the foundation to look into summer sea ice thickness as well. This ultimately will have a lot of implications for climate change monitoring and research. There will be a lot of expanded applications from sea ice thickness measurements to other applications. I believe we contributed to providing more ground data on this, and sea ice thickness measurements should help in producing more accurate results and values for climate changes and other challenges that we face. And I think this is an efficient research or effective research that we did. And the sea thickness predictability and predicting technology could be used in this application as well. For the recent years where we use satellites to predict sea ice thickness, our research was mostly following in the footsteps of advanced countries, but the technology and our system that I just talked to you about today is actually one of the world leading technologies, and I believe that we are becoming closer to leading the polar technologies here. Korea will be able to design and push forward and pioneer projects in this polar technology field going forward. I'm sure many of us are concerned about the environmental changes happening in the polar regions, but on the other side, it now boils down to how well we can respond to such changes. One example is the northern Arctic route. If we can accurately recreate and observe the thickness in sea ice both in summer and winter, this means that when it comes to sea routes, we are now able to gain very accurate perspective and insight and visibility into those seas, and it will greatly impact and help the sea route development. And that is why our infrastructure and research will be utilized to great lengths. So let me summarize my presentation today. We have utilized existing data sets to add on and reiterate our prediction model, which gave us more accurate results. And I believe that these can be applied to other various industries going forward. Thank you very much.
해빙 연구
Thank you for the sea ice research current status and prospects using remote sensing. Thank you for listening to the presentation. So that's all for the presentations, and we'll move on to the discussion session. On the 4 topics addressed so far, with the chair, Professor Lee Ki-taek from Post-Tech, we will start the discussion, and I'd like to now hand over the microphone to Professor Lee. Thank you. I am the chair of this discussion session. I am Post-Tech Professor of Environment Sciences. My name is Lee Ki-taek. I would like to thank Professor Kang Sung-ho for inviting me to moderate the session. And I would also like to thank everyone at KOPRI for putting together this event. I think the most important purpose of this discussion is for KOPRI to conduct research that is supported by the Korean people and to also produce results so that all the Korean people can understand and know the results of KOPRI's research. So to that end, we will look at the different research areas and in areas in general of what the plans can be. So we will have two rounds of discussions. First, on the four presentations we heard, we also had the keynote speech very briefly by Vice President Shin Young-chul about the past 20 years of research in the Arctic by Korea. So regarding the current status, I'd like to ask the panelists to share your views and your general assessment of how the research is being done and going forward, how research can be conducted. So that would be round one. And for round two, we will address a larger picture. For example, Arctic science research discourse. What kind of research needs to be conducted? What type of research and survey should be addressed for KOPRI to be known across the country? Recently, KARI really placed itself on the map by launching a space rocket without the need to persuade the public for the need of KARI. KARI made itself known very well. And are there similar research topics and activities at KOPRI? So in this context, we will move on to round two, and I would like to ask you for your comment on this topic. So starting with round one, for each of the given topic, please share your views. Starting with Professor Lee Sang-hun from Busan National University, please give us your views on the ocean. Professor Lee used to work with KOPRI. Thank you. Good morning. I am Lee Sang-hun from the Busan National University. In terms of research and at heart, I believe that KOPRI is really my home. So KOPRI needs to do well for all the members and previous members of KOPRI to do well as well. So I've listened to the four presentations and I was able to feel how much KOPRI has grown in the meantime in terms of the content we heard. So I'd be very brief. And in short, I think I could say wow. Because back when I began, KOPRI, as Vice President Shin Young-chul described, was only big enough for one or two researchers to be sent away to board icebreakers. And later on, we felt the need to build our own IBRV that led to Araon. And so in the initial steps, we were not able to conduct our research. So we had to go through much challenges, but in the decade that followed, we consistently conducted research in one area, and in worldwide, I think it is a very rare case. So in terms of government funding, there was much support provided to KOPRI, and the researchers in the Arctic were strongly committed to continue on their research, which made all this possible. So since 2005, 500 different papers have been published on the Arctic by our researchers, which is really a remarkable number, as the president has said earlier. So kudos to all your achievements and all your ongoing programs, and I really don't have anything in particular to add. So in just one area, in Chukchi Sea and East Siberian Sea, you have conducted 10 years of research. based on the various programs and experience, I do believe that you have set up a milestone. And I think that all your work for the Korean people and to other researchers demonstrate great results that have been reached after a long period of time, but I don't think that the results have been known widely enough. So please be proud of what you've done and promote your activities, for example, by publishing your books based on the key achievements. So in terms of PR, I think that KOPRI can do more by publishing pamphlets or books. And after 2027, the next generation IBRV will lead the way. KOPRI's researchers believe that their research is quite limited with Araon, and now that the research has become much bigger and too big for Araon, we need to make more investment and more time on a wider region. And I think this is why we have come to the plan to build the next IBRV. But once the next IBRV is built, you need to set the direction of research ahead of the IBRV. So are you going to use the new IBRV during a short period of time in a limited area only to conduct research? I don't think so. So preparing for the next decade to come, please have a far-sighted vision in mind. Thank you.
네, 감사합니다.
Thank you, Professor.
So you mentioned that KOPRI should focus on public PR on the great achievements. And for atmospheric part, I'd like to invite Professor Kim Bang-min of Pukyong National University.
제 마스크를 좀 벗고.
Let me take off my masks. Thank you. It has been about 4 years or 5 years since I left KOPRI, and even in that time frame, I noticed you made astonishing achievements in terms of research despite the difficult times. And as a member of the Korean citizen, as a citizen myself, I would like to thank KOPRI. I think infrastructure is key when it comes to polar research, because the polar regions are new areas where we need to identify new science technologies to lead new science. And that is, I think, the biggest calling that we have in the polar regions, so infrastructure matters more. And with the development of infrastructure, KOPRI also developed and made advancements. It built the King Sejong Station, and after we laid down the foundation like that, after Dasan Station, we are pushing the boundaries of polar research. In the photos that Vice President Shin showed us, we also saw President Kang, where he went to the Arctic for the first time, and I think this is also a great memory to have. And through KOPRI, I saw the clouds and many events in the Arctic, and I saw first-handedly the formidable impacts or effects of climate change in the Arctic, which motivated me to do research, which bore fruit, and I think that kind of research effort is continuing. Aaron also pushed our first boundary in polar research, and now as we are going to have the second IBRV soon, it should also play a role of adding more values to our research. Going forward, our research should really capitalize on these large-scale infrastructure, and we should think about what we want to do with these infrastructures. These large-scale infrastructures mean that we want to capture and observe the diverse environmental situations in the polar regions. And as a man living on Earth, there are areas about the polar regions that we do not understand, for example, the atmosphere and the clouds and ice of the polar regions. And these infrastructures should be optimized to observe and understand these uncharted territories of the polar regions. Listening to the presentations earlier, I think we are definitely headed in the right direction, but I really want us to focus more on newly developed or new infrastructure to come that we need for new and better research and for us to engage in global science better. Lastly, as for the atmosphere topic, I want to share a couple of comments with you here as well. In research regarding atmosphere and air, one noteworthy area is, as it was with the last government, our R&D effort and capacity in this field also increased. And with this trend, the usefulness of our research and the practicality is a key value. Now, I know that practicality in research is very important, but as an advanced member in research, science research in the world, I think KOPRI should exert more efforts in this effort, academic research and academic excellence as well. And I think academic excellence is more important than practicality in some ways. Improving accuracy so that it's more practical and applicable, those values are appreciated as well. But I think at the same time, being the first to understand some polar circumstances and events in the atmosphere or climate, which is more closer to the basic research part and touches on academic excellence, is also a value that we have to keep in mind. Thank you. Professor Kim Baek-min, you just talked about how we utilized our Dasan Station, our own and Antarctic Research Center to improve our research capacity, and academic excellence was a key suggestion that you made.
And from KIST Green Technology Center Korea, we have President Lee Sang-hyuk. Up next, Dr. Lee led polar research under the national project. When you go to other academic seminars, I think that you see most of the people here, but I don't think that any of you have met me before, and my area of expertise is engineering. And as Professor Lee has mentioned, in terms of polar research, I'm really not at a level to be here as a discussant. But I used to be the energy environment group leader for 4 years. And during that time, in the polar research sector, there is no equivalent research group. So because energy research group is involved in different parts of our lives, I was also given the role to lead the polar research area as well. So for 4 years, I was in charge of planning and budgeting, and I met with KOPRI researchers, and I had such a great impression. And so I was determined to maintain this good relations, and if I'm lucky, maybe I can get on Araon for free. I don't know how much you can see on the screen, but with KOPRI, every time I had a planned project with KOPRI, every time I saw the globe, I felt like I could identify with the world, because as you can see, at the top of the earth, there's a empty round circle like my head. I did not do much research in the polar region, but during my 4 years, what often came to mind was that, well, if you have children, you might read an English book to your children so that they can learn English. It's a very famous book. And when the polar bear goes out into the world, listens to different sounds, the polar bear learns how wide the world is. And when I read the book, I felt that the author was very strategic, because he, I think, had also the climate change in his mind. Because later on, we have to think of what do you see, what do you smell, and what do you eat. And I thought that we may see some different series of polar bear books, but with climate change, the title could change to Where Are You? So, listening to the environment presentation, as permafrost melts, methane and CO2 will be released into the air, and they can also cause particulate matter. In my days, the Arctic, the polar regions, and the other regions seem to be two different places, but now I feel like all these regions are connected. With climate change, well, my Green Technology Center Korea is really not known among Korean citizens or even researchers. But I think that with the polar research going on at KOPRI, KOPRI will be better known to the public. And so along with KOPRI, with carbon neutrality plan going forward, Green Technology Center, I think, also can receive more attention from the people of Korea. And as the center's head, to prepare for carbon neutrality, I do feel like I should put the center at the top of everyone's minds. So in round one, what I want to say is that someone like myself who is not well versed in the Arctic, engaging in Arctic research, was able to learn that the Arctic and the rest of the world are connected. The world, the air, and the Arctic are all in one, connected as one. President Kang mentioned before, as he smiled as he went on into the Arctic, I really learned that you are able to smile at 40 degrees sub-zero. So with climate change, as the Arctic is melting, permafrost is melting, releasing more and more greenhouse gases. And with this scenario, with the perspective that we are all connected, KOPRI should go ahead and set forth a new direction to conduct more comprehensive research to be closer to the public. And looking through the presentation by Professor Peck, I learned that the photo of the polar bear is actually taken in person. And I learned also for the first time that polar bears can actually rumble this way and that. You were conducting research in a very narrow area of the Arctic, but if you can expand that scope to the entire world, then I think that KOPRI will be better supported by the people and will be a place that's even more essential to all scientists. And because KOPRI plays a very important role, those of us engineers working on ground and the atmospheric experts working in the air, if you can encompass all of us as a central point, it will be much appreciated. So do we also have round two? I understand. Thank you. I was laughing so hard from your comments that I was not able to take notes of all of your key points. But what was good is that you are willing to interact further with KOPRI. And I was able to learn that KOPRI successfully persuaded Dr. Lee, at least, for the need to conduct Arctic research. And I think that as long as PR is done, we will have no problem.
Lastly, on ice and glaciers, we will hear from Professor Jo Young-han from Busan University. Hello everyone, nice to meet you. I am Jo Young-hyun from Busan University. I use satellites a lot as part of my work, and before I came to Korea, I used NASA satellites to do a lot of research. And as I came here, I looked at this leaflet and flipped through a couple of pages, and I saw that the young generation I see in this leaflet, I felt that they must have had a lot of challenges in their journey. We saw the history of our research And it seems that through various trials and errors, the young generation, the young scientists of Korea made the journey. And in Korea, you know that even though we don't have a lot of resources, we work hard to deliver more results. And for young generation, I hope that we can make the math better so that they don't have to yield that many results with so little resources. And even now, there are a lot of people who work despite little resources or little help, but there are ways to certainly improve this. For example, for KOPRI's like supporting systems and mechanisms, if those things are more rolled out, then human work and human research or the burden on the scientists and researchers become much less. And this will free up our manual resources to invest more in more key priorities with more passion. So in terms of human resources wise, I hope that we can add more resources to our research institutes so that we don't have to work with so little. And of course, I also want to talk about budget. Budget kept scaling down from for say 100 over the years, and the budget slowly decreased over time. I think, but for when it comes to budget, it's important because we base our research plans based on that. For example, we thought we'd have 2 satellites available for our use, but because the budget was smaller, we could only utilize one satellite. And another comment that I would like to share is that while KOPRI publishes a lot of data and papers in the US, they give these kind of data or information to students and make the students or the professionals compete. So I think we can benchmark off of that, and if we disclose and make public the information and data that KOPRI has, and have an award for competing for these topics and researches, then I think positive engagement with the private sector can be fostered. I'll speak more in the later sessions. Thank you very much. Professor Jo Young-han made a memorable comment for me, which is for 20 years, the research has been very hectic, and that it is time for us to take stock of our past efforts and recalibrate our priorities. I fully agree. The second part of this discussion will be similar. It's not that much different. It's about the future. KOPRI will exist in 20 years and 30 years into the future. And in light of that, what should KOPRI do in terms of research or other activities so that we can actually come closer to the lives of the Korean citizens, so that we can also have bigger and greater support in terms of budget as well? Please share your comments on this topic, and I'll give you 2 or 3 minutes each to give your perspective on this.
Yes, that was a difficult question. Well, if I knew the answer to that, then I'd be really a guru. What the chair has mentioned, I think, is about not only the KOPRI members, but those of you outside the KOPRI who give us support should together consider the matter. Polar research is getting bigger, but the manpower in not only polar research, but in ocean in general is getting smaller. So the government has conducted for multiple years projects to build capacity, but next year, unfortunately, this project comes to an end and moves on to another sector. KOPRI is a leader of polar research. Co-work and collaborative projects, I wish we had more of them. But even if the KMI program comes to an end, if KOPRI is able to provide more support in these areas to students studying the ocean or the polar regions, I think could be very helpful and useful. Thank you. Thank you very much. So to summarize, we need to be realistic in attracting good talents by running at least a small program, which can be a start for KOPRI to gain greater stability. Thank you. Professor Beck, I think you should take the floor for 3 minutes.
From my standpoint, climate change is the biggest issue and a shared interest across the world. There are many people in the general public that don't know that climate change is most severe in the Arctic. Many people don't know this fact, but it is very serious. So I'm sorry to keep bringing up my research and studies, but one noteworthy point about my research that gained attention was that compared to the past, even in a single day, in the Arctic, there are 20 degrees or 30 degrees temperature rises. And that happened in the early 2000s. And that is why my research gained attention. But these days, it has become quite stable. The temperature kept rising in the Arctic for quite a long time. And as a keen observer of what happens in the Arctic on a daily basis, I see that the temperature rise trend has stabilized. And I think now it is because the Arctic is stabilizing, it is also a good time for KOPRI to take stock of our past efforts and recollect ourselves to do better preparation for the future. And the same is with the Antarctic. There isn't a problem. It's not as if there's a problem on a daily basis. It has ups and downs, but unless you're prepared, you cannot respond well to when a problem happens. For example, I heard that many airplanes or devices were not able to land on the Antarctic because the ice was so thin. And if we were on top of these changes and things, we can communicate of what happens to the what happens in the Antarctic to the people in a more timely manner. As the people who research on the field of the polar regions, which is at the forefront of climate change, our responsibility is to communicate the polar regions to the people frequently and in a clear manner so that the people realize that polar regions are, while they're geographically far away, are not conceptually and palpably far away because they have such a great impact on us. It is going in the right direction because polar regions are being featured in news articles more, and using the infographics or visual means, we are trying to come closer to the lives of daily people, and I hope we can work more on this. Thank you. That's it. Thank you, Professor. You said that for key environmental issues, especially the climate change issue, researchers should prepare more well in advance so that when a problem or a key issue or incident happens, we'll be able to brief about the incident in more detail and communicate it to the people so that our Korean people can realize the importance of KOPRI. Thank you for your comments.
And next, Dr. Lee. Yes, I think I'm the only one here as a citizen, in the capacity of a citizen, and as an ordinary citizen looking at the Arctic, and also someone who has known KOPRI for 4 years. Well, I would like to give you a fresh external perspective. As an ordinary citizen, when I hear that the polar regions are melting, the sea ice is melting, I didn't really know what impact that has because I live in Seoul, so I wasn't aware of what impact that would have. But last week, President Kang Sung-ho mentioned that the airstrip in the Arctic melted away and was lost. And he showed me a cell phone picture of that airstrip, and that was really eye-opening and very scary. And that was the first time I felt that the sea ice melting is a very, very serious issue in the Arctic. And I wasn't really aware of how serious the issue was, but looking at the cell phone photo, I felt like I had to do something about it. For KOPRI to gain more public support, I think that in the age of climate change, you can think of how you can reach out to the citizens. And my personal thought is that while I conducted many different planned programs, with KOPRI, I felt like you had a number of different infrastructures built by engineers. So engineers were essential for KOPRI. And I felt proud as an engineer myself. Although I'm not usually very proud of being an engineer, I think that technology can be a means to deliver science to the general public, and I think engineers are the ones who develop the technology. So KOPRI looks at very limited scope of geographically very limited scope of area in your research with a limited number of researchers. But I do believe that your research can be supplied to different scientists, and you can think of what type of different collaboration you can pursue with these researchers so that KOPRI's research in the Arctic and Antarctic can be better delivered to the citizens. And I wanted to coin a new term, combining polar science and engineering. So, pol sci engineering. No relation to the singer. So, Arctic science and Antarctic science should be known to the public that they're very important, and changes taking place in polar areas are very important and has an impact to our lives. So I suggest that you create a link. And globally, the trend of technology is convergence. But if you ask engineers what they mean by convergence, they don't really know. They just think of convergence as mixing different things, but that's not it. If you can build a route of science from the Arctic all the way to us, then maybe the people will be better aware of the need to save the Earth. Thank you. Science combined with technology and PR to the public through a outreach program, that is where KOPRI may probably focus on.
교수님께서
Lastly, Professor Zhu, please share your comments. Thank you, Mr. Chair. I will talk about 2 points. When I cannot fall asleep at night, I have a ISS app, the space station app, and I turn it on and see what it shows me. It has the footage of the satellites passing over land and sea, and this footage is very peaceful and sleep-inducing. And when satellites by KOPRI go up, in the ISS is unable to observe the polar regions. It has a latitude limit. But of course, not all of our population will be able to see it. And it doesn't have to be real time, but there are some people inside Korea who watch these footages and also aurora light videos. So I think having these apps where more general people can access and see the space will be very useful. Our world population has reached 8 billion recently, and half will be 4 billion. So some, at least some and a couple of people may look at the footage at a certain point in their day and make an outstanding discovery. That is one possibility. So let's try to have more accessible apps. And secondly, the deep sea is an area where the satellite research is focused. So if we can expand the scope like that from the polar region, it will be great. A lot of integrated researches are underway, and I think we can collate those researches into an algorithm to clearly understand the causal relationship from space to deep sea. I think it's one idea. Thank you. Thank you, Professor. Of the words that you mentioned, that is actually the most memorable thing. You said from space to polar. Not only that, but from space to deep sea. I think that's a good catchphrase. Thank you very much. I would like to now close the session with my final remarks. If I look at the leaflet, in 1991, after the paper on polar regions was published, there were 0 achievements or deliverables up until we established Dasan Station. But after we established Dasan Station, Arawan was built, and our research achievements and footsteps significantly increased. As was mentioned in the discussion, our research platform and infrastructure is key and crucial to and directly linked to research results. And thanks to the hard efforts and hard work of our researchers and scientists, the recent growth in our scientific areas happened in the recent years. But going forward, I think quantitative growth may not matter as much, because that is a global trend, and the size of our research institute or station cannot keep growing. The research center, for example, cannot keep growing in size. But as Professor Cho said, we need to now take this time to recharge, and the researchers need to brainstorm about key research topics to flesh out the research themes that are accessible and understandable by general people, and I hope KOPRI becomes better in doing that. Thank you.
네.
Thank you, Chair and all panelists, on behalf of KOPRI. And in particular, Chair Igitek, for your wonderful moderation of the session. We were able to look back on 20 years of Korea's Arctic activities and research outcomes, as well as seek future directions. What was discussed today will be incorporated into KOPRI's policies and research plans going forward. I'd like to thank all participants and viewers for staying with us. And I wish this is the end of the event, but now, as previously announced, we will celebrate the 20th anniversary of Dasan Station with a book launch event. Please stay with us a little bit longer for this special session. And after this special session, we will go to lunch. And marking the 20th anniversary of Dasan Station, Arctic researchers and visitors share their thoughts on the Arctic and the station over the past 20 years, written into a book of essays called The Arctic, A Record of 20 Years. Before the book launch, let us watch a video from key stations of Norway, Germany, and more in the Allison, congratulating the 20th birthday of Dasan Station. Here is the video, and then we will move on to the book launch event.
Start. My name is Rune Jensen. I'm the leader of the Norwegian Polar Institute in the Ocean. And I would very much like to congratulate KOPRI on its 20th anniversary since establishing the Ocean. I hope to see several South Korean researchers coming to the Ocean in the coming year. Congratulations again. Thank you.
Dear Korean Polar Research Institute and Arctic researchers. My name is Heikki Lihavainen. I'm the director of SIOS. This is the 20th anniversary of Dasan in Ny-Ålesund. That is an accomplishment that deserves to be celebrated thoroughly. Dasan and Korean research activities are an integral part of the Ny-Ålesund research station. Now you are also contributing to the observations of Svalbard Integrated Arctic Earth Observing System together with our 28 member institutions with research activities in and around Svalbard. Together we can unleash the potential of Arctic research and be the leading long-term observing system in the Arctic to serve Earth system science and society. Cheers to achieved glories and ever-increasing success and friendship. Greetings from Svalbard.
Okay, let's start, please.
20 years Dasan institution here in Ny-Ålesund. Congratulations. My name is Isabel Schulz. I'm the current station leader for AVIPEF, the French-German research station here in Ny-Ålesund. And it's great to have you here in Ny-Ålesund, and I'm wishing you many, many more years here in Ny-Ålesund and lots of collaborations, lots of good research. All the best.
Thank you.
20 years of Dalan station in Ny-Ålesund. I have been seeing 8 of those, and I've been always very glad to cooperate with KOPRI. I'm a station coordinator from the Big Institute for the AVIPEF station here, and good luck for the next 20 years at least.
Okay, your name, please?
I'm Verena Mohout.
Okay,
Thank you. Okay, please. Let's start.
Okay, so I'm Ombretta dell'Acqua, the Italian station leader, and I'm very pleased to have met South Korean people from KOPRI, which I already met in Antarctica. But now I want to congratulate with them because they are able to celebrate the 20th anniversary of the Dasan station here in Ny-Ålesund. So they are, as they are part of this community, and I'm very glad to be able to meet them again here in the opposite side of the world. I'm so pleased. So thank you for having me here with you.
네, 영상을 보내
Yes, I'd like to thank everyone for sending us the video message. Myself and the International Cooperation Division head went to the Arctic, and we ourselves took the recording. So I ask you for your kind understanding if the video was not of high quality. And now we will start the book launch event for the Arctic, a record of 20 years. Let me briefly introduce the book. We've placed the book in front of you. I ask you to read through. This book is launched in celebration of the 20th anniversary of Dasan Station and is a record of Korea's Arctic research and the station itself. The beginning and history of Arctic research by Korea, the entire process leading up to the establishment of the station, achievements of dedicated researchers, and stories of visitors are introduced in this book that records the 20-year history of Dasan Station. The book consists of 19 stories on 5 topics: beginning, encounter, research, advancement, and togetherness. From the starting point of Korea's Arctic research, we do have 19 authors as well, including President Kang Sung-ho, Chair Kim Ye-dong, Director Yang Eun-jin, Director Kim Hyun-chul, and many more, who contributed stories to help enhance understanding in Korea's Arctic research and Dasan Station and to shed new light on the role of the station. Now let me invite President Kang, one of the main authors of this book, for congratulatory remarks to celebrate the book launch. Please welcome President Kang with.
오늘 제가 기관
As the head of KOPRI, we have with us who are dear friends for this book launch, and it is a very moving moment for me personally. And at first, I started with my research in Antarctica, and then in 1987, and since then on, I went to Antarctica and received my degree. And then I moved to KOPRI and visited the Bering Sea and went to the Arctic, the Dasan Station, and always on someone else's ships at the mercy of other nations. And I wondered when we would finally have our own vessel. And I just did what I was told to do by my professor and went where I was told to go. And in 1990, with the former President Kim Ye-dong, with the Snow Dragon RV from China, I was seconded to that icebreaker and went to the Arctic for the first time. And the smile in the photo is because I was so delighted and because I'm always excited to go to someplace new. And that was just a demonstration of my curiosity and happiness. And when Dasan Station was first opened up, I didn't know what to do with the research. And then a Swedish researcher was climbing up the glacier with a gun at his back. And I just followed him. And I learned how to ski and the routes I need to take for research. So at first, everything is new. And you can't really see the deep curves and valleys because it is snow covered. So sometimes it can be dangerous when you ski down without knowing how the topology looks like. So now all that experience leads to this book launch. And I think that the Arctic research is divided into before and after the Araon and before after the Dasan. And from the coastal research to the continental research. And once we have the next generation IBIV, we will make another leap forward. And we have great support from the Ministry of Oceans and Fisheries. And as a public figure myself, I am very encouraged about what you said during the discussions, how we can better reach out to the public and how the polar researchers can, just like space, become it remains an uncharted area. So for the public to feel closer to the Arctic and to better understand the Arctic, as the head of KOPRI, I will do my best during the remainder of my office. So over the past 20 years, we did a lot. We had the Arctic Run, a marathon event with prizes. About 20,000 citizens came and ran, thinking about the Dasan Station and left their messages. And with a retailer, recently we have launched a campaign. Well, now plastic bags have been prohibited in Korea, and we put a polar bear image on a bag with a retailer, and we have launched a campaign. And soon you will see, when you purchase a paper bag, you will see the polar bear image that we collaborated on with this retail partner. So we are about to launch this book called The Arctic, A Record of 20 Years, 19 authors total. And they shared different stories about the Arctic. And I also wrote a story of my own 23 years ago when I first went to the Arctic. So the authors have went to the Dasan Station at least once. There are hundreds of people from Korea who visited the Dasan Station, and 19 of them shared their stories. There are high school students, journalists, as a non-scientist who look at the Arctic with their own eyes. So taking this opportunity, I would like to thank all the authors once again. Korea's Arctic research took off later than others, but in just 20 years, in quantity and in quality, we were able to grow. And as the discussant, the panelists mentioned, it's now time to take stock of the past and also think of what kind of selection and focus we need to do and plan the future. So this book called Arctic, A Record of 20 Years. We have 5 different chapters: beginning, encounter, research, advancement, and togetherness. And with this book, in this book, you will be able to learn how we were able to quickly advance our research. So Dasan Station is like the mother of all Arctic research in Korea. Looking at the growth and development of research, like a mother, KOPRI will continue on with support to the Dasan Station. And based on the Dasan Station, our researchers go to the ice-covered waters, permafrost, Eurasia, East Siberia, and more, deep into the uncharted land. So I'd like to share with you a quote from the book to conclude my remarks. Glaciers and ice caps have gone and been replaced with vegetation. And now, more than polar bears, we are more worried about mosquitoes. So we heard about the book, Polar Bear, Where Are You? But now we will be soon we will have to look for polar bears because there are less and less of them. And students sometimes think that you shouldn't go to the Arctic because going there in itself will pollute the Arctic. But we need to go. Someone has to be there to look at the changes taking place, to better understand the sciences and alert the rest of the world, and to love the Arctic and to protect the Arctic. So it is the mission given to all of us as Arctic researchers. So taking this opportunity, I would like to thank you all. And please read through the book, mindful of the meaning of the book. Thank you. Thank you. As President was right there at the beginning of Korea's polar research, I believe that the book is very meaningful to you. Before we wrap up the book launch, we will have a photo session with all honored guests and participants to commemorate the book launch. I'd like to ask all honored guests and participants to come forward to the stage for the photo session. So I'd like to ask the moderator, the MOF participants, presenters, and discussants to come forward to the stage for the photo session. Please bring the book in front of you so that we can take the photo with the book in your hands.
네, 그리고 저희 참석자분들께서도
And all participants, if you can come forward for the photo as well.
네, 그 저희 실무진들은
KOPRI staff, could you bring the book to our guests for the photo?
네, 마스크 잠깐 벗으세요.
And could you briefly take off your facial masks for the photo?
네, 그러면 다 같이 웃을 수 하나, 둘, 셋, 극지. 네, 그러면 이어서 저희 그 극지연구소.
And next, everyone from KOPRI, please come forward for the photo. Everyone from KOPRI, please bring your books and come forward for the photo.
네, 직원분들께서 많이 앞으로
Everyone from KOPRI, please come up to the stage for the photo.
네, 그럼 이것
Thank you. This concludes the third Korea Arctic Science Research Seminar and the Dasan Station 20th Anniversary Book Launch Event. I'd like to thank you all for your participation once again, both on site and online. This concludes all events. Thank you very much.
네, 그리고
And those of us on site, just one housekeeping announcement for the presenters and panel discussants, as well as honored guests. We have lunch boxes ready. So please go to room 6 and 7 for lunch. And for general participants, we have prepared a sandwich as well. So we have sandwich at the back for your lunch. And please, can we take one more photo?
팀장님 사진 한 번 더. 네, 책 들고 같이 한번 이렇게 더 주목.
저기 탁. 행사에 참가.
Ladies and gentlemen, those of you sitting at the back, please come forward and take seats up front. Please take the seats. We have many empty seats up front, so please take them.
한국 북극연구 컨소시엄 세미나에 참석해.
Ladies and gentlemen, here for the co-arc seminar. We will start co-arc seminar at 1 p.m. So please kindly take your seats. English, simultaneous interpretation into English will be provided. If you need interpretation, please use the interpretation receivers. Channel 1 for Korean and Channel 2 for English. Also, those of you here on site, please set your cell phones to vibration or silent mode to minimize interruptions. And please check that your alarm setting is turned off. To prevent the spread of COVID-19, please keep your facial masks on inside this hall. We will start the seminar at 1 p.m.
잠시 후 1시부터
Ladies and gentlemen, the co-work seminar will soon start at 1 p.m. Please kindly take your seats.
아니요 앞으로 가운데로 모시 옮겨. 잠시 후 1시부터 시작.
So the seminar will soon start at 1 p.m. Please be seated.
안녕하십니까?
Ladies and gentlemen, I am the Secretary General of KOARC from KOPRI. I am Seo Hyung-kyo. I am also the MC of the KOARC seminar. I would like to thank all participants for coming all this way. Now, as the second session of the Science and Technology Day of the APW, the KOARC seminar will now begin on the topic, Finding a Way for the Korean Technologies and Industries to Strengthen the Arctic Market Entry. In this session, one of the key industries in the Arctic, shipping, energy, and shipbuilding, we will engage in discussions. So before we start, let me introduce our honored guests. From the KOARC, we have Chair of the Steering Committee, Mr. Kang Sung-ho. Next, we have executives from member corporations. Director Byun Jung-woo of Hyundai Heavy Industries. Director Lee Young-bum of DSME, Daewoo Shipbuilding and Marine Engineering. Executive Director Matt Friedrichsen of the Arctic Economic Council. From KOARC, we have Vice Chair Kim Hyun-soo, President of the International Science Technology Cooperation. Last but not least, Vice President Shin Hyung-chul of KOPRI, who will also moderate the second session of this seminar. Presenters will be introduced when their turn comes. We have many other guests here today, but in the interest of time, I am unable to introduce every one of you. I ask you for your kind understanding. And now we will start with the Chair of the KOARC Steering Committee, Dr. Kang Sung-ho, for opening remarks. Please welcome Dr. Kang with a big hand.
Good afternoon, everyone. As introduced, I am Kang Sung-woo of KOPRI. Before I deliver my opening speech, I would like to say that this year had two big events for KOPRI and Korea Polar Research. As you well know, the next generation IBRV was initiated for its construction, and the government established a statutory master plan promoting polar activities, which is a follow-up from the passage of the Polar Act, promotion of Polar Activities Act last year. So it is a monumental year for Korea in the space of polar activities. And I think against this backdrop, it is very timely and meaningful that we could hold COARC, the research consortium, in the day of the Arctic Partnership Week, and I would like to thank our 40 member companies who helped make this happen, and also experts with us today. In particular, I would like to thank the Ministry of Oceans and Fisheries who have helped host this event. Thank you so much. We have very special guests with us today. We have Executive Director Matt Frederickson from Arctic Economic Council. And next, we also have Director Byun Jung-woo of Hyundai Heavy Industries and Director Lee Young-bum of Daewoo Shipbuilding and Marine Engineering. Thank you for coming. Pursuant to the 2013 Basic Arctic Policy of the government, COARC was founded in 2015. Since then, 40 members from industries, universities, and research institutes have shown strong participation and support, which allowed us to establish the 2030 mid-long-term plan, publish polar issue reports every year, and also host a session at our Arctic Circle Assembly and a special COARC session at the Arctic Partnership Week as well. In leveraging our expertise of our members, we have identified various areas of research and supported projects to broaden our scope continuously. Last year, Daewoo Shipbuilding joined as a member, followed by Hyundai Heavy Industries and Samsung Heavy Industries this year as new members, and we are honored to have the top 3 leading companies in shipbuilding as our members. Going forward, we will of course support and expand our members in shipping, fisheries, tourism, and IT sectors, as well as strengthen exchanges with relevant agencies so that the business portfolio of COARC grows and ensure that our endeavors are in good quality as well. This year, as you know, the polar region environment is very unstable due to the war in Ukraine, and also Korea is facing difficulties from global inflation and economic depression and trade deficit. The Korean government is trying to find a breakthrough in this situation with business-friendly policies. To be aligned with such government direction, COARC has also set the theme of this year's session as Arctic Industries and Economy so that we can support domestic companies' entry into the Arctic market. That is why today's session are on the key industry agendas related to the Arctic, such as shipping, energy, and shipbuilding. First, Executive Director Frederickson of AAC and Deputy Director Dr. Lee Sung-gyu of Energy Economics Institute will talk about the Arctic shipping, energy prospect, and some potential inroads to the Arctic market. Next, on the eco-friendly IBRV, President Kim Hyun-soo of Korea Arctic Technology Committee will present on the research results, followed by expert comments from Mr. Lee Young-bum from Daewoo and also Hyundai Heavy Industries to talk about their export use cases in the shipbuilding industry. In sum, I hope that we can have a productive discussion today to reach insights on how Korean industries could better tap into the Arctic market and set the policy direction. KOARC will do its best to become a center for cooperation between the Arctic Economic Council and domestic companies looking to go into the Arctic. Lastly, in closing, I wish all our experts from industry, academia, and government who came to this event despite their busy schedule in December and all the participants. Thank you.
강성
Thank you, Chair Kang, for your kind words as the chair of steering committee. And as you said, I hope that COARC becomes a true platform for cooperation among the industry, academia, and research, and we will do what we can to make that happen. Thank you. And next, to celebrate this seminar, we have special guests representing the corporate members. First, I'd like to invite Director Byun Jung-woo of HHI for congratulatory remarks. Please welcome Director Byun with a big hand.
예, 안녕하십니까.
Good afternoon. I am Byun Jung-woo, Director of Hyundai Heavy Industries. Korea's largest research event on the topic of the Arctic has been prepared by COARC. I would like to deeply thank the chair of the steering committee and all relevant staff for putting together this event. Today's topic is finding a way for the Korean technologies and industries to strengthen Arctic market entry. I thank all presenters and panelists with relevant research experience and expertise, and I hope you have a fruitful discussion. HHI developed and delivered a polar-capable LNG carrier and offshore construction support vessel in the 2000s. In 2020, we also delivered an ice-class sustainment vessel to the Royal New Zealand Navy. With growing polar resource development and NSR usage, we have been developing since 2010 ice-breaking iron ore carriers, LNG carriers, container carriers, and many other ice-breaking commercial liners and propulsion systems. HHI will continue to develop relevant technologies for polar-capable spatial vessels and commercial vessels. Once again, I would like to thank the organizers of the COARC seminar and all researchers and experts for your participation. I'd like to conclude by quoting the message from the chair of the steering committee, who also serves as president of KOPRI, as posted on the KOPRI website. This is the final sentence on the message, and I quote, "We hope you will join our journey to the polar regions where you will find the answer to the secrets and mysteries of the earth." Unquote. Thank you very much.
장모님 축사 잘 들었습니다.
Thank you, Director Byun Jung-woo, for your opening remarks, and it is meaningful to hear from a new member of COARC, and I look forward to your active participation in our efforts going forward. We'll go to the next congratulatory remark. We also have a special guest. It's Director Lee Young-bum from Daewoo Shipbuilding. Please welcome him to the stage with a big round of applause. Good afternoon, everyone. I am Lee Young-bum from Daewoo Shipbuilding Marine Vessel Research Division. I would like to thank President Kang Sung-woo and COARC members for inviting me to speak at this meaningful event. I appreciate how after Korea became an observer in Arctic Council in 2013, the COARC was launched in 2015, and it began to play an active role in supporting and leading our polar researches. As you are well aware, Daewoo, which is the world #1 shipbuilding company, holds up the value Technology Daewoo, and we have been committed to improving technology ever since. In particular, we have been doing joint research with domestic and overseas research institutes to secure polar technology since 2002. Our 10-year-long polar research efforts bore fruit when we secured an agreement to build Yamal LNG vessels, 15 of them, which laid the foundation of us leading in technology for polar vessels. After delivering Yamal LNG ship, we additionally won orders to build Arctic 2 and FSRU project, which demonstrated that Daewoo has proven to the world that we have the best-in-class technology. I am confident that we are the shipbuilder with the best technology in the world when it comes to the polar field. Daewoo Shipbuilding forecasts that polar durable vessels and other offshore structures will become a key pillar to prepare for the future. And we will not be complacent at the technology we have achieved so far, and we are instead working to lead polar technology continuously with a combination of eco-friendly vessel technology and fourth industrial revolution technology. I feel that for a smart response to the future via tech development, we need a joint and converged research effort from engineering, academia, humanitarian, industry, scientific sectors altogether, but each body has its own research purpose and direction, which makes it difficult for one company to lead cooperative research projects on such convergence needs. But when it comes to polar technology, after joining and participating in COARC, I'm beginning to find some solutions to this end and even see a potential for greater synergy effect. So I'm very grateful to COARC for making this happen and aligning various stakeholders. I hope that the passion and commitment of all of you here translate into good results, and I would like to thank COARC once again for arranging this great seminar. Thank you.
네, 이영범 상.
Thank you very much, Director Lee, for your congratulatory remarks. DSME is in charge of eco-friendly container building project and is a key participant of the projects, and we expect more from DSME in terms of your activities. So we will begin the presentations. The Secretariat of COARC is operated by KOPRI, and I'd like to invite Vice President Shin Hyung-chul of KOPRI to moderate the expert presentation session. And I will now step down from the podium.
안녕하세요.
Good afternoon. As introduced, I am Shin Hyung-chul. I used to be the Secretary General of COARC Secretariat, so it's a special day for me. As the chairman of the steering committee has introduced, I think that the presentation, discussions, and Q&A are well organized, so I'd like to call your attention to the structure. First, we'll address the economic opportunities with the presentation by the Executive Director of AEC himself. And then we will look at the shipping side of the economic opportunities, and we will move on to how all the resources can be used in the future by Dr. Lee. And then we move on to the topic of vessels, beginning with the containers carrier, which is under development, and the LNG carrier that is already in operation. And in the Antarctic waters, Korean company has built and delivered a vessel to the New Zealand Navy. And we will also hear about this very special ship. So first, I'd like to introduce Executive Director Mads Fredriksson of the AEC. Last dinner, I had dinner with Mr. Fredriksson, and we engaged in very interesting dialogue. And I heard that his name, M-A-D-S, well, D is silent. So we should not say Mad, but Mads. So Mads Fredriksson, Executive Director of AEC, will have the first presentation.
Thank you very, very much. And thank you very much to the chair for allowing me this opportunity. And thank you for the directors for very important companies to come here and see this presentation. Some of the slides I showed yesterday, and some of them are brand new, but it's all about sustainable economic development. And it's also about another important thing that COARC and KOPRI is working with, which is the triple helix model. And this was actually my first job when I came out of university, was working with the triple helix model, getting universities, private sector and public sector working together for the benefit of everyone. So, just very briefly, so I'm the executive director of the Arctic Economic Council. We are an international business membership organization with member companies from all 8 Arctic states, but also non-Arctic states like France. We have members from Greece, we have members from Switzerland. And a lot of these members are working within shipping. And when most people look at the world, they look at the world like this. But we like to look at the world like this. And we actually like to add another layer to this, which is this, the people of the Arctic. So the main role of the Arctic Economic Council is to work for the people living in the Arctic region. Me, myself, I live in Tromsø in northern Norway. Very briefly, I just want to say we do 3 things in the Arctic Economic Council. One is we do policy advocacy. So if we need policies to support science in the Arctic, if we need policies to support business development in the Arctic, that's what we do. Then we do networking. We have a network, a working group on shipping, for example. And then we do a lot of outreach and communication about the Arctic region. If you Google the Arctic, this is what comes up. This is the image of people not having ever worked in the Arctic they see. And if you ask policymakers, this is what they put in front of their policies. And it's a lot of governments and very little people in these policies. This was the old one from South Korea. I was actually happy to see yesterday how many people that are in the new framework. So I was very happy to see that the role of business has also been focused on. Because this is how I see the Arctic. When I see the Arctic, I see this. I see data centers, I see energy projects, I see cities, and I see vertical farming and tourism and shipping. Because these are some of the key sectors in the Arctic region. Some of them are very big, some of them are smaller, but all of them needs the help of science, all of them needs the help of shipping to succeed. We know that temperatures rise 4 times as fast, global warming, in the Arctic as anywhere else. Svalbard is 7 times the global average. This is just one mega trend that affects everyone. So as I said yesterday as well, these are the mega trends like climate change, urbanization, demographics. We are getting older population. This affects everyone, but also the 4 million people in the Arctic. But these mega trends also affect these people, the people living inside of this circle. And these people, for me, are the key important people for the people of the Arctic. Because, as I said, we are just 4 million people, but we have a lot of products that those people need. And the people in the Arctic can actually make something good in the world, but what it takes that we connect the 2 people. How do we connect the people in the Arctic with the people inside of this circle? And I believe we can do it with 3 things. 1 is fish to feed the world. 2 is with energy to power industries like LNG, as we heard about in one of the previous speeches, and raw materials. So we know we're going to be a lot of people in the future on the planet. 9.7 billion people in 2050, according to the UN. So we need to feed these people with more proteins. This is Royal Greenland. This is the biggest company in Greenland. They are responsible for 95% of the export from Greenland, which is fish. But the question is not only how do we sell fish, and their main markets is in Asia and the US, not in Europe. But the question is not only how do we catch more fish, the question is also how do we use it better. And for me, what you see behind me is a perfect example of private sector and science going together. What you see behind me is the skin of the codfish. And the skin of the codfish is an Icelandic company called KOPRI. The skin of the codfish is now being used in the pharmaceutical sector to treat burn wounds. So instead of putting an artificial band-aid on you, you can now put the skin from the Arctic cod on you, and your skin will automatically absorb it, and it will treat the wound. This came from science, and it came from private sector. Today in Iceland, the skin of the codfish is worth more money than the fillet of the cod. They make more money from what they used to throw out because of inventions like this. Then we got energy. These are some of the main energy sources. So if you look at wind, it's very big in Finland and in Sweden. Geothermal is obviously very big in Iceland. Hydro, where I come from in Norway, where I live, hydro is 90% of the energy sector, and solar is even being used. And this makes it very, very attractive to open new companies that are energy intensive. Like this one, Northvolt, that are building batteries. It's 5,000 employees, and they will deliver 1/3 of the European Union's car batteries. Comes from this factory in northern Sweden. And the reason why they decided to move to northern Sweden to build a battery factory was because there was a deep sea port, a lot of space, and there was a lot of green energy. But also because it was close to a lot of raw materials, because that's the third one. This is where the European Union gets their raw materials from. So if you, in the European Union right now, are getting raw materials from Democratic Republic of Congo, from Guinea, from South Africa, and so on. And I think the most important raw material here is in China, where they get the rare earth elements. The rare earth elements is what you use when you build a battery, when you build a cell phone or a Tesla, you use rare earth elements. The rare earth elements are also in Greenland, they're also in Canada, and they're in many other places in the Arctic region. But they need to be transported because we will never be able to do the processing in the Arctic region. So we need bulk ship carriers to transport these materials from the Arctic into processing plants somewhere else. Yeah, this is just a slide of all the different mining sites and oil and energy sites. So to do this, we need to release the full potential of the Arctic. We need infrastructure. So that's, for example, new ports, new airports. We need investments, and we need people. And that's my second part of this presentation. Because when we look at investments in infrastructure, let me spend a little bit of time on the Arctic shipping. This photo is from the main trading routes in the year 700. So in the year 700, the Vikings were traveling and trading across the Arctic. This is before the polar code. This is before any ice classes and icebreakers. But young, brave Vikings were sailing up north and trading with the local people in the Arctic region. And ever since year 700, trading has happened on the oceans. Everything you see in your house, in your factory, in this room, 90% of it has been transported on the oceans. The oceans is the main transport hub to transport things around the world. And this is something that people often forget about, that most things are transported on the sea, but not only that, 85% of the northern hemisphere, 85% of the world's population lives in the northern hemisphere, and the Arctic really connects all of these people. As we see here, the Arctic region can be a hub for transport. And we have this situation, as I showed before, with climate change. Climate change will have an impact on industries, especially for shipping. Because Arctic sea ice is going to become less and less and less over the time, which means that new shipping routes will open up. During the lunch break, I talked with a researcher from a local university who spoke about the Northern Sea Route. So let me spend a little bit time on the Northern Sea Route, which is the blue line here. For many years, there was talks about that the Northern Sea Route would really be a game changer in the Arctic region, that it will be the new transport hub, because you could suddenly cut away 12 days from your itinerary, 13 days from your itinerary, if you were traveling on the Northern Sea Route. But what we saw since the war in Ukraine started is that we saw a massive drop of shipments to and from Russia. And before the war, there was also not that many ships sailing on the Northern Sea route for transshipments. And I think it's something we have to remember when we talk about the Northern Sea route. These three numbers are quite important to be a little bit realistic about the Northern Sea route. Because when you read in the media, it seems like the Northern Sea route is going to be the new Suez or the new Panama Canal. We are far from there. This year, there was not a single international transshipment on the Northern Sea route from any other than Russian countries. But I still see, in the long term, Northern Sea route could be a potential addition to the other sea routes. It's not going to compete against the Suez, it's not going to compete against the Panama, but it's going to complement the other sea routes in the long-term horizons. But for me, there are three enablers for that to happen. And these three enablers, I think, is also very relevant for the South Korean companies present here, because you have to help us in the Arctic achieving this. So one is icebreakers. Right now, the US government got 2 icebreakers. 2 icebreakers. I know it says 5 here, but like the maximum Arc 7, they have 2 icebreakers. One of them they're using for spare parts for the other icebreaker. So in reality, they have 1 functioning icebreaker. This is a massive challenge, and right now, if you read every single policy from the US, they say we need to invest in more Arc 7 icebreakers. We need to invest in more of this, and it needs to happen not in 10 years, but we need the icebreakers now. So right now, a lot of Arctic nations are talking about renting or leasing icebreakers from other places. That also goes for LNG carriers that have the polar class. So yeah, icebreaker is number 1. We need more icebreakers in the Arctic. Number 2 is the development of hydrogen. Hydrogen, or you can call it power to X, you can call it methanol, you can call it ammonia. It has a lot of names, but when you look at hydrogen, I think this is going to be one of the most important development into shipping. 50% of the shipping today is energy being shipped around, LNG and oil. But when LNG and oil will cut down, and we will see also less and less shipping, and it has to be greener. But we need a lot of changes for this. So what we work with in the Arctic Economic Council is we work with some of these areas. We need to look at policy around hydrogen. We need to look at the technological advancements. We need to look at how can we produce the fuel. We need to look at more customer demand and fuel, customer demand and pull, because who will start? Will it be the ship producers making ships before there's a market, or will it be the market first coming before there's the ships? That's the big challenge, and then we need to finance. But developments in hydrogen I see as a big, big important thing in shipbuilding. And then the last part, another enabler, is data. Right now, the Arctic region is very much a data desert for many people. There is 8 times more data from the Atlantic Ocean than the oceans around Alaska. During the COVID times, we really saw this digital divide. So right now, for example, I've been to Greenland many times. Greenland don't have any nautical charge of the whole coast of Greenland. That doesn't exist. We simply don't have nautical charge of the coastline of Greenland. So we need to invest in data, we need to invest in satellites that can supplement these nautical charge. So we need to make more investments in connectivity. So this comes with a price. This is not for free. Guggenheim Partners, which is a big US investment firm, estimates that we need investments of $1 trillion in the Arctic region. This is a statement from 2015, but the chief investment officer, Scott Minerd, he actually repeated this statement at Arctic Circle this year. So we need a lot of investments in infrastructure. And that's why, finally, I want to take you to Northern Norway. Because for me, Northern Norway really symbolizes everything I talked about. How we need investments, how we need infrastructure, how we need people in the Arctic, and how we need the green transition and renewable shipping. So the population of Berlevåg, what you see here is the forecast of the population of Berlevåg. It's a small town in the north of Norway, 700 people. It's up here, located up here, close to the border to Russia, close to Sweden. And this is how Berlevåg looked like after the Second World War. The whole town was completely destroyed by Nazi Germany at the time. They burned the whole city when the Soviet Union came to liberate. Then people decided to build up the city. And today, the small village, fishing village, looks like this. And for many years, this town was dependent on fishing. But what happened is that the fishing industry became industrialized. So suddenly, the fishing vessels went further and further out, and they didn't need to go in and dock. So the people of Berlevåg, they looked at each other, and they said, what can we do? And they looked around, and they said, we see a negative population growth. We go from 1,500, 2,000 people to 700 people. Everyone is leaving. We cannot do the fishing anymore, but what can we do? And they looked around, they said, what do we have that no one can take away from us? And they had two things. One is they had a lot of space, a lot of land. Two, they have a lot of wind. So they decided to put up 15 wind turbines. Then everyone had heated houses, everyone drove electric vehicles, there was a nice swimming pool there. But the problem is in Norway, they could not export the energy because the grid is not ready for exporting energy. So what does this village do? They decide to put up 12 more wind turbines to actually produce far much more than they actually need. And why is that? And I will show you, because this is relevant for shipping as well. This is what they did. So they're going to build, what you see in the middle is a hydrogen factory. And this is not a dream, this is already happening. They have the finances for this, they have the money from this, they have the investments. First, they got EU research money, Horizon 2020 money, to do a small pilot project. That was step one, to show that you could actually build hydrogen in the Norwegian Arctic. Two, they went together with the whole value chain, with all industrial partners. So they have a shipping company, shipping producer. They have which is going to be the main customer. They have the energy producer. They have the local municipality. They have the whole value chain. So 6 strategic partners went together, and now they are building a hydrogen factory, ammonia factory. So what they will do is that they will not only deliver ammonia power to X, hydrogen, to the ships coming there, they will also send out energy to Svalbard. Svalbard today is primarily using diesel and coal for their energy. So suddenly they will help make Svalbard more green. But what I think is more interesting, when you produce hydrogen, you have a lot of energy waste going into the air, around 30%. So what they will do is they will make on-land fish farms. So instead of getting prawns or shrimps from Asia, they will have on-land fish farms where the water will constantly be 27 degrees Celsius, which means they can grow the hot water prawns, hot water shrimps locally in this village. They will also have vertical farming, and they will use the waste of the fish farms as fertilizers in this vertical farming. So suddenly they will also grow lettuce and everything there. I think what you see here happening in the Norwegian Arctic is a game changer. It's a game changer for the Arctic region, but it's also a game changer for the shipping industry, because new things, new products has to be shipped, and new technologies has to be used. And I've been very impressed with everything I've heard here in South Korea about the work that you're doing within Arctic shipping. I've been very impressed by all of the research you're doing within, and I've been very impressed with the goals in the master plan. So I'm sure that South Korea is definitely ready for these changes in the Arctic, and I'm sure that shipping will play a very important role. Thank you very much.
Do we have any questions for Mr. Fredrickson? Maybe just one? Not yet? Okay, then we will take all the questions during the discussion session at the end. I only thought of the skin of the fish as a source of food, but that was a completely different story. And that value chain far up north is quite impressive. So, in the energy market, what is the prospect?
We'll look at the status quo and the future of the energy market. And Dr. Lee Sung-gil from Energy and Economic Research Institute will present about this. Hello everyone. I am Lee Sung-gyu from Energy Economy Institute and specifically focusing on overseas energy. Today I would like to talk about how the energy market changed and became much more uncertain after the Ukraine war. This has significant impact and will change the global energy trade sector. So I will talk about this in the first half of my presentation. In addition to the trade change, transportation of energy will also be impacted and changed, and especially the pipeline gas transportation is now being switched over to LNG carrier vessel-based transportation. With this, the importance of the Northern Sea route gets highlighted even more, so I will also touch upon this subject in the latter part of my presentation. In 2020, we had very low oil prices. It actually went to the minus range in the actual price. If you look at the actual price, it was in the minus range. So this low oil price persisted until the mid-2020, but after that, COVID-19 brought economic depression and also a breakdown in supply chain. Furthermore, this year, February, the war between Russia and Ukraine broke out. As a result, the global energy market faced high prices. If you see on the right, the blue line, new coal, see how it increases steeply from 2019 to 2022, 8-fold, and gas rose 10-fold. And in Europe, the increase was steeper, like 14 times. And oil prices about 2 times. Right now, the oil prices are somewhere near around $80 to $90. If the Ukraine war persists, then I think this price range will also persist for 4 to 5 years, according to energy experts. The incident in Europe had overarching impact on the global market. Europe consumes 150 BCMs of Russia gas and Korea 40 BCM. This means that Europe is consuming 3 times as much as Korea in terms of energy, and 150 BCMs was being sourced from Russia. Of course, 150 BCM represents 40% of the total energy consumption in Europe. So they get 150 BCMs from Russia, Europe, and then they get about the same amount from Africa, Caspian Sea, and also the northern areas such as Norway. These are the import routes for Europe. 150 BCM recently fell to as low as 5 BCMs or 10 BCMs. As a sanction on Russia, Europe is trying to phase Russia out and bring their dependency on Russia down to nearly zero. And as for oil products, if early, by the first half of next year, Europe will also bring down its dependency on that to zero as well. And this is not only one country's strategy, but rather the strategy of Europe as a whole. And such Europe-bound volume now will, I think, be converted to Asia-bound volume from Russia's perspective. Russia's exports to Asia and Middle East will grow, as you see on this screen. This is a midterm forecast. By I think until 2030, this is how world trade in energy will look. In the past, Europe imported from Russia via pipeline, but this kind of transportation will be switched to LNG carriers and bound to US, Mozambique, and various parts of Africa, such as West Africa, and Middle East, Qatar. France and Germany have signed a big LNG agreement with Qatar. It's a long-term, big volume agreement, and also there will be transportation going up from Australia as well. And this will all go into Europe in the form of LNG. Now, on Russia's side, the originally pipeline volume that was bound for Europe will now be switched over so that they are now destined towards India or China. And because gas demand in Asia is rising, they will try to ship it to Thailand as well. I think Russia will send its gas resources via pipeline to China. The volume in West Siberia that was originally bound for Europe will now probably be converted to China destined volume. And Arctic gas or oil terminals will be built so that they can go to India via the Suez Canal or the Northeast Asia region through sea. Another noteworthy point is the global movement towards moving to carbon neutrality by 2050. As you know, oil, coal, and gas will peak around 2030, but afterwards, after 2030, they will drop significantly and the fossil fuel consumption needs to drop dramatically. I'm saying that we need to decrease the consumption of such energy sources, but I'm unsure as to whether it will happen or not. It really depends on each country's effort. And to reach our global targets, we need to make more dramatic cuts in terms of these conventional energy sources. The rest of the demand needs to be met by renewable energy sources. Especially power generation will see the first carbon neutrality achievements. In Europe, around 2040, nearly all the fossil fuels will be phased out, and nuclear power or renewable energy will do nearly all of the jobs, which is quite quick. After 15 or 20 years from now on, we will see this step change in certain regions of the world. Of course, for Asia and developing countries, they will be about 10 years later and will keep using fossil fuels for 10 years longer compared to Europe. And going forward, the portion of gas which is less polluting will of course be used more than other fossil fuel sources. Nevertheless, at least until 2050 or 2060, even developing countries are saying that they will go towards carbon neutrality. So when the year 2060 comes, every country is faced with a mandate that they have to deliver on achieving great lengths in carbon neutrality. The key tool for carbon neutrality is electricity. If possible, in the areas of transportation or in building and other sectors, the fossil fuels will be converted to electricity, and this electricity will be generated from renewable energy sources. Nevertheless, there are some industries which require fossil fuels, and for example, shipping and air freight For these large-scale transportations, fossil fuel reliance is inevitable. And as suggested in the previous presentation, hydrogen, ammonia, or biofuels could be mixed with the fossil fuels to make such large-scale transportations happen. But still, if developing countries still want to use fossil fuels, CCUS, carbon capturing technology, needs to be implemented more widely, and they will probably do so as they use fossil fuel. Europe and developing countries, both of these regions, I realize that fossil fuels are economically more feasible because they're cheaper. And if the government policies are in a direction that they want to use these economically more meritable energy sources, CCUS technology will allow them to use such fossil fuel sources for longer. Of course, CCUS technology is not commercialized fully, which means that more technology development needs to take place in this carbon capturing space. As these graphs suggest, the International Energy Agency has set out 3 scenarios: oil, natural gas, and coal, and how their trends will change until 2050. There are 3 scenarios. If each country maintains its current policy position, then oil, natural gas, coal consumption will increase at a similar rate until 2050. But there's the scenario where we simulate that the countries will go carbon neutral by 2050. Then the yellow line will happen. That is the simulation. And the last line is where IEA or IPCC, these international climate organizations, they say if it's necessary to cap it at 1.5 degrees temperature rise, and we have to achieve this global target by 2050, and that if this is given as a mandate to all global countries, then the efforts of each nation has to speed up significantly. It ultimately boils down to how binding and strong the global agreement of with each country and among countries can be implemented and enforced. Recently, there was a COP meeting in Egypt, and it seems that we can learn from the meeting that we have still more distance to go to reach a global agreement. In the Paris Agreement and meeting, we thought that there would be great, helpful, and effective efforts by each country. But after the supply crisis hit, each country started using more coal and wants to use more gas now that there is an energy crisis in this supply market. So their commitment towards the Paris Agreement and the climate agreement seems to weaken. This means uncertainty for each nation's climate policies that we have to consider. About 3 or 4 years later, in 2026, Europe's gas consumption or LNG consumption will take a big portion. In particular, to stabilize the energy supply in winter season, LNG demand will probably be very high in the global energy market, and Europe will try to import more gas in this season. And that means Asia countries have to buy LNG gas at an expensive price. And for some countries with less buying power, they can now secure volume, which means that they have to turn to coal. And this kind of situation will persist for around 4 to 5 years. EU is imposing strong sanctions on Russia, and G7 keeps having discussions about this, and Japan is also on board with this movement. Korea hasn't put forward a clear stance on this global movement. It's our reality that we cannot be fully on board or fully side with the Western society. But Europe is very clearly committed to lowering their dependency on Russia. Before the Russia-Ukraine war happened, Europe and US companies had a lot of company investments in Russian companies and vessels and Russian plants, but American investment and Europe investment in companies are withdrawing. In the initial phases of the war, it was unclear whether Europe and US would withdraw. And actually, when the Crimea annexation happened, US said that they would withdraw, but Euro companies did not follow suit, and they continued with their investment in Russia because it was aligned with European interests. So when the war in Ukraine happened, some thought that Europe will maintain its investment presence or company industry presence inside Russia, as they did back then in the Crimea annexation. But it looks like this time Europe will withdraw its presence from Russia. That place may be taken up by China, but China doesn't have the technology to replace Europe because the key facility and key equipment mainly exist and inside Europe and US, and China cannot wholly replace them. So this means that Russia's LNG business is taking hit, and the in-flight projects were delayed for around a year, and it is uncertain what will happen to them. And for new project prospects, it is even more unclear on how they will play out. So as a means to solve this situation, Russia is looking to expand cooperation with Middle Eastern countries and other Asian countries, but due to technology gaps and differences, this is also seeing a limit. And also in the terms of funding, Europe, Japan, and other Western countries used to fund Russian business efforts a lot, but now that kind of funding will likely be cut off. Against this backdrop, Russia's energy strategy going forward will be pivot to the east. They inevitably will look towards Asia. The key consumption for fossil fuels and the export destination will be Asia, not Europe. Then the expandable market will be the export market that Russia wants to go towards. And if Russia wants to go into Asia, then vessels, carriers are the only option. The inland fields, the energy sources coming from that needs to go into China. And there are a lot of old fields which have been extracted for a long time, and the new fields are going in the direction of the Arctic. This means that the volume produced from there will be carried in oil vessels or IBRVs to go into Asia. So Russia, for its future, will definitely pivot to the east. Long-distance shipping transportation will be key and inevitable for Russia, and the specifications of these ships need to be able to support this requirement. This means that this will be the new demand and new requirement in the shipbuilding industry. The mineral fields and the oil gas fields near the Arctic are quite many in number. This is how sea transportation will likely look. Russia's problem statement will be this: the long-distance transportation, whether that will be competitive in terms of exports, because it will, of course, drive up the cost of its long distance. Russia's key interest will be in solving this, And if they are able to get price competitive, then they will likely do this by having a big vessel or carry a big volume, or having a transit station in the middle so that they can be more flexible in their shipping schedule. So Russia is trying to devise various strategies, and where possible, they will build various export terminals near the Arctic Sea so that they can compile the volume at this transit station and then keep sending out bulk shipments out to the destinations. This kind of hub transit will be key for Russia to survive in the price competition against other countries of energy export. That is why Russia is interested and is planning a lot in energy transportation, gas terminal, oil terminal, and the railway construction for minerals in the Arctic to be moved to the terminal are some of the projects that Russia has announced that it will do until the year 2035. Murmansk and Kamchatka are the two potential regions for these transit hubs that Russia is considering. They will probably build out and scale out these regions, and the volume in East Siberia will go through Vladivostok, and they will make Vladivostok the new transit hub so that the land volume can go out into the sea volume. The Yama and Kidan region and Tamira region, peninsula, are probably the places where we will see large-scale terminal constructions. I think Russia will try to do this quickly because after year 2030, worldwide, the demand and consumption for coal and gas will decrease, so they need to sell the stock that they have as quickly as possible. This means that all volume and all possible stock has to be sold by 2030, and they have to get money out of that to fund their other strategies, and for example, export of critical minerals and so on. Going forward, the demand for critical minerals will increase significantly worldwide. Critical minerals is a market where there is great China dependency, but US passed the IRA, Inflation Reduction Act, and is trying to create a bloc in the region which consists of its allies. So they're trying to create a supply chain bloc and exclude Russia and China from that bloc. Of course, this bloc will not persist forever. This kind of new Cold War regime will not last long in my perspective. However, US strategy in this field will continue, I think, for the meantime. The global critical mineral supply chain will change also accordingly for the meantime. Greenland is surfacing as a key area of attention by Europe. It used to get a lot of critical minerals from Russia as well, but because this is proving to be difficult now, they have to look for alternate sources, which are Africa and Greenland in Europe. These are the new supply regions that Europe is considering, and also the northern part of Canada, namely Alaska. This is the supply chain bloc between US and EU, and these supply sources will replace Russia likely. US, Canada, and EU countries are building a lot of intergovernmental forums between them, among them, and Korea is being involved in that as well. The Korean government is pursuing multilateral or bilateral government forums and connections with these countries. In short, and in sum, critical minerals, LNG, and fuel and oil will be impacted by the changes in global supply chain, mainly in its form that shipping transportation will happen more and also long-distance transportation. And since there are movements to keep the supply chain in a certain block, there may be intra-block transportation more, and through the development of the northern route, mineral resources will be transported more. Of course, for US and Europe, they have the environment to consider. As a nation, they have to think about where they want to go in a trade-off between energy security and better environment. The governments have to decide which values they're going to uphold more and which direction they're going to go towards, and that will affect their policy decisions. That's it. Thank you. Thank you. You explained the dynamic and very fluid situation in the recent market. It will help our discussions later on.
The next presentation will be about the development of the ongoing eco-friendly ice-breaking container carrier. So if you could keep your presentation to 15 minutes, it'll be much appreciated.
네, 인사드리겠습니다.
Good afternoon. I am Kim Hyun-soo. I feel much at ease because up until yesterday, I thought I was supposed to present in English. And I was wondering whether I really should because my mother tongue is Korean. But since my preceding presenters presented in Korean, I will follow suit. So we have two more co-authors of this presentation. Dr. Choi Jung-hyo here today, and in London, Dr. Jung Sung-yeop helped me out with this presentation. So what I'd like to speak about today is, as the moderator has mentioned, is still under development. And please consider this project as a feasibility study. How the container ships go up the NSR, how all that can be possible. And the two previous speakers have mentioned, when you look at the Arctic, one perspective would be energy and another could be the shipping routes. And I think that in the process, the scientists here today, when it comes to the sea routes and the energy resources in the Arctic, how much reserve the Arctic has and whether the NSR can actually be feasible, will be a key research topic. And I look at the ships that may go through the NSR. So the two more presenters to follow will discuss what has already been done, and I will more focus on the future perspective. These are the topics I will be addressing. And as you know, and as many have mentioned, there's the climate crisis and climate disaster, in fact, and in our daily lives, we are impacted severely by climate change. So we live with these changes. So those of you in the industries that are involved in shipping or oceans, shipbuilding, and shipping are all involved. In international organizations, including the UN, carbon neutrality, decarbonization, are key topics that are being discussed. And in shipping and shipbuilding, IMO is the lead institution, and they have come up with this roadmap that you see on the screen. And by 2050, greenhouse gas emissions will be fully neutralized, as you are all already familiar with. So starting next year, EEXI or CIA will be applied to vessels. So the vessels in operation, how much, depending on how much CO2 they emit and greenhouse gases they emit, all that will be proven legally, institutionally, and technologically. Everything is ready. In terms of technology, energy saving, so reducing the amount of emissions. What's most important is about how to use less fuel, but more efficiently carry more containers. So from that perspective, as you can see on the screen, there are a number of different technologies mentioned. In order to reduce the fuel, lubrication system, energy minimization system, and more are applied to vessels. These technologies are being developed. Energy-saving devices and other types of technologies are under development, and you can see how each of those technologies can save energy. And as you heard before, going forward, what can be alternative fuel? We heard about hydrogen, electricity, ammonia, methanol. So according to these outlooks, the red line indicates coal and fossil fuels. By 2025 onwards, there will be a steep decline, and hydrogen will increase dramatically. Methanol will also go up. And likewise, ammonia will be increasingly in use as alternative fuels on board, and shipyards are really developing these technologies the best they could. No one knows when exactly and which of these technologies will be realized first, but shipyards around the world are really competing to develop these new technologies in order to dominate the global shipping market and shipbuilding market as well. On a container ship, these are some of the technologies applicable. Again, it is all about saving energy, using less energy but more efficiently to build a good vessel. For container carriers, there can be a number of different technologies involved, not only in terms of fuels use, but other areas, as you can see on the slide. As vessels themselves are converted into eco-friendly ships, that's the general trend that the world is preparing for and headed towards, as you all know. As I mentioned before, there's the NSR that is often mentioned because, as you can see, one notable example is that when the Suez Canal was grounded and blocked, there was a huge value chain disruption, which really fueled discussions on opening up the NSR and whether this could be an economically viable alternative. As a possibility, there has been some discussions about possibly moving some of the container shipping to the NSR. So in the energy sector, we heard before that in the Yamal oil gas storage sites in Murmansk, Kamchatka Bay, there are different facilities in place, and the Arctic Yamal Peninsula platforms and other types of port infrastructures require great level of investment, and technology have been involved, and what you see on the slide are some of the examples of such technologies. This is the offshore structures for LNG terminals in 2016 and 2015. As you heard from DSME, in 2015, the very first Yamal ship was delivered, and before that, preparations were already in place, and mass production is ready and very successfully to Europe and Asia. These vessels are being operated, and maybe Dr. Choi put in these photos. There are equipment related to Korea, very special equipment and vessels that are operated. So as the environment is rapidly changing in the Arctic, if you look at the data, the open period for Northern Sea Route is increasing day by day. So in 2020, the open days amounted to 88 days, and I think the numbers will be higher for last year and the year before. So when I look at this data, I think that scientists are doing very important work, predicting the future, and also determining what type of values should be prioritized going forward, how many days will be open for the NSR, and what the sea ice environment would look like. We need accurate information about the future, because once the vessels are ordered, then they will and are built, they will be in use for 30 to 40 years. So we need to make sure that we use as less fuel as possible, but operate in a more efficient way. So in that sense, I would like to thank all scientists for your work in helping us build the better and future-proof vessels. And so the amount of containers volume is growing and growing. As of last year, we hit a new historic high. And all this indicates that although NSR is blocked, and large container carriers like Maersk say that the beautiful environment in the Arctic will be degraded and further accelerate climate change by sending ships over to the Arctic. But if vessels can operate in an eco-friendly manner and do not emit any GHG and also help economically, then will the shipping companies be able to refuse the use of such vessels? I don't really think so. So that's why shipbuilders are really competing to build vessels that run on hydrogen, for example, that do not emit any GHG. And this is just an example from the logistics side. And for container carriers that travel between Korea and Europe in 2021, there were about 1.75 million TEUs carried in total by the carriers. I don't think that's really a high number. That's from Korea to Europe. Globally, there's about 200 million TEUs, and 10% of that amount goes through the Arctic. So anyhow, the container volume is growing and growing, and I think that we have more accurate data in the logistics sector. And anyhow, the volume will only go up. And one of the possibilities is that once the sea routes are opened up in the Arctic, with more and more sea ice melting, with the sea ice coverage retreating, Arc 7 type of vessels we really don't need Arc 7 level of vessels. Smaller vessels, once the large vessels break the ice and open up the routes, the smaller vessels can follow and operate. So that's basically the concept that shipbuilding companies have in mind. And once that becomes a reality, the shipping routes can be used much more efficiently. So this is one of the feasibility studies that we are conducting. So the basic concept is, well, we're not the only ones, first of all. NARC or other research institutes have already designed the concepts with 8,000 TEU vessels, and they already analyzed the potential impact. They tested mostly with the LNG-driven vessels, but ammonia or methanol-driven ships can come on board. And depending on the size or of the vessels, then they are limited still. So the technology has to advance further for them to really come on board. So once we have these technologies ready and alternative fuels are marketed, then the global shipping market will perhaps be swept by all those alternative fuels. So based on the vessels, this is the data that we have analyzed. And on the NSR is a Northern Sea route and SCR is a Suez Canal route. So comparing one to one, this is the fuel cost and other segments that we compared. So the numbers may differ depending on the ice class and how much containers are carried. Here we assume 8,000, 14,000, 24,000 TEU size of vessels. The cost effectiveness analysis is presented here, and along with the carbon neutrality plan while using alternative fuels, this is the level of economic viability that we can foresee. So we plan to operate these vessels, and we started with the research first. What will they look like? What's most important is that for UAVs, what's most important is field data. In the ocean, there's wind, there's water, and all that type of data must be presented in a real-time manner. So for the polar regions and the ocean, we need real-time data that's provided to the integrated system. So sea ice, currents, winds in the Arctic, all those different information must be fed through to our system, whether it's by using small satellites or simulating with a model. The results need to be delivered to those of us in the industry so that we can make ships that really best fit the environment. So here you see how, based on the platform, we collect different data from the ocean to build ships and ultimately carry cargo. And there's much talk about the ship type design, which is fully advanced. And because safety is very important, there are different safety measures and equipments on board. And as you can see here, this is the very tough environment where the cargoes have to go through. And sometimes the weather is too extreme that the ship will be stranded. So we need technology to prepare against such environment. So we've mentioned the environmental side. And next I would like to look at the COARC's planned research by showing you a few examples. I think the most strong point of the COARC is that engineers, scientists, legal experts are all gathered together for communication. As I mentioned before, in predicting the Arctic environment, we can utilize the relevant data. And I think data is key. What type of ice there is, how the ice changes over the years, and where ice was concentrated this year, what will happen next year. All that type of detailed data should be fed through. And as I said, what kind of route will be selected and what type of vessels will be best to service those routes. And we also need to think about the alternative fuel leads in the market. And once there's an entire market formed for an alternative fuel, that's where all the shipbuilding technology will be headed. And same for unmanned autonomous vessels. When they operate in the Arctic for safety reasons, biology, minerals, indigenous peoples, relevant industrial conflict of interest can happen. So what type of legislation and institutions should be prepared to make best use of the Arctic and also keep the Arctic sustainable. So in our planned research, we have categorized different types of topics. So for the science, industry, legal, indigenous people, and policy, we have created different research ideas with different groups of experts working on each of the topic. So our hope is for the industry sector and the science and policy sector experts to come together to engage in deep discussions for a 5-year research. So this amount on the slide is just my hope, what we hope to receive from the MOF. To come to a conclusion on what size of the container vessel is best for the Arctic and what kind of ice class is needed and alternative fuel. So we need to come up with the answer to all these different questions and ultimately place an order with a Korean shipbuilder, and perhaps the Ocean Promotion Corporation can perhaps subsidize these shipping companies who place an order with a Korean shipbuilder, and the shipbuilder can use local content and apply locally developed technology. So in that case, the full value chain will be all joined into one. So as I said before, there are two major perspectives to the Arctic, the routes and the energy. It can be container vessels or LNG carriers. I think LNG carriers are near saturated, and next year tankers and bulk carriers will be brought back to market. The technologies developed so far, depending on the changes in the energy, can also change to service the different types of vessels to be developed. That is all for my presentation. Thank you very much. Thank you.
We will now go on to the next presenter from Daewoo Shipbuilding, Dr. Choi Jung-il, who developed the icebreaker and made a lot of achievements in this field. Hi, everyone. I am Choi Jung-il from Daewoo Shipbuilding Company. Since I have only 15 minutes, I try to really pare down what I wrote down on the PPT slides. So my presentation today will be brief based on specific keywords, and if you have further questions, please feel free to ask me in the break sessions. Today, I would like to talk about a 6-year-old vessel, which is our Yama LNG. And after we delivered the Yama LNG carrier, of course, we did other projects, and we are preparing in other areas. So I would like to share some explanation on this as well. After my presentation, I think the one key takeaway that all of you, I hope, would get is that Daewoo is very technologically advanced and that we're trying to make various efforts to this end. Yama so there was an onshore plant in Yama, and an LNG carrier was needed. In the winter season, it will go towards Europe, through Suez Canal, and then to China. In summer, it will go through a different route to come into China, and the orderer wanted these kind of specifications in its vessel. So our proposal looked like this. It would operate in minus 52 degrees Celsius, and it would even able to navigate ice thickness of 2.1 meters when the max back then was 1.8 meters. And also have the same ship speed as a just general regular 19 LNG ship. So we got the order for 15 vessels, and we managed to deliver all 15. It is 300 meters in length and 50 meters in width. I talk about the breadth because the biggest icebreaker is only 40 meters in breadth. So I wanted to stress that this is bigger than an icebreaker, and it needed to icebreak on its own because it could not follow in the paths of an icebreaker which was smaller than it. It is nearly the same tier or same class as a Russia vessel which can go to the North Pole. Arc 7 class has a specification of breaking 1.5 of glaciers, but we have more capacity than that, and the driving speed is also higher than that, and it's more heavy. So this LNG carrier has a capacity that is similar to that of an icebreaker level. I have a short video clip, and it's a video that we brought from the North Arctic itself, and it's a rare video I wanted to share with you, so we'll play it.
예, 저희 선박은 더블 액팅 베셀이라 앞쪽과 뒤쪽으로.
We can do ice breaking both on the front end and the rear end. So this shows the ship advancing from at a level end, and as it goes, it breaks through ice. I show you this video clip and it's a rare video clip because while it's our Arctic vessel, we don't intentionally go through ice, but to create this video, to do this test trial of our vessel, we broke through ice and we captured the video for further use. Ridge penetration is Big Mac in our own terminology, and if you pass through the Big Mac, because the friction is low, lemming happens because you go over the ice. The friction is because the friction is so low, but because our vessel was so big, we couldn't go over the ice, but we had to go through the ice and penetrate it and break the ice.
굉장히 느린 속도로 갔기.
It went at very slow speed, so let me make it faster. You can see that there's no much shaking, and the Big Mac was a big Big Mac with a deep depth. After we delivered this vessel had the highest performance and the biggest vessel using the NS route. And in 2017, after we passed the NS route for the first time, the next navigation, it took 9 days to make the passage. We have a record on that, and 10 days and 17 hours, as you can see. The average speed is recorded as 12.8 knots, which means that it is moving nearly at the same speed as a general LNG vessel through the NSR. The right article is the most important one. This started navigation and shipping in winter, February, and it started in winter, which means that on the NSR, sea ice was scarce because it was already broken by an icebreaker. But on the other hand, because our vessel performance was very good, we could make the first voyage in winter. And while not all conditions were optimal, I think for our next project going forward, we'll start journey in winter. The business plan from the first Yamal project needs to be changed then. To develop this Yamal LNG from year 2002, we had joined researchers with many foreign research institutes. Even in 2002, we were one of the famous shipbuilders. So when it came to general just sea, we had no problems. But polar environment was a totally different environment, which had different factors such as sea ice, low temperature, and extreme lighting conditions. These three conditions make the polar sea very different from general sea. So we were thinking about ways to overcome these externalities with excellent design. And since our first research effort, after 10 years from our initial research, we won the first order in this polar project and implemented it. So to overcome sea ice, what we did was change the shape of the vessel. We call it hull pop, and the form of the ship. And we thought if we make the form of the vessel sharp, it could break the ice better, but if you make it wider, it wouldn't be as sharp, so it wouldn't be able to break the ice as easily. We did a lot of research on this form. And the vessel form in general sea versus the polar sea is very different. If one vessel breaks ice well, it doesn't work as well on general sea. And finding the right balance needs experience. We did a lot of tests and trial runs, not only LNG, but bulk carriers or other carriers. We studied about 5 types of vessels, and through 100 test experience on them, we extracted the required design specifications. Yama LNG has a double hacking system which breaks ice on the front end and rear end, so it actually knows in the operating scenario we have looked at, we have also contemplated in which cases it is better to go with the front end ice breaking versus the rear end ice breaking. This is another risk factor. So for each class in the vessel, the amount of weight that one has to endure is defined. As you see on the left, however, because of sea ice, many vessels were damaged, although it was built to endure weight. The number of polar vessels is much smaller than general vessels, but it gets damaged much more compared to general vessels. This shows that the statistics on sea ice is not very accurate, and many unexpected things can happen in the polar regions, and that is what we also learned. To overcome the sea ice and potential damage from sea ice, we looked at various scenarios that could happen in the polar region. For example, how can we make the vessel withstand collisions with sea ice and so on. NSR vessels rarely collide with sea ice and iceberg, but we needed to consider the potential risk as we built out the design, so we've even factored in that scenario where there's a collision with an iceberg in an NSR. And I just showed you, and Dr. Kim showed you a video clip on Suez Canal, but in the Arctic Canal, if there's an accident, you cannot endure it as easily. In the Arctic, the accessibility is very low, so if a ship gets stranded or damaged in the Arctic, this could mean a big disaster. So we were very cautious about the form and shape of the vessel. After designing these various and myriads of scenarios to really validate if this would be okay, we did real collision tests. In the center, the graph below shows you our test collisions. This vessel gets more weight and pressure compared to other LNG vessels, so we used high-strength materials. And how much we would use high-strength materials at which strength requirement were also covered in our studies. Lastly, we installed gauges and measurements to understand how much power we would need and check that data against our predictions. And also in terms of safety, we have finished those measurements and analysis. These were the risks related to ice. Now on temperature, the photo on the left is the photo taken on the next day of our test run. So in the deck or rail, just in one day, icing or snow piled up like that. And to overcome this temperature factor, we call it winterization. The key facilities had snow melting capabilities. And we also prioritized the importance of devices or components inside the ship to know which one should be melted or versus later on. But as you know, if there's a big temperature gap inside the ship versus the outer ship, frost keeps happening. And to prevent this, we would have better air circulation so that the temperature gap does not lead to such frost. And we have also an ice finding radar, and this radar also has a winterization function. And that is how it is navigating right now. And we went in the deep dark night one day, and even though we had a search and radar, two seamen always had to stand watch to find ice. So I know that we have not fully overcome this challenge. And because the vessel is made out of iron, if you knock on iron, it oscillates and it vibrates. And if there's vibration, then it means that there's noise coming out from that vibration. And what we developed for Yama was how much the vessel would oscillate or vibrate when it collides with ice and so on, were one of the measurements that we took when we developed Yama. Next is construction. Because it's an icebreaker, it had much more materials and ingredients compared to a general vessel, and it was all compacted in a tight space, which made it difficult to build, and this had greater quality implications. The vision and the goal of our shipbuilding company is to improve quality, so we built a separate mold for this. And for high strength materials, they have to endure and go through high heat. So we also developed a heating facility and heating equipment in the construction just to build this Yama vessel. So we built it well and did a test run in General Sea and also near the seas in Russia, and then finally delivered to the customer. Now let me talk about our future project. In the Kiran Peninsula, LNG vessels are needed as well. And if we just take the two, the amount of LNG that is buried in these two fields is very big compared to the rest of the world. The business proposal by Novatek looks like this. In the Arctic, it would run an Arctic vessel, and in Murmansk Sea and Kanchuk Sea, they would have a structure set up and make the export from a general LNG vessel. So Russia made some amendments in its business plan, and the projects that were ordered was ARC-2 and also LNG storage facility. Because we did the Yamai project successfully, Daewoo won both of these contracts. And we needed to develop a higher spec vessel compared to the Yamai. And we are currently actually doing that and building it, and we're building these 6 new higher specification vessels. ARC-4 vessel is one of the top tier vessels, and we have won the order for an ARC-4 vessel, and one vessel is nearly complete. We are working on the second ARC-4 tier vessel. As you see on the pictures on the right, next to the storage system, Arc LNG stops by, and the general LNG vessel is able to approach and to make the final journey in the export. Our company has been developing smart platforms and is installing this technology on our vessels. 40 of our vessels already have this smart technology on it. It is on the left. You see the smart platform center. And with this screen overview, you can see the route that the ship is going in and the performance of each equipment or module that are inside a vessel. And this can be customized to the customer's need. And you can see how the ship is doing from land remotely. And we're thinking of installing this view and smart technology in Arctic vessels. And we are working together with Dr. Kim Hyun-cheol's team on this. We now have the capacity and visibility on sea ice distribution. And Dr. Kim Hyun-cheol is projecting even the strength, not only the distribution of sea ice. If we know the thickness, strength, and distribution of sea ice, then Teo can do the simulation of what will happen if a vessel collides with such sea ice. So with this information and insight, we can design a vessel to move around well and also contaminate less as it moves around. There will be various sea routes and navigation routes which we will be able to determine based on this smart technology data system. And on a real-time basis, we will be able to inform the vessel on a better route. It is called green ship technology. And as for LNG, Yamal, it is using LNG as a fuel already. So among the existing vessels, compared to other vessels, this ship is much more green. It is less contaminating and emits less contaminating elements. For any current vessels, we're trying to put in LNG in, and most of the recent orders that we won were LNG vessels. On LNG, like the Yamal LNG, Yamal LNG is an electricity-powered vessel. The power generator is run on LNG, and electricity produced from that runs the ship. But other ships run an engine sometimes. LNG is not a new technology for Daewoo shipbuilding. So having LNG on general regular vessels is also a task that we are already doing. And these Type C or Type B LNG storage systems are being designed and built by Daewoo Shipbuilding directly. Through these various storage systems, we are also trying to apply them to ammonia, hydrogen, and other alternative energy sources. Energy reduction system is another factor. From various small ingredients or devices in the ship, we would have the storage systems which help the operation of the vessel, and we're studying what would happen if these devices collide with ice. Another potential area that we're focusing on is going into the Arctic through offshore structures. And on another end, container ships. These two topics, we have studied them for at least 5 years. And as for the offshore structures, it will be in the shape which breaks ice well. We are studying which form is better for breaking ice and what form should be done. And for a container ship, we're looking at the propellers. I seem to be over time. Thank you very much. Thank you. It's a very important topic, but because we have limited time, I would ask the next presenter, I'm very sorry, but to reduce the presentation a little bit so we can take at least a couple of questions.
안녕하십니까?
Good afternoon. I am from the HHI NSSBU, Kim Ki-tae. I'm a senior engineer. As I prepared this presentation, in order to design, research, build, and deliver one vessel, I wasn't sure how to explain about the entire process within a limited time. And although there's much to say, it was difficult to prepare the presentation to fit the time. And I had to run through my slides because of the interest of time. And going forward, since today is only a beginning, I look forward to more work with COARC and KOPRI, especially at COARC since HHI is a member, and we will make sure to do more at COARC. And when I return to my company, I will let my colleagues know. Thank you for this opportunity to present. And today I am going to present the Aotearoa that's been delivered to the Royal New Zealand Navy. I hope to contribute to our Arctic market entry and to all of you here today in developing the next generation IBRV. This is the order of my presentation. I will start with a very brief introduction of my company, followed by project overview, Antarctic resupply mission requirements, design technologies of our first Antarctic resupply mission completed this year. And these will be the main parts of my presentation. Our company celebrated the 50-year anniversary, and we changed the company name to HD Hyundai. I work under the KSOE, under the HHI at the Naval and Special Ship Business Unit. In 1971, our company was established, and we celebrated the 50-year anniversary. Our NSSBU delivered the first Korean indigenous frigate, Busan class, as well as Aegis destroyer. And for polar class vessels, we do have special vessels that have been designed, built, and delivered successfully. 1,300 employees are at the company, about 400 of which are R&D experts. So moving on to the project overview. The name of the project is MSC, Maritime Sustainment Capability. The project was ordered by the New Zealand Ministry of Defense. The vessel, after delivery to the Royal New Zealand Navy, has been operated by the RNZN. We were in charge of R&D, design, shipbuilding, and delivery. The main vessel class is AOR, which is a military sustainment vessel. The ship name is HMNZS Aotearoa. Aotearoa is in Maori and is the name of the country, New Zealand, in Maori. So this just signifies how important the project was. The classification was received from Lloyd's Register. The ship was ordered in July 2016 and commissioned in July 2020. LOA is 173 meters, breadth 24 meters, depth 12.5 meters, and displacement is about 26,000 tons. This is quite a large naval vessel. These are the key specifications. The propulsion is a Codlat 2 design engine, 2 diesel engines, and 2 electric motors, and 4 diesel generators are on board. The liquid cargo capacity is about 9,500 tons, and because this is a military sustainment vessel, oil will be carried by the vessel for supply to other vessels, and this ship can also be used to supply oil to the Antarctic stations. Solid containers, we have 12 TEU containers that can go on board, 100 berths, range is 6,750 nautical miles. As this is a naval vessel, the NR naval rule applies. Naval Ship Code, SOLAS, MARPOL, and the general rules that apply to commercial vessels also apply to this vessel. And there were several notations applied as well. Ice class PC6, winterization C-25, SDA, FDA ice also applied for the hull, and these were all related to polar class vessels. This is a naval vessel, but other than military missions, the vessel also serves Antarctic resupply missions. So in normal times, the vessel will operate as a naval vessel, but once a year or maybe twice a year, it provides resupply to Antarctica science stations. Just briefly, let me wrap up that project overview, and now I will just focus on the Antarctic resupply mission requirements, which is relevant to the topic. This vessel, I'm sure some of you have already been to Antarctica, but right next to the Changbogo base, there's a Scott base held by New Zealand. There's the Antarctic base there. And in order to supply the base, MacBoard Station Ice Pier is the destination where the vessel has to travel to. Throughout the year, the vessel does not travel to Antarctica throughout the year, but from December to February, when it is summer down there, when the temperature and ice conditions are right, they would choose the right timing to provide resupply services down to Antarctica. Leaving New Zealand all the way down to McMurdo without a transit, the vessel will travel directly. This vessel is not an icebreaker, and there has to be an escort by an icebreaker. In designing this vessel, and to operate in the Antarctic environmental conditions, temperature is very important. And for the vessel, MDLT is about minus 15 degrees, PST is about minus 25 degrees Celsius, and so depending, the vessel has been designed to as per these defined conditions. The McMurdo Station, Ross Sea, Northern Ice Barrier, in the actual Antarctic waters and ice conditions. Based on the data collected by the boat team, we designed the vessel. So those were the requirements, and in order to satisfy those requirements, the Hyundai Heavy Industries applied this following design and technology. In designing polar class vessels, what's most important is customized naval ship design to be also to incorporate engineering, own design and technologies, as well as customization that fit the requirements of the owner and the conditions of operation. So we had to combine all these different sectors to present a polar class naval ship. So we are discussing the Arctic, and at the NSSBU in the Northern Sea, we have designed a vessel that can operate in the Northern Sea. So I wanted to include this in my slide. In 2007, the 7 Arctic was delivered. It was heavy constructed. Ice class only, winterization, it was applied for this vessel to operate in polar waters. The vessel is eco-friendly as well. Fully electric propulsion system is applied. For polar vessels to be designed, what's most important is in the engine to satisfy the conditions presented by the owner and the environment, and to comply with the international rules, and to customize our own design and technologies to fit the needs of the owner and to tailor the different requirements. We had to have regulatory meetings and to acquire polar ship certificate. So the entire process were all important in designing a polar operated vessel. I think it takes a little bit longer, so let me just speed up. For the hull, PC6 notation, SDA, FDA ICE notation were applied. So as you heard before, we have a very meticulous scantling throughout the board, so it was very difficult to design and work on. Through different interpretations, polar level ice conditions were fully met with our vessel. We applied the ridge hull, leach bow to reduce the resistance and enhance performance. We enhanced scantlings and higher grades EH36 steel and extra thickness was applied to counter the corrosion and abrasion against the ice. And for paint as well, we applied anti-abrasion paint in ice conditions for anti-abrasion epoxy paint. Propulsion system, as I mentioned before, we have a hybrid propulsion system, cod-lat system. Electric motor can run the boat in an eco-friendly manner. And we also applied selective catalytic reduction. So although the polar areas are not defined as a Tier 3 area, we did apply the same technologies anyhow. And we use ultra-low sulfur fuel. IMO Tier 3 EIAPP was acquired. For PSMR, self-berthing capability, and other types of technologies required for survivability and polar operability have been applied. Safety case and risk assessment were analyzed to prepare against any dangers that may arise in polar operations. Winterization C notation was applied for anti-icing and de-icing solutions. Water ballast tanks, steam lines, or heating tanks, and other facilities for de-icing were applied. We would also use heated seawater for tank cleaning and freshwater generation. Sea chest also was designed so that even small ice, when that goes into the ship from the polar waters, can be sent back out. And in polar regions, ice pier damage has to be minimized, and so we apply sacrificial bilge keel to prepare against anti-roll and also to fit the vessel to meet the conditions of the polar waters. And what's also very important for polar operated vessels is life-saving equipment. I think this was the second time in the world where polar code was fully applied for the lifeboats to go attached onto the board, and we had different LSAs for Antarctic operations. Applying all this, we finished the construction. And after testing and trials, we delivered the ship to the owner. And we also applied the same seaworthiness system and acquired the polar ship certificate. The ship owner is the Maritime New Zealand, and Seaworthiness Authority in New Zealand is also in charge of safety. So with these two authorities, we acquired the polar ship certificate through the seaworthiness system. So in 2020, our ship was delivered, and for the first time this year on February 3rd, left successfully for the resupply mission. And USCGC Polar Star, the icebreaker, provided escort. And luckily, the ice was already removed, and we were able to arrive at the Antarctica safely. And when we returned, there were a few ice on the sea. So, but because the ice was just within the level of PSC that the vessel was capable of, we were able to safely move out of Antarctica on our own and return home. And so in operating in polar waters, designing and building a ship to be operated in those waters, we designed a naval ship, but this special ship requirements and customizing the ship to meet the needs of the owner and using our own design and technology capabilities and tailoring all that to the needs were the key part. Thank you. That concludes my presentation. Thank you very much.
네, 감사합니다.
Thank you. As I listened to the presentations, I was very impressed by our shipbuilding industry. I have to apologize because from 3:30 we have another session joining, and we need to end by 3:10 because there is some visual testing that we need to do before that 3:30 session. So I don't think we can call people up to the stage and have a fully fledged discussion, but instead there were various use cases introduced to use vessels, eco-friendly use vessels as a means to achieve carbon neutrality. While we talked about the large-scale vessels, there's also electrifying smaller vessels that we can use near the coast to help achieve carbon neutrality as well. And in a company called it's a green technology company, and we have the CEO from the company to introduce about the tech.
Opportunity to speak a little bit about our company. It was thank you for your excellent presentations. It was really interesting to see how far you've come in so many ways in your technology. But I come from Iceland, up in the north. We have our goals of carbon neutrality by 2040. And fossil fuel will be phased out by then as well. There's a ban on new fossil fuel cars being imported to Iceland in 2030. So, and we are turning our shipping fleet to green power, green fuel. And my company's name is Grænafl. It's a very hard name for non-Icelandic speaking people, but it means green power. And we have government support because our aim is to fully electricize the small fishing vessels, coastal fishing vessels. But you also have the opportunity to do electricity, green fuel, hybrid research. It is in accordance with Iceland's Arctic policy, which is focusing on reducing the use of fossil fuel in the Arctic. And we have entered a partnership with one of Iceland's largest power company to provide us with the green power that Iceland has in abundance. So we are working on the electrification, as I said, refurbishing the coastal fishing boats, and also hybrid with green fuel so that the boats will be CO2 neutral. I have been in Korea having discussions with Korean, hopefully partners in the future, both regarding research and development cases or projects, and also just manufacturing and equipment. Because although these are small boats, it is a big opportunity to do R&D projects that you can later scale up into larger boats. We are looking at electric propulsion systems and batteries and such, and can use the green energy of Iceland in these projects, be it R&D projects or just manufacturing with equipment that we hopefully will get from Korean partners. So, 감사합니다.
질문이
So I'm sure there are many questions that come to mind, but we don't have time, unfortunately. So today we discussed the eco-friendly economic activities in the Arctic, and we realized that green shipping is so important, and technological support to make this happen is very urgently needed. And this will all require much research and preparation ahead of all of that. Russia is eager to supply energy to Asia, but Europe will not let that happen easily. Oil will become more and more unpopular. We will find new sources of energy, and strategic resources and minerals will become more and more important. We don't know when that will happen, but I think that was the key point of this discussion. And I promised to wrap up by 3:10, and I'm very sorry, but let us meet another day for further discussions. Despite my rushing you, thank you all for finishing up your presentations on time. Thank you very much.
네네 사진은 계속 예예예. 저 정식 우리 포토그래퍼가 찍어서 예예예.
Oh.
So you might
No.
want to take you.
Yeah, I was going to take it off, but oh,
Okay, that's good.
Yes.
okay.
Okay.
Yeah, it already works.
So the organizers will automatically put on the on and off.
Yeah, I see
to
it's
your
still
mic.
on.
So when you're off the stage, mic will go.
Good afternoon. Good afternoon, Excellencies, ladies and gentlemen. Welcome to the International Arctic Science Cooperation Seminar. Today's event is an annual event with the Danish and Norwegian embassies in Seoul, as well as the Korea Polar Research Institute. And it is a part of the 2022 Arctic Partnership Week. Today's theme is From Svalbard to Greenland, New Endeavors for the Next 20 Years of International Arctic Science Collaboration of Korea. My name is Anu Fredriksson. I am the Executive Director of Arctic Frontiers in Tromsø, Arctic Norway, and it is my pleasure to guide you through today's program. In addition to all you distinguished guests here in the room today, we also have an audience online. A warm welcome to you all. We have a wish of making today's session an interactional one, which means that we welcome questions both from the audience here in the room as well as online. We have people monitoring the online chats, and your questions will be relayed to me. So please feel free to pose questions and actively participate. It is my great pleasure to introduce today's first speaker. He is the president of the Korea Polar Research Institute, Sung-ho Kang. He was appointed in his position in 2020, and he has an extensive polar experience from the Arctic and Antarctic. He has previously served as the station leader for the 23rd Antarctic Overwintering Party at the Antarctic King Sejong Station, and he has expertise on a broad range of topics within Arctic oceanography and biology. President, the floor is yours.
Thank you, Anu, and Norwegian Ambassador Anne Kari Hansen Obin. I prepared my talk in Korean. Please understand the situation. So you need to have a translator. 예, 안녕하십니까. 극지연구소장 강성호입니다.
Good afternoon. I am President Kang Song-ho of KOPRI. First of all, well, again, Honorable Ambassador Designate Anne Kari Hansen Ovind of the Royal Norwegian Embassy and Ambassador Einar Jensen of the Royal Danish Embassy in Korea, online on-site participants, MOF team leader, thank you very much. At this International Arctic Science Cooperation Seminar, it is an honor to welcome you. I'd like to take this opportunity to thank the co-hosts, co-organizers, the Royal Norwegian Embassy in Seoul and the Embassy of Denmark and Innovation Center Denmark, Seoul. And I'd like to thank all speakers, and in particular our international speakers who are joining us online very early in the morning in their local times. Korea's Arctic Research Program, as mentioned before, is led by the Dasan Station, which was opened in 2002 in the Allison, Norway research community. And since then, we have been continuing to develop with our international partners. We have on-land ecosystem research, as well as permafrost and atmospheric observation, and fjord paleoclimatic research. And these outcomes have led to monitoring of pollutants and climate change in the circum-Arctic region, using UAVs to observe the cryosphere of Greenland, and research into the northern Greenland paleobiology. In Svalbard, as a member of SIOS, we have recently joined, and there's the Arctic Passion project led by the EU to observe the circum-Arctic region. And Korea has thus been quite active in sharing knowledge through international cooperation and creating a more synergetic effect. In this vein, this year's International Arctic Science Cooperation Seminar involves the key leaders of Korea's Arctic programs and international partners as speakers to discuss the past and present of the Arctic cooperative research with the participation of Korea. And after the two sessions, we will invite the Secretary General Anu Fredrickson of the Arctic Frontier, the Executive Director, will moderate a panel session with Dr. Lee Yu-kyung from the KOPRI MPI Cooperative Polar Research Center, and also two representatives from Norway and Denmark, respectively, to discuss the achievements of Korea's Arctic cooperative research and to present the prospects for the future. I'm looking forward to that session as well. So once again, thank you very much for coming, and I wish you fruitful discussion. Thank you.
Thank you so much, President Kang. Our next speaker is the Ambassador-designate of Norway to Korea, Ms. Anne Kari Hansen-Ovind. She has extensive Arctic background, having served as the Norwegian ambassador to Canada and also as the director of the Norwegian unit of High North at the Ministry for Foreign Affairs. With her background of over 25 years of diplomatic service, we look forward to hearing from you. Welcome, Madam Ovind.
Ladies and gentlemen, dear participants, the Norwegian Embassy is very pleased to co-host this International Arctic Science Cooperation Seminar with the Embassy of Denmark and KOPRI. I had the pleasure of visiting the headquarters of KOPRI for the first time just a few weeks back. In fact, KOPRI was the first Korean institutions that I visited as a new ambassador to Korea. And it seemed all natural to me, as I have had various responsibilities pertaining to Norway's Arctic policy throughout my career in the Ministry of Foreign Affairs, and have a particular interest in polar affairs. But more importantly, it was absolutely necessary, as Arctic cooperation plays an important role in our bilateral relations, and KOPRI, as the lead agency for Korea's polar program, is an important part of that. For Norway, it is important that global discussions on Arctic issues are knowledge-based. 1/3 of Norway's land territory lies north of the Arctic Circle, and some 10% of our population live there. The region contributes significantly to the Norwegian economy, and the Arctic, as we have discussed earlier today, is also the region most affected by climate change. This is why knowledge is at the heart of Norway's Arctic policy, and my Arctic research is prioritized an area in Norway's long-term strategy for higher education and research. The Arctic is in fact home to many of Norway's most advanced research communities and centers of excellence with focus on maritime fields, fisheries, resource management, and environmental issues. The city of Tromsø is home to the world's northernmost university, the Arctic University of Norway, a flagship on Arctic Norwegian research. The University Center of Svalbard is the world's northernmost research and higher education institution, hosting nearly 700 students yearly from all around the world. And I'm very pleased to hear that you will have speakers from these places later in the seminar. The Arctic is one of the most developed fields within research collaboration between Norway and Korea. Several MOUs have been signed between Norwegian institutions and Korean counterparts on research cooperation. researchers from Norway and Korea work together in joint expeditions and participate in global research projects, such as the Synoptic Arctic Survey, where Norwegian and Korean icebreakers, Kronprins Haakon and Araun, participated, I would say, side by side. Another example is collaboration between the Norwegian Center for the Ocean and the Arctic and the Korea Maritime Institute to combat marine plastic litter in the Arctic. These are projects highlighting how we can work together in the Arctic fighting plastic pollution as a global problem. As the region is warming twice as fast as the rest of the globe, climate change is a driving force in Arctic research cooperation. Norway has facilitated international polar research in Svalbard for more than 50 years, and the Ny-Ålesund Research Station is one of the world's northernmost year-round research communities. I am pleased that KOPRI is one of the international research institutions present here. In fact, you mark 20 years this year. Congratulations. Norway values the production and sharing of high-quality research at Ny-Ålesund Research Station, and KOPRI's contribution to Svalbard Integrated Observing System is very much valued. The Norwegian government decided last year to include Korea in its panorama strategy, making Korea one of the 9 strategic partners within the field of higher education, research, and innovation. Arctic research is very much at the center of this strategy, and I am confident that the collaboration between our institutions will develop even further in the years to come. The achievement of many of the UN Sustainable Development Goals will heavily depend on science and international cooperation, also in the Arctic. Thank you for your time. I wish you all a successful seminar. 감사합니다.
Thank you so much, Ambassador-designate Anne Kari Hansen-Ovind. Next, joining us digitally, we will hear from His Excellency, Ambassador Einar Jensen. He assumed his position as the Ambassador of the Kingdom of Denmark to Seoul in 2019. Ambassador, we look forward to hearing from you.
Distinguished guests, researchers and co-hosts, I am Einar Jensen, the Ambassador of Denmark to Korea. Let me start by extending my warmest welcome to all of you participating in today's seminar on international Arctic science cooperation. Also, I would like to share my sincere appreciation for our co-host, Korea Polar Research Institute, and our colleagues at the Royal Norwegian Embassy in Seoul. The Embassy of Denmark is very happy to be part of this important seminar, where we highlight the importance of international Arctic science collaboration and where we celebrate the 20-year anniversary of South Korea's Dasan station in Ny-Ålesund in Norway. The Arctic Partnership Week serves as a strong platform to share the latest Arctic knowledge with researchers from Korea, Denmark and Norway, as well as other countries interested in participating here. It is impressive to experience dedication and knowledge among the finest researchers on this issue. Last year, during the Arctic Partnership Week, the Ministry of Oceans and Fisheries of the Republic of Korea and the Ministry of Higher Education and Science of Denmark signed an MOU on polar science and technology cooperation. This MOU is a statement of the importance of international science collaboration, not least within issues relating to climate change. The spread and effect of climate change is seen quite clearly in the Arctic regions, and it is triggering cascading impacts on biodiversity, human livelihood, and the security all over the world. Your presence here today is an important step in the joint international action to combat climate change and slow down the clock on global warming. I wish you all a successful session that will hopefully lead to further collaboration between our countries. Thank you very much. 감사합니다.
Thank you, Ambassador Jensen. Before we start the first part of today's program, I would like to invite all the participants to the stage for a group photo. So please, if you may. Leave tomorrow. Thank you. Thank you so much. Now, let's get ready to move forward in the program. Part 1 of today's program focuses on the lessons from model cases of international Arctic science cooperation, and it provides us some highlights from well-sustained Svalbard-based research portfolio in the Arctic. Again, I would like to remind all of the listeners that there is an opportunity to pose questions. I will monitor the floor here, and we have people monitoring the chat online. The first presentation is by Professor Mathias Forvik and Dr. Seong-il Nam, and it focuses on scientific collaboration between Korea and Norway. Professor Forvik is the head of Institute of Geosciences at UiT, the Arctic University of Norway. Dr. Seong-il Nam is the principal research scientist, Division of Polar Climate Research at KOPRI, and the presentation will be given by Professor Mathias Forvik. Professor, the screen is yours.
Yeah, 안녕하세요. Good afternoon, good morning. Thank you for the nice introduction. Dear President, dear ambassadors, and dear other guests. Yes, my name is Mathias Forvik. I am the head of Department of Geosciences at UiT, the Arctic University of Norway. My background is marine geology. And together with Dr. Seong-il Nam, I have compiled some slides to show you some examples about the scientific collaboration between Korea and Norway based on marine geosciences. Next, please. Or next slide, please. So we structured the talk in the way that I first tell you a little bit about where I am from and a few words about UIT, then give you some examples of infrastructure that we have access to, and then some examples of Korean-Norwegian collaboration on Svalbard, and at the end I would like to summarize. Next, please. So where I am from. Next, please. Most of you are probably familiar with Tromsø. Tromsø is in the Norwegian Arctic. It is dark at the moment. The sun will return in January or something like that. We have some snow on the ground and we have had a lot of northern lights. And and I want to talk about Svalbard, of course, and I hope you have a good time in beautiful Busan that you can also see on this map. Next, please. UIT, the Arctic University of Norway, was founded in 1968, and it is spread over all northern Norway. It has more than 10 study places. The department that I am leading and that I am belonging to is the Department of Geosciences, which belongs to the Faculty of Science and Technology. And at the bottom of this slide, you can see the logo of UIT, which shows two ravens. The ravens Hugin and Munin, and they are sitting on shoulders of their host Odin. They fly out during the day, and in the evening they come back, sit down on his shoulders and tell him what they've experienced during the day. And this is what we try to do here at UIT as well. Next, please. A few examples of the infrastructure that we are very privileged to have access to. Next, please. Includes, for example, next slide, please. Yeah, thank you. Access to a new, relatively new ice-going or ice-breaking research vessel named Kronprins Haakon that allows us to go into more central parts of the Arctic Ocean and to do multidisciplinary research during such expeditions. Next, please. And UIT is also extremely privileged to own its own research vessel, the Helmer Hansen, that has been used a lot during the Korean-Norwegian collaboration so far. And this is actually a photo that I took during one of our expeditions in 2016. Next, please. When we are out at sea with Helmer Hansen, we can collect a lot of data that are subsequently analyzed here in Tromsø, at other Norwegian institutions, and primarily then in Korea. But when we are at sea, we can collect different types of data. Next, please. So we can collect so-called acoustic data. That means that we send sound waves from the ship through the water column to the seafloor, and then the sound is reflected at the seafloor or in the seafloor. It's like an echo when you're standing in front of a wall and shout against the wall. And all this information is collected for different purposes. If you look at the next slide, please. When we use this so-called multi-beam echo sounder, we can make landscapes maps. We can make maps of the landscape of the seafloor. This can tell us a lot about how glaciers have been behaving in the past, where there was ice, how the ice has moved, how the ice has melted away, and such information. Next, please. Another method that we are using is so-called penetration echo sounder. So then the sound is a bit louder, and then it goes into the seafloor, and you see this wiggled line or hummocky line, the uppermost line. This is the seafloor, and then you see a lot of lines beneath the seafloor. And this shows the internal structure of the seafloor, and this can also tell us a lot about how climate has been in the past. When we want to take samples, we can say, okay, we would like to take samples here, and then analyze these samples further to say more about the environmental development in the area that we are investigating. Next, please. We have also access to a very special system here at UIT where we can make three-dimensional maps of the area below the seafloor. There have been, for example, ice ages before the last ice age. And looking at such data can help us to understand how ice in former ice ages has behaved, for example. Next, please. So when we have used all the acoustic methods, we can take samples from the seafloor. Next, please. And we can do this by taking so-called sediment cores. So sediment cores contain information like the clay and the sand. Many people call it for mud or dirt, but we scientists, we call this for sediment because the sediment can tell us a lot about the past. It is an archive of the past. Next, please. There are different ways how to take sediments from the seafloor. We have a so-called multi-core, so you can take multiple cores. You see on the left picture, there are several barrels that are vertically standing and where you have material from the seafloor. To the right, you see an example of how this looks like. So you can see the brown material, which is the sediment on the seafloor. And then you see the water that is on top of the sediment. Next, please. If we would like to have more material, then we can take so-called box cores. Then we take a much larger piece, as you can see to the right, and that gives us a better impression of the larger area of the seafloor. You see it's very smooth. There are some warm tubes sticking out, and then we can take samples from that. Next, please. If we want to look further back in time, then we take so-called long sediment cores. I hope you can see this on the left image. There is a kind of a dark gray needle sticking into the picture from the top. In the center of the top, there's a dark gray needle. This is a so-called gravity core. In this gravity core, we have a plastic tube, the black tube that you can see in the middle of the picture. And in this tube, then we can find information about how the sediment looks like several meters below the seafloor. And in the picture to the right gives you an example how it looks like in one of the fjords on Svalbard. And once we have done this, we do a lot of laboratory analyses and investigations, and then we use this archive to find out how the environment has changed in the past. Next, please. So now I would like to give you some examples of the successful Korean-Norwegian collaboration that we have had on Svalbard so far. Next, please. I've had the privilege to collaborate with scientists from Korea for about 20 years, so it started quite early in my career. And all the institutions that you see listed here have participated in expeditions that we have organized to Svalbard. It was primarily under the lead of KOPRI and Dr. Sung-il Nam, who's the co-author of this presentation, and we have had a very trustful collaboration for a very long time. Next, please. Here are some things from the good old days to the left, getting to more recent times. To the right, you see that the group is also increasing of participants. I think the largest group of Korean scientists was 12 people that we had on our ship, and we always sailed on the Helmut Hansen that the Koreans rented for some days and got access to, and we then operated 24 hours a day. So it was a very efficient cruise, or these have been very efficient expeditions. Next, please. Again, in 2017, the weather wasn't that good, but you see there is this mix of people from Korea, people from Norway. There are people from our former rectorate actually participating in this expedition. And we all helped each other and make this expedition to a success. Next, please. In 2019, the group was even larger. And next, please. In 2021, we could not carry out an expedition, but this year we managed to come together again. And this time we also had colleagues from Sweden, from Germany, and from other Norwegian institutions joining us during this expedition. Next, please. So why are we interested in studying the fjords on Svalbard? If you look at fjords, you can regard them as small oceans. So they you can study processes that happen in the large oceans, but at a smaller scale. Then the fjords are affected by the so-called very distal branches of the North Atlantic Drift. You see a lot of red arrows in the right part of the figure that are pointing towards the north and that are passing by Svalbard. And this is the so-called Gulf Stream or North Atlantic Drift. And if changes happen there, they ultimately affect the environment on Svalbard. At the same time, you can also study local environmental changes by looking at the fjord sediments. And because you are close to sediment sources, you can also have a so-called high temporal resolution. That means with the sediments that you retrieve, you can look back at a very high detail for several thousands of years of this very good time information. You have glaciers on Svalbard today, and this reflects like conditions that have been in Norway during the last ice age. And of course, you have very good infrastructure on Svalbard. You take the plane to Svalbard, go on the ship, and then you start to work. And you do not need to sail for several days before you come to the area that you want to investigate. Next, please. So if you look at this map, you see this white line that outlines how the ice extent was during the last glacier for about 20,000 years ago. And you see there is this white line around Svalbard as well. You can see Svalbard in the yellow frame there. So large parts of Svalbard were covered with ice during the last ice age. Next, please. And this resembles a bit how the situation is on Greenland and in Antarctica today. On these maps, you see how the ice in Greenland and Antarctica is moving today. So when you have blue and purple colors, the ice is moving very fast. You have so-called ice streams. And you had them on Svalbard as well in the past. So if you take the next one, please. Again, you see a white line here that goes along a bit off the coast of Svalbard, and you see the thin lines that are merging or moving towards the coast. And these are so-called ice streams in the past. So that's when the ice had its maximum extent. There were ice streams like you have them in Greenland and in Antarctica today. Next, please. And today, large parts of Svalbard are free of ice. Next, please. So that means you have very marked changes in climate and environment in the past, but you also have this at the present, and this is what we want to look at. Next, please. And we have we've done this by visiting all these places that you can see with the yellow dots here. Next, please. And this has so far ended in multiple publications, and there are more publications to come. Next, please. So we experience global warming, and this enhances coastal erosion and increased input of contaminants to the sea, and therefore ecosystem changes. And if we want to predict the future, we need to look back into the past. Next, please. And we do this by looking at the sediments and to understand how environments have changed since the last ice age and how they change at the present. Next, please. We do this going on trips, or going on expeditions, so far primarily on the research vessel Hellman Hansen. We develop proxies. That means we develop parameters that reflect certain conditions, and then we use them to look back in time. Next, please. We have plans for the future as well, and the main goal is to continue the work on Svalbard, but also to expand this to Northeast Greenland, because you see on Northeast Greenland, you still have ice, big ice masses, whereas on Svalbard, large areas are ice-free. Next, please. So to summarize this presentation, we have had a trustful collaboration for about 20 years, and this collaboration has primarily been driven by Dr. Sungil Nam. We had multiple collaborative scientific cruises where we have focused on Svalbard fjord systems. We investigate the environmental changes that have taken place since the last ice age. We develop parameters that we can use to look back in time. We would like to strengthen and expand the collaboration, and one way to do this is to have another expedition that we are currently planning for 2023. Thank you very much for your attention.
Thank you so much, Professor Forvik. Now, next, we will hear of Korean-Swedish collaboration in the Arctic at the New Ålesund Research Station in Svalbard, Norway. With us digitally, we have Deputy Head of Unit and Researcher at Department of Environmental Sciences at the Stockholm University, Radovan Krejci. Sir, the floor is yours.
So, good afternoon to Korea from third Nordic kingdom, from Sweden. So, dear ambassador, dear guests, ladies and gentlemen, I will talk today about our long-lasting collaboration with our Korean colleagues at the Norwegian research station at Ny-Ålesund. Here you see the main participants of this collaboration over last 2 decades. And next, please. And starting with Ny-Ålesund, as it was mentioned also in a couple of previous talks, Ny-Ålesund is an absolutely unique place on the globe because it's an international research village located 79 degrees north, where a number of countries, of which the flags you see on the bottom of the slides, are collaborating over many, many years to understand Arctic climate and Arctic environment, how it's changing, and all the processes and human influence which affects the development of Arctic now and in future. The place is scientifically very productive, where around 700 peer-reviewed papers is published every year. And this number is increasing together with number of collaborating projects and scientists working at Ny-Ålesund. Next one, please. What I will focus a little bit more within the Ny-Ålesund community is a atmospheric research station, which is called Zeppelin, which is located some 500 meters above the village of Ny-Ålesund. It has a long-lasting history, starting sometimes around 1913, but what is most important is the part which happens after 1960. In the second half of 1960s, when after a mining accident at Ny-Ålesund, the village slowly started to change its mission into a research site. And one of the outcomes was establishment of the Zeppelin research station in 1989, which is marked by this green bar. And that's the place where most of our collaboration with our Korean colleagues happens. Next one, please. So what we do, we look at one of the major components of the climate system. We look on aerosols and clouds through different instrumental techniques. Just for simplification, the white ones are those which comes from Stockholm University, and the red ones are those which comes from Korean Polar Research Institute. So we combine our knowledge and our expertise to deliver a very comprehensive, unique data set about atmospheric aerosols and clouds in the Arctic. On the upper row of pictures to the left-hand side, you see our Korean colleagues actually installing one of the instruments studying cloud microphysics. So how many cloud droplets and elements and ice crystals and how big they are, depending on where the air mass is coming, how much water is in the atmosphere, and also how many aerosol particles are present in the air. Next one, please. Why we do it? We do it because Arctic is the fastest changing place on the globe with respect to climate change. The temperature there is increasing 2 to 3 times faster than over the rest of the globe. And that's illustrated on these pictures, showing the change in temperature on right hand, depending on the season. And there you can see actually that most of the warming happens during Arctic winter. And it also shows how important it is to have places like Zeppelin and Ny-Ålesund Research Station, because there are no many expeditions in the Arctic in the winter. And these trends we can get only thanks to the long-term presence at places like Ny-Ålesund. Next one, please. One of the most pronounced effects of changing Arctic is, of course, decline in the sea ice. So this here you can see what has happened in past through the black lines and what is the predictions towards the future. So that it's very unlikely that around the year 2050 there might be years when actually Arctic will be nearly ice-free. Next one, please. And that's driven by the effect of increase of greenhouse gases, and this is what you see from Ny-Ålesund, from Zeppelin stations. In the upper row, you have two very important greenhouse gases, carbon dioxide, increasing from 360 ppm when the measurement started in the early 90s until 2022, when the concentrations reached 420 ppm. And on the right-hand side, you have a similar picture for methane. Next one, please. But at the same time, what happened is that through the economical changes and the technological development and the implementation of new abatement technologies and more environmental awareness, in some aspects, our environment and atmosphere is getting cleaner. And that's also visible on this long-term track of concentration of atmospheric sulfate. From 80s until 2020, you can see this huge peak in the late 80s until 89, where those largest values are associated with a phenomenon called Arctic ice. And that's the transport of long-range transport of air pollution from low latitudes, from Europe, Eurasia, and also North America. And that is linked to another environmental issue, which is called acid rain. And once people understood acid rain and understood that it's linked to acidic deposition, then there was a strong pressure to clean the emissions from sulfur and also from sulfate. And together with political changes in 1989 in Eastern Europe, you can see this sharp drop in sulfates by almost factor of 2. Next one, please. So what we do with our Korean colleagues directly is that what we study life cycle of aerosol particles in the Arctic. So we look at them, how they are born, how they are formed, how they are transported, and how they are processed, interact with clouds, and how they are removed from the atmosphere. Next one, please. Why we do it? In our current understanding of global climate and climate change, the aerosol particles and their interaction with clouds, it possesses the absolute largest uncertainty in our understanding. So if you would like to narrow the error bars and have a better idea what will be the path of the changing climate, we need to better understand aerosols and clouds. And why they are coupled together is that every cloud, actually every cloud droplet or ice crystal, needs one aerosol particle on which it is formed. Therefore, they are so strongly coupled together that it's very good to see them as one entity. And an example of that, how changing aerosol can change cloud properties, you have in the right-hand corner, where you see so-called ship tracks. So when the plume from a cargo ship reaches the cloud layer, provides more aerosol, it results in more cloud droplets and it makes cloud brighter. So that's why you see those ship tracks so nicely. From climate point of view, it means that it can reflect more energy, more light back to space. Next one, please. Next one. So what we do with our Korean colleagues, as I said, we study aerosol life cycle. So over those almost 20 years collaborating together, we've been able to look on how this concentration of these aerosol particles, which makes clouds, is changing over the year. That's what you can see on the left hand side. We can see clearly that the maximum is associated with spring in the Arctic, which is so-called Arctic haze period, when we have an extensive transport of air pollution from low latitudes. Minimum is in the autumn, when we have least pollution, least sources, but we have a lot of cloudiness and a lot of rain and snow, which actually cleans the atmosphere. Then currently with one of the students from KOPRI, Hyun-Jin Kang, we are working on understanding one of the most critical parameters in the formation of clouds. It means how it's linked with, what is a link between atmospheric dynamics and water vapor concentration in terms of so-called supersaturation, which is needed to form the clouds. And then also together with our other colleagues from Alfred Wegener Institute, using remote sensing, we were able to link the concentrations of these aerosol particles, how they influence so-called aerosol optical depths. So it means that how well they interact with light, and it means how much they perturb the radiative balance of the atmosphere. Next one, please. Then we together had an intensive campaign at Ny-Ålesund linked to a mosaic expedition to the deep Arctic during 2019-2020, when we extended the observations and made them more comprehensive and intensive. Next one, please. And then all that is set to context of Ny-Ålesund research station as one entity. Because the Zeppelin, which is shown on in this blue block with the arrow to the top of the mountain, that's the atmospheric research, but only part of it. Then we have also a station called Badet, which is between Ny-Ålesund village and the Zeppelin station, and a lot of remote sensing and additional observations at Ny-Ålesund itself. So together, it represents beautiful, overrepresented, absolutely unique settings in a global scale of atmospheric observations. Next one, please. Then we can extend on the other side of the Fram Strait, and that's what we have already done together with our Korean colleagues and with our Danish colleagues, that we look at the same processes at the northern Greenland of the station called Willum Station. One of the newer established research sites on the northern side of the Greenland. And here you can see actually that together also with the other team from Finland, we were able to look on how the particles are formed. And we can see clearly already now the differences, that aerosol formation in the Greenland is driven by slightly different processes and slightly different compounds than at Ny-Ålesund. Next one, please. So I would like to conclude with a little bit of a view in the future. So the collaboration with our Korean colleagues is it's absolutely wonderful. It's has been now for 20 years. We have published around 20 papers together, only from Ny-Ålesund. And we would like to very much continue at least 10 years more to reach really the climatic scale of 30 years. And further develop the knowledge exchange and especially exchange of students, and eventually extend a little bit more also on the other side of the globe to Antarctica. which already started this year with the first joint campaign at the Korean station in the Antarctica. So with this, I would like to thank you for your attention.
Thank you so much, Deputy Head of Unit Kireitsuki. Now it is time to move forward to part 2 and look at new efforts of Arctic collaboration for the next 20 years. The focus will be on the more recent and expanded joint scientific endeavors. And our first speaker today is Dr. Arild Sundfjord, an oceanographer and program leader of the Norwegian Polar Institute's Arctic Ocean Program. And the title of his presentation is Towards a More Complete and Sustainable Arctic Observing System. Dr. Sundfjord, the screen is yours. Welcome.
Great, thanks very much. And good to see you all, dear friends. Thank you very much for inviting me to talk today. As the title says, we are working together towards a more complete and pan-Arctic observing system. And by observing system, we mean systems that together comprise the cryosphere, so the glaciers and the sea ice, the ocean, the terrestrial domain, the atmosphere, essentially everything that governs and constitutes the environment and the climate of the Arctic. And an observing system that is going to inform us about all these aspects needs to contain autonomous vehicles, for example, people on sea ice or on land. We need remote sensing from satellites. We need instruments out in the field. And of course, we need humans, locals, and indigenous peoples to be involved in a complete observing system. So that will be the topic of my presentation today. And I will focus mostly on one particular new project that is started about 1 year ago. That involves partners in many countries and across all of these fields. Next slide, please. So the project that I will mostly talk about is called Arctic Passion. It's funded by the European Commission, runs for 4 years, but I will say immediately that the aim of this project is not that it ends in 4 years, but that we create a legacy and ongoing collaborations and systems that will last for decades afterwards. We currently have 35 partner organizations and 6 indigenous communities that are involved. And I'm very happy that KOPRI has joined formally as an official partner just a couple of weeks ago. And we will have a first meeting 13 days from now to discuss more specifically how KOPRI will join us in the field and in our other endeavors in this project. So for more information, you can look at the website cited here, arcticpassion.eu. Next slide, please. The project is very broad and has many objectives beyond just the observing system itself. The overarching goal is to create a coherent, integrated, and sustainable pan-Arctic observing system, which, as I mentioned, includes collaboration with Arctic communities, indigenous peoples, and their organizations, expand the monitoring capabilities. Much is in place, but we need more and better integrated capabilities on the ground and in the air. And this again includes inclusion of indigenous knowledge. Other objectives are, of course, to improve data interoperability, meaning that data that is provided from the different components of the observing system is conveyed in a useful way to end users or locals or anyone who needs environmental and climate data from this region. There are many other goals, objectives for the project that I will not go into detail on today. I will focus mostly on the observation system itself and even more so on the marine part of the observing system. Next slide, please. So this figure illustrates the geographical domain of the project itself, and it includes elements, as I mentioned, on land, on glaciers, in the ocean. This is an illustration from the proposal phase, but illustrates in a good way the ambitions of the project and the complexity of the project, where you have all these different elements using different methods and involving very different institutions and organizations. Next slide, please. Project organization is often not very interesting. I just wanted to show this one quickly to show you that there is about 50% of the project devoted to the observing system itself. So observations, the data conveying, making useful products based on data. That's the upper 4 work packages. But then there is a significant part of the project, time and energy devoted to kind of the real end products, which should give societal benefits, improving international cooperation, and supporting decision making on political levels and for industries and other actors in the area for that sake. And then, of course, outreach, dissemination of the results, and to the broader audiences. Next, please. I will dive into the ocean, the Arctic Ocean proper, and tell you about some of the activities that we have had in the project so far. So last summer, we had an expedition with Consortium that Matthias from UIT already introduced you to, the ice-breaking vessel that we used together. The ship first went to the North Pole and then going towards Greenland, starting on the real main transect, going back towards Svalbard and the Barents Sea. So that's the red line with a lot of small dots on it. There are 2 yellow stars marked along this transect, and those are new ocean moorings. Moorings are instrument platforms that are anchored to the seafloor and equipped with a lot of sensors and instruments that measure different parameters in the water column, from temperature and salinity, sea ice thickness, nutrients, chlorophyll, which indicates how much production there is from algae, carbon chemistry that allows us to learn about ocean acidification and carbon uptake from the atmosphere. A suite of instruments that are standardized and identical on these 2 moorings. There have been extremely few long-term observations in the water column in the interior Arctic Ocean, and particularly in the European part of the Arctic Ocean. So this is something that we've wanted to do for a long time, and finally we are able to deploy such moorings in a planned long-term manner. You can see a lot of stars also in the Fram Strait further south, which have been in place for up to a couple of decades or even 30 years, some of them. So we have a long-term history of observing what comes into the Arctic Ocean and what goes out from the Arctic Ocean. But finally, we are starting to learn more about what goes on inside this important and soon ice-free area in the European Arctic Ocean. Next slide, please. Another important part that we want to strengthen through Arctic Passion is coverage of the sea ice, the snow cover on the sea ice, and the water just below the sea ice. And we do this by deploying sea ice drifting buoys. An example is shown on the right-hand side of a buoy that also contains an instrument that will cover marine life, zooplankton and fish in the layers below the sea ice. So the main figure on the left-hand side on the map illustrates sea ice drifting buoys that have been deployed since July this year. Some of the drifting tracks of the sea ice moving towards Fram Strait are illustrated. I didn't manage to include all of them, unfortunately, but this is a good example of collaboration across institutions in the Arctic Passion project, where we have deployed buoys from the Alfred Wegener Institute, from University of Tromsø, UIT, from Université Sorbonne in France, and also from the Norwegian Polar Institute. So by planning jointly who deploys where and when, we get really good spatial and temporal coverage of this. Next slide, please. So the reason for showing these two previous slides with the moorings and the sea ice drifting buoys is that they will form part of a long-term regional system that we call the Atlantic-Arctic Distributed Biological Observatory. If you look at the top of the map on the right-hand side, there's something called the DBO Pacific sector, the Distributed Biological Observatory in the Pacific sector of the Arctic Ocean. This is a system that has been in place for more than 20 years, a very successful system of collaboration between the US, Japan, Korea, and Canada, among others, where they do standard transects in a standard way and plan things together for many years. It's a good system of sharing data, discussing what's in the data, and providing synthesis of how this region is developing. A similar system is being built up between Greenland and Canada, the Baffin Bay and Davis Strait DBO. And now we are in the phase of establishing the Atlantic Arctic DBO system in the European side of the Arctic Ocean. The yellow lines and circles illustrate standard transects or ship tracks that the partners should agree on, and the circles illustrate areas of special focus where we should dig even deeper into details of the processes that are governing climate and ecosystem status. So key parts of establishing this system is to identify these key locations for joint monitoring and research. There's a need for a very communal, open planning process, and also better sharing of infrastructure such as ships, moorings, etc. Again, sharing of data and sharing data that have been processed in the same way is super important. And by doing this together, we want to create win-win situations between the institutions with mandates for long-term monitoring, such as the Norwegian Polar Institute that is responsible for monitoring on behalf of the Norwegian government, jointly with institutions that work more on project basis to understand basic processes, for example, typical university projects that are equally important and together can get more out of their efforts. So for more information on this, please visit the Arctic Passion website on the subpage ADBO. Next slide, please. Quite similar to this is the Interact system, which has been in place for a very long time. This is a system of collaboration between land stations, terrestrial stations that also monitor environmental conditions and climate development. As you can see, unfortunately, the partner stations in the Russian Arctic are for now suspended from this collaboration, which is of course a big loss that we'll have to deal with somehow. But there are still many stations in Scandinavia, on Greenland, in Canada, and in Alaska that are providing access to each other's sites, harmonizing their ways of doing observations. And within the Arctic Passion project, there is a push to increase or improve the coverage at the number of stations to make sure they have equal instrumentation and the same data can be provided for comparison between different sites. So these are just a couple of snapshots from this big project. There's of course lots of work going on obtaining data from glacier sites to improve satellite based data on glacier change. There are similar things for sea ice where you do field studies to improve the quality of remote sensing products. Next slide, please.
Dr. Sundfield, sorry to interrupt. You have 1 minute left.
Perfect, thank you. Yeah, and in today's presentation, there's unfortunately not much time to go into the community-based observations and indigenous and local knowledge, but this is a super important part of the project, and it's important to include these from the design of the observational systems. The local people have to be allowed to decide which questions the observational data should give answers to. So they need to be included from the very first stage. So we try to improve that situation. Next slide, please. Yes, the final slide. I just wanted to mention that there are many organizations, many initiatives to harmonize Arctic observations and Arctic climate and ecosystem projects. There is an ongoing push to align the IASC plans with the UN Decade for Ocean Science in the Arctic. And I just wanted to alert you to the processes going on with aligning this again with Arctic Passion, so that we reduce the number of sort of competing processes, but rather merge them to allow us to focus our energy on getting more work done together in the Arctic. So there is a strong need for international collaboration, even more so in these troubling geopolitical times. And I'm very happy to be able to join this meeting today. And as I mentioned, I look very much forward to including the Korean partners in Arctic Passion and elsewhere. So thank you very much.
Thank you so much, Dr. Sundfjord. Our next speaker comes from Denmark. He is an astrophysicist and chief advisor at DTU, the Technical University of Denmark. Dr. Michael Linden Wernle will join us with a pre-recorded message online. He will speak of drone-based cryosphere observations in Greenland. Welcome.
So good afternoon, everybody at the Arctic Partnership Week. My name is Michael Linden Wernle. I'm an astrophysicist and chief advisor at the National Space Institute in Denmark, or DTU Space. I'm very sorry that I'm not able to be with you physically during the Arctic Partnership Week, but right now I'm in the United Arab Emirates. So I'm participating in a conference called the Abu Dhabi Space Dialogue, where we are trying to set out the future for space. How do we cooperate better in the space regime? And this also very much taps into the discussion about climate research and Arctic research, because space, as most of you probably know, is the key enabler to allow us to monitor the changes of our climate, especially in the Arctic region, where things are moving very, very fast at a worrying rate. The combination of space-based observations together with unmanned systems like drones has proven itself to be very, very useful, and we are very happy that we've now for several years had this close collaboration with the Korea Polar Research Institute and also the Korea Aerospace Research Institute, employing drone-based platforms in order to investigate the climate change, especially on the glaciers in Greenland. And this project is still continuing and yielding very, very promising results. Let me allow myself to look a bit into the future, because one thing is what's going on now, but the interesting part is how are we going to proceed into the future with our collaboration between the Kingdom of Denmark and South Korea. And a lot of promising steps have already been taken. So we have made a memorandum of understanding between the Ministry of Ocean and Fisheries in Korea, with the Ministry of Science and Higher Education in Denmark, which allows researchers in both countries to establish research collaborations. And in the near future, we are going to establish workshops and pursue this collaboration to extend both the ongoing activities, but also to look into the future and say, okay, what other activities could we envision for both Denmark and Korea, Kingdom of Denmark and Korea, and going ahead. And here the utilization of drone technology is definitely a very important part. And the results so far from the field works we've been doing in Greenland, in Kangerlussuaq, in both in September 2021 and in January and June 2022 are very promising, and we are planning the next campaign in this program, actually the last in this campaign, in September of next year. But there's a natural extension because there are other glaciers in Greenland that we want to investigate. We want to study them as well, with the drone data giving much more detailed observations, much more high-resolution information than can be obtained from space-based platforms. But the combination of space-based data and data from drones and in-situ measurements done on the ground during fieldwork is essential to get a deeper understanding of the activities and the changes due to climate change in the Arctic region. Looking into the further future, one of the things that is of very much importance for us in Denmark and DTU Space is broader vision towards observing the Arctic region. And here it's been of special interest that our good colleagues from the Korea Aerospace Research Institute are looking into the use of high-altitude pseudo-satellites, HAPS, high-altitude platforms, drones that can fly at very high altitudes, around 60,000 feet, and do a lot of different kind of scientific measurements. One thing that's of particular interest is doing a geomagnetic survey of Greenland, because Greenland's geomagnetic properties can yield information about the heat flow through the mantle and the core or the surface of the Earth below the ice sheet, which can yield important information about how much heat is melting from below, combined with the heating that we see from the coming from the atmosphere due to the global warming. That's one thing, and also generally the geomagnetic properties of the soil and the ground is of high importance. Also to map the distribution of various minerals. So conducting surveys like this using high-altitude platforms would be ideal, and we have to look into that. We have already, during a visit that I made to South Korea in the end of September, had initial discussions with KOPRI on their development of platforms, and also had very constructive talks with KOPRI with the ongoing process of developing new projects towards a deeper collaboration between the Kingdom of Denmark and South Korea. So in general, I think this is very important that we continue to do this development, and we focus on these technical aspects which will allow us to do some both technological developments and some innovation, which will be a generally interesting thing, but also to provide the necessary platforms to provide scientific data for understanding the effects of climate change in the Arctic region. So I sincerely believe that this collaboration between the Kingdom of Denmark and especially the very good relations that we have now established between the Technical University of Denmark, DTU, and especially my institute, DTU Space, the National Space Institute, and KOPRI and KOPRI, that building upon these good relations, we can further the collaboration between Denmark and then South Korea. So looking into the future, I think a lot of interesting projects will be coming our way. The concrete way of going about this The idea is to have a workshop during the spring of next year at KOPRI in South Korea, where we bring together South Korean and researchers from the Kingdom of Denmark in order to discuss what could be the possible projects, what would be the possible topics of collaboration that would be relevant in order to develop this collaboration. And I sincerely believe that this could be a very useful process in order to identify the projects that we want to do, how we're going to do it, looking at the possibilities, how we're going to fund it, in order to maintain the momentum as we have now with some good results from the initial projects that we've been doing, and then continue this very productive collaboration. So at this point, I will finish off. I'm sorry I'm not able to be with you in person, and the situation is that I've had some computer problems, so I will not have any presentation to give to you. But I hope that this very brief introduction here and my statements will also emphasize the importance of the continued collaboration, which we at least feel from our side is very constructive and has yielded a lot of interesting things. And I should mention also that in relation to the development of drone technology, right now at the Technical University of Denmark, we are looking into developing the area around Kangerlussuaq in Greenland, where we've been doing our field trips so far with the KOPRI DTU collaboration, into a drone test area. So right now we have applied for funding to establish an RTK network, which would allow us to do sub-centimeter positioning of unmanned systems in the area, and allowing tests of systems and navigational systems within the Arctic region. So we believe that this could be a very beneficial thing, both for the research projects that we are looking into, but also a very beneficial thing, and that's very important for the local community, because as we are looking into a future now where the main airport in Greenland has been Kangerlussuaq right now, both the capital Nuuk and other major cities in Greenland, they're establishing airports for international traffic. So Kangerlussuaq is looking into a future where they want to identify other routes in order to support the local population and their activities. And a drone test center in the city of Kangerlussuaq with strong international relations with South Korea, for example, would be a very, very useful thing. So that's what we are pushing for right now. We will be conducting initial talks and workshops with both government authorities in Greenland, but also other interested parties in the coming month, in order to foresee the possible establishment of a drone test center in the city of Kangerlussuaq, which has the only city actually in Greenland that has direct access to the ice sheet in Greenland just by going on a road. And DTU Space and DTU, we have a strong presence there because we have our own campus in the city of Sisimiut, which is a few, not so far from the city of Kangerlussuaq. And right now a road is being established, which will enable kind of building a campus area within the cities of Sisimiut and Kangerlussuaq. So I sincerely hope that South Korean researchers will be interested and willing in participating in this development, which could be very, very useful and beneficial for both parties. So on that note, I would like to thank you very much for the opportunity to share my thoughts with you. Again, I apologize for not being able to be with you in person and not share some more detailed information on slides because I have some computer problems here. But I still hope that we can continue the dialogue. So far, I mean, it's been very fruitful, and it's been something that's just been yielding more and more for both parties. That's at least my perception, and I hope that's also the perception from the South Korean side. So thank you very much. And I hope that the Arctic Partnership Week has been useful and beneficial as always. And I hope to be able to participate next year physically in person. And thank you very much for your attention.
Thank you for your time, Dr. Linden-Wernle. Our next speaker is Associate Professor Nicholas Balacio from the College of William and Mary. He will speak to us about the Vandel project in northern Greenland. Associate Professor, the screen is yours.
All right. Thank you for having me. I just first want to say how much I appreciate being here and being able to share information about this project going on in northern Greenland on behalf of our project team. My name is Nick Balacio. I'm a climate scientist working at William and Mary, working in the Arctic for the past 20 years or so. I'm from the United States, but currently I'm at the University of Bergen on a Fulbright scholarship. So I'm coming to you from Norway this morning or this afternoon. So I appreciate the opportunity to share information on one of our Arctic projects on behalf of our group. This is the Wendel project, which is focused on a region in northern Greenland. The importance of this and the reason that we're highlighting this project in particular, because it's an interdisciplinary project focused on terrestrial, climate, and environmental change. It's international. It's funded in part through the US, the UK. We have partners in Greenland and Norway. And it's focused on not only terrestrial climate and environmental change, but also the human history of this region and landscapes in the Arctic. And we have engagement with local Greenlandic communities. And so this is an extension of the work that my group has done over the past few decades in the Arctic. And it also highlights some of the potential for collaboration with Korean scientists currently with this current project and in the years to come as we move forward with this project over the next 3 to 4 years. And so I'm a co-principal investigator on this project, and I've also highlighted Ray Bradley of the Climate System Research Center at the University of Massachusetts, who is the lead investigator on this project. Next slide. So just a quick outline for the talk. I wanted to just give an overview of the Wendel project, talk about some of our objectives for research, the completed work and future work, and this leads right into the potential for Korean scientists working in the area, which we've been in touch with, and hope that we can continue and establish a partnership going forward in the years to come. Next slide. So the Wendel project and sort of the overview for it is, broadly speaking, investigating climate change in the high Arctic, and in particular looking at records of past climate change through the study of the paleoclimate of the region. But it's also doing this in the context of early human habitation in northern Greenland. And I chose to highlight this project of our groups because of its potential for collaboration with Korean scientists, but number one, because of its interdisciplinary nature, coupling climate scientists, climate modelers, as well as archaeologists in the field of study of looking at terrestrial environmental change, the international aspect of it, both in terms of funding as well as partners that we have, and our engagement with folks at the Greenland National Museum, and through them engagement with the local Greenlandic communities. And local Greenlanders have been a part of this project this year and going forward. Next slide, please. So the Wendel project is a region in northern Greenland, and that's the focus of this study, and that's the open red box at the top along the north coast of Greenland. I've also highlighted in red squares our previous project locations where we've conducted very similar research looking at both climate change and early human activities that have been interdisciplinary, but also our expertise in regional Arctic paleoclimate studies throughout Greenland and other regions in the northern North Atlantic. Next slide. So I'm not going to go too far into the details of the research context, but it does provide an interesting angle on some of our work in different parts of the Arctic, and in particular with the Wendel project. And it's sort of thinking about not only the climate change in the high Arctic and the reconfiguration currently of ice sheets and ice caps and glaciers, and we do this oftentimes in the context of looking at past records and paleoclimatology. But what our group has been doing to look at this from a couple of different angles is by looking at the human history. And there's this map is showing the location of early approximate regions of Paleo-Inuit cultures throughout the Arctic, from eastern Siberia through Alaska, northern Canada, and into Greenland. And there are really interesting questions about the timing of movement, the interactions between these different groups, and the potential for that climate influenced a lot of early human activities in parts of the Arctic. And this also highlights a way to engage local communities in the high Arctic who are interested in the human history, and coupling the studies of climate change with human history, both past and present. Next slide, please. So getting back to the Wendell-Dal region, this is a zoom in on northern Greenland. This is a shot somewhat in the spring. So you can see in the northern part of the region is the Arctic Ocean covered in sea ice, and the Greenland ice sheet is on the southern part of this image, and the red box highlights the Wendell-Dal region, which we are studying. And like I said, there's an impressive change going on here, and the amount of warming, as well as changes in precipitation patterns that are going on today. And we're also looking at the paleoclimate of this region within the context of human migration. And it's pretty interesting in the Wendell-Dal region, there are dated artifacts that put people there approximately 4,000 years ago, very soon after ice was retreating from the last ice age. And we are interested in this because of the potential role that natural climate variability had on the migration of people into and out of this region. There are several phases of settlement and abandonment by Paleo-Inuit and Inuit cultures, and trying to understand that history is important for understanding the human history of this region, of some of the northernmost settlements in the world. And we're doing this through this interdisciplinary and international project. Next slide. And so this is again zooming in on the Wendell-Dal region, getting a little bit closer. The main part of it is marked by Midsummer Lake, which is the long lake running from west to east in the center of the image, pointed to with a red arrow. The Greenland ice sheet is in the southwestern corner or the lower left corner of this image, and there are several small ice caps surrounding the Midsummer Lake and its catchment and valley around it. And so this region, of course, there's a lot to say about the extent of glaciers and ice sheets since the last ice age in this region, as well as in response to modern global warming. But this region is also very important to the early human history of northern Greenland. Next slide. And so this is looking at the same region. This is a map from a paper studying the archaeology of this area. And the title of this caption is Wendell-Dal, a High Arctic Oasis. And this is a pretty difficult and tough environment to imagine living in, especially 4,000 years ago. But it's remarkable in terms of the number of archaeological sites that have been mapped in and around the Wendell-Dal region. And the importance here is just to show the number of archaeological sites. It was a very important place with some of these earliest northernmost settlements in Arctic. There's evidence for the Independence Paleo-Inuit culture, the Paleo-Dorset culture, and up through the Thule. And but there's also questions that remain about the timing of a lot of these movements and the potential that climate and other environmental changes might have had on these early people. Next slide. Next slide, please. So the project goal is to understand the climate history of the region and to place the ancient occupation of Wendell-Dal into a broader context. We're going to be looking at climate, thinking about thresholds that exist and that could have driven abandonment and migration throughout this region, and also looking at it from both an archaeological and paleoanthropological perspective, as well as looking at the climate history of the region. Next slide. So just to highlight the project team, as I said, this is an international effort with collaborators in the United States, at various universities, the British Antarctic Survey, people at the Greenland National Museum, as well as collaborators in Norway that are advancing this research. It's jointly funded by the US National Science Foundation, the UK Natural Environment Research Council, and the Greenland National Museum. Next slide. And so the research activities, briefly, I'll go through them, but that we are focusing on aspects of the archaeology. We're doing paleoclimate work using lake sediment records from this region, and we're coupling that with climate modeling efforts to look at multiple dimensions of Arctic environmental change, as well as reconstructing the human history of the area. Next slide, please. So briefly, the goal of the archaeology is to refine the history of occupation of Wendeldahl and the geographic extent of some of these settlements in Wendeldahl and the adjacent areas. Next slide. This is being done through fieldwork and laboratory work. Fieldwork is being done to do field surveying and drone surveying of archaeological sites in the Wendeldahl region. We're also doing work to improve the chronology of various settlements that have occupied this area through radiocarbon dating. We don't have funding for additional material to be sampled in the field, but there's a wealth of material that's archived at museums in Nuuk and Copenhagen that will be radiocarbon dated, and will try to improve our understanding of the timing of settlement patterns in this region. Next slide. The lake sediment work is, as previous people have talked about in terms of looking at changes in marine environments, we can do the same thing in terrestrial environments. Lakes provide continuous archives of climate and environmental histories. They reflect what's going on with the lake in terms of its biology, as well as ice cover. And we can also reflect changes in the watershed of the lake that get washed into it. Our goal here is to recover 5,000-year-long sediment records from Midsummer Lake in the main part of Wendeldahl and other lakes in the region. Next slide. We also have a modeling component of this, and this is to place the archaeology as well as the paleoclimate and paleoenvironmental work into a broader perspective. The goals of this are to simulate the location and extent of sea ice and polynyas over the last 5,000 years, and examine how these changes could have provided opportunities for Paleoinuit to hunt marine mammals, as well as using for migration corridors. Next slide. So just to give a brief run through of what we've been up to, in 2022, we began field work in this. We had a camp on Lower Midsummer Lake near some of the main archaeological sites in this region. Next slide. Field archaeological surveys were conducted by members of the Greenland National Museum. As you can see, most of this is very easily observed on the surface because of the lack of soil and any vegetation cover at all. Next slide. We conducted fieldwork surveys on the lake, looking at the bathymetry of Lower Wendeldahl, the Midsummer Lake, as well as seismic profiles to identify sediment that can be recovered and that are undisturbed, that would record environmental changes. Next slide. And we conducted sediment coring from floating platforms to recover sediments from various locations. Next slide. And so we've recovered approximately 30 meters of sediment from several sites that we'll begin analysis on now. Next slide. So ongoing activities will include the analysis of a lot of these sediment samples, which is shown in the image to the right, looking at both the paleoecology, paleotemperature records and hydrology records, dating of sediment records, as well as the archaeological dating is what's going on currently and will in the next couple of years. Next slide. And we also have planned field activities in 2023. And we plan for an NSF camp on the upper part of Midsummer Lake. We're going to be targeting other lakes in the region to look at past ice extent. And this camp that we have planned for 2023 also offers the potential for collaboration directly with Korean scientists. And that was one of the other highlights of this project. Next slide. Is that we have been in touch with members of the Korean Polar Research Institute who are conducting a nearby interdisciplinary project with work in Sirius Passet, which is just located a little bit northwest of our study region, but they have planned work on Upper Midsummer's Lake. And we have been in discussions about a possibility for a joint camp in 2023 and collaborating on logistics. And we know we have mutual research interests in terms of understanding paleo-environmental change, as well as some of the paleoecology that we hope to collaborate in the years to come as this project, which is really just kicking off this year, will span the next 4 years. That offers a lot of really interesting potential of collaboration with Korean scientists and our group. Next slide. So yes, again, thank you for the opportunity to be here. What I've summarized here is also on our project website that highlights this interdisciplinary and international effort. And I appreciate the opportunity to talk to you and represent my project team. And of course, at the end of the session, I'd be happy to answer any questions about this.
Thank you, Dr. Barlaccio, for sharing this intriguing project with us. We appreciate you being with us today. We have not received any questions from the audience so far, so we are moving ahead to the fourth speaker of this session. He is Dr. Heikki Lihavainen, the director of the Svalbard Integrated Arctic Earth Observing System. And he will speak of an international research infrastructure for Arctic Earth System science. Dr. Lihavainen, welcome, and the screen is yours.
Thank you, and thank you for inviting me to represent SciOS in this event. Next slide. What is SciOS? SciOS is a consortium of institutions with research infrastructure in and around Svalbard. We have currently 28 members from 10 different countries. And I would like to express my warmest welcome to KOPRI to join SciOS family. I'm convinced that your participation will create mutual benefits and improve the conditions of research in Svalbard. The mission of SciOS is to develop an efficient observing system, share technology, knowledge, experience, and data, close knowledge gap, and decrease the environmental footprint of science. The observing system itself, it's concentrating on Earth system science, but it's a holistic approach within the Earth system science. So it includes oosphere, geosphere, cryosphere, atmosphere, hydrosphere, and biosphere. And especially we are concentrating on the processes and the interaction between these spheres. Our target is to provide systematic observations which are stable over time, but yet we want to be dynamic when the new questions and needs from society arise. And as a research infrastructure, the main goal is open and free harmonized data. On this figure, here you can see where SciOS observations are conducted or planned to be conducted. These are the infrastructure that science members has reported to us. So this is one way to help to find synergies and find possibilities for common investments and science. Next, please. The first phase of our endeavor was to establish the foundations to science operations and services. Just this year, we entered the new phase, a new funding phase, and this was a natural place to renew our strategy, which this slide reflects. It's a busy slide, and I'm not going to go into details, but the strategy and the mission is fulfilled and achieved with these three pillars: joint activities, services, and management. And in this new strategy, we put more efforts to joint activities where we provide and organize together with our members different kind of workshops, trainings, and also optimization of the observing system with different various kind of tools. Some of the tools I will represent later in my talk. We have also secondment program where we invite our members, researchers from member institutions can apply to visit here us at Longyearbyen to work with SciOS KC, SciOS Knowledge Center. And of course, nothing of this will never happen or would happen without the active member engagement. Next, please. As a multidisciplinary research infrastructure, there are big challenges, but the potentials are even bigger. As an example of holistic approach is snow. The snow is affecting everything here at Svalbard. It's cooling the atmosphere, it controls greenhouse fluxes, it blocks food sources for mammals and other animals. It creates natural hazards, logistics are depending on it, and so forth. So this figure that you can see here tries to summarize in a simplified manner the complexity of the processes and how to observe variables affecting the snow processes. This is also a good example of the collaborative work within SciOS to develop observing system. All these were initiated by various snow-related chapters in our annual State of Environmental Science in Svalbard reports and multidisciplinary workshop on snow, which actually produced this scientific paper, which has been accepted for publication in Polar Research. It also the recommendations that were provided from CES reports, it was implemented as a snow pilot, where harmonized snow cover observations are taking place in all around Svalbard. So this is actually, the CES reports are a bottom-up approach where research crews can actively influence the prioritization within SciOS and in developing the science observing system. Next, please. As I mentioned earlier, data is one of the main products of research infrastructure. And the main principle of the data management services is to provide open and free data sharing according to FAIR principles, so findable, accessible, interoperable, and reusable data. We don't have our own data center, but we are distributed data center. So we are harvesting the different data centers that are provided by our member institutions. And we are using international standards. And what is important, of course, is harmonization of data. For example, temperature can mean different thing to different scientists or operational activities. It can be different dimensions, Kelvins, Celsius, Fahrenheit, whatever. It can be 2 meters above surface or 2 meters below surface. And the idea of this, our data access point, is to have cross-disciplinary combination of data and products that could be easily accessible, that they shouldn't have to go to the different databases. So it's about discovery, retrieval, visualization, and transformation of data. Next, please. And this is an example, one of the data set. This is actually the longest data set that can be entered through our data portal. This is a meteorological data from Hopen temperature, and I like this figure because here you can see the warming that has been occurred from the 70s and 80s, and you can also see that the warming is more pronounced during winter times. And indeed, the winter temperatures have increased, depending where you measure, from 5 to 8 degrees in Svalbard. Next. One of our quite famous service or activities is SciOS Access Program. We have had 3 calls so far. Unfortunately, this was heavily affected by the COVID-19 pandemic, but that was also us a good showcase how we can work as a community. So we provided those that couldn't travel, we tried to provide remote access, so there are people here at Svalbard to take care of some of the operations that couldn't be couldn't take place because people couldn't travel. And we provide also different kind of remote sensing products to fill up the field data. For example, we had 2 Dornier campaigns, and also we provided extra amount of remote sensing services. So it has been on hold, but now it's renewed. We are opening the new program next year, which is slightly different than the earlier one. So it's open for members and non-members. It includes physical and remote access to research infrastructure in Svalbard. And we have an annual budget about 1 million. And it's expected to be open in February 23. This is the new service that we are providing, and it's about optimization of the observing system. Developing the observing system in Svalbard with pan-Arctic and/or interdisciplinary focus. So this call is open now. The deadline is mid-December, and here you can see what kind of funding is available. And this is actually based on these SES report recommendations. So those are the objectives that we are looking for in the application. But you can find more information about the call in our web pages. I brought up this as this is one way we try to enhance the innovation in science community. Innovation is we need that in order to decrease the environmental footprint of science, but also the parts of the archipelago of Svalbard is hard to reach or access, and new infrastructure is almost impossible to to solid infrastructure is almost impossible to get permits for them. So we need new innovations to tackle these issues. So we have come up with the Science Innovation Award. This has been awarded once, and the next award will be announced during next Svalbard Science Conference 2023. And we opened the call for nominations in the beginning of 23. We are also looking, unfortunately, the one half of the Arctic is at the moment inaccessible. So we are reaching to different directions to find synergies and collaboration. We have started collaboration or strengthening collaboration with Svalbard, Greenland, sorry. And we had this sort of a Svalbard Greenland workshop in the beginning of October. We rename it as Bridging the Fram Strait. So we found a lot of synergies that we could utilize within logistics, for example, scientific collaboration, project proposals, and also as well Green Master Program. Next, please. Next, please. I forgot to say that, but yes. And next, please. And I invite you all to our main event, Polar Night Week. It's taking place in Longyearbyen, 23rd to 27th January. Register now. Its registration is open. The event will be hybrid, but still we would like to see as many of you at Svalbard as possible. Once again, I wish KOPRI most welcome to SciOS, and I'm looking eagerly discoveries what Mother Nature reveals us with our common endeavor. Thank you.
Thank you, Dr. Lihaman, also for outlining the opportunities for further collaboration internationally. Now it is time for a health break. I announce a break of a whole 9 minutes. We will reconvene at 5:30, 17:30 local time for the final part of today's seminar. So please be back sharp. Thank you. I've heard about this book. Thank you so much. I appreciate it. Ladies and gentlemen, may I kindly ask you to take your seats? All right. Right on time. Welcome back to the third part of today's International Arctic Cooperation Seminar. Now, the final part of today's seminar focuses on the plans to further science cooperation from both science and government perspectives. As earlier, should you have any questions here in the audience, please raise your hand. We welcome those. But I will start off with a few questions to the panelists myself. But before that, I would like to present our distinguished guests. With me on stage, I have Dr. Yu Kung Lee, who is the head of the KOPRI Norwegian Polar Institution Cooperative Polar Research Center and the president of Korea's Space Biology Association. She is a polar ecologist specialized in Svalbard. With us on screen, we have Dr. Christine Mi Lee. She's the Counselor for Higher Education, Research and Innovation at the Norwegian Embassy in Seoul. The main purpose of her position is to contribute to increased cooperation between Norway and South Korea within the fields of higher education, research and innovation, and to see education and research cooperation in the context of industry cooperation. And then we're also very pleased to have with us Ms. Ine Nør-Madsen, who is the Science and Innovation Attaché at the Innovation Center of Denmark in Seoul. She's got a master's degree in political science from the Aarhus University and extensive experience working at Universities Denmark, which is a cooperative organization for 10 Danish universities. Welcome, ladies. Now, Dr. Lee. The previous presentations have greatly summarized the international Arctic science cooperation activities since the establishment of the Busan Research Station 20 years ago. So in the light of the 20 years of joint research efforts in Ny-Ålesund, what is, in your view, the most significant scientific finding by the Korean program and why?
네, 저는 우리말로 I would like to speak in English or Korean. I would like to speak in Korean. Over the past 20 years, Busan Station conducted various research programs, and each program has their own unique value. And it is impossible to pinpoint to a single most important program. So rather than pointing to the best outcome, I would like to simply introduce two more programs that haven't been introduced today. Yesterday at the Swiss Federal Research Institute, I received an email. All the fungus that inhabits the soil around the world, and to study them and their genes to look at how they interact in climate change. So the email was a proposal for such a program and proposed that we conduct the permafrost research. So far at the Busan Station, we have been conducting the soil properties and the microbial communities in the soil and published many different papers. And by reading the papers that we published, the research team contacted us. So this shows that soil and permafrost study conducted by Busan Station is very important. And Arctic vegetation research is another key example of Korea-Norway cooperation. We together published a book that introduces tundra vegetation. I presented this book to Executive Director Anu Fredrickson, and I was happy to do so. Not only Korea and Norway, but the book also is published in Chinese and English, introducing different plants that inhabit the tundra region. So through this book, I hope that the people understand that in the Arctic, there aren't just the polar bears and the ice, but beautiful flowers and vegetation. Because of climate change, the tundra plants are at the brink of being extinct. Going forward, Korea, Norway, and Denmark, I hope, can work together to preserve the near extinct plants. Thank you.
Thank you so much, Dr. Lee. Now, moving forward to Councillor Lee, online. You started at the Norwegian Embassy in September this year, and your position was newly introduced based on the panorama strategy, which the ambassador also highlighted in her opening remarks. What is the panorama strategy, and how the strategy and your service here in Korea will contribute to future scientific collaboration with Korea in the Arctic?
Yes, thank you. That is correct, and I would be very happy to explain some more. Now, the Panorama strategy is a strategy for all of Norway's prioritized countries outside of the EU, with the objective to promote international research and education cooperation. So the first strategy was launched in 2016, and when it was updated in 2021, I am very happy to say that Korea was the only new country added, and hence making Korea one of Norway's 9 strategic partner countries within education and research cooperation. Now, this, of course, sends a clear statement from the government of Norway that Korea is a highly prioritized and valued partner country. And of course, for Norway-Korean relations, it means that a much larger emphasis will also be put on maintaining and further developing current collaborations, as well as developing new ones. And of course, I am very happy to say that the Arctic research is at the center of this. And I think even though Arctic is perhaps one of the most developed fields already within research collaboration between Korea and Norway, there is for sure a lot more important research to be conducted in the future, as the presentations today also have emphasized. And as was said by the moderator here, as part of this effort, the Norwegian Ministry of Education and Research appointed my position here, starting this fall, so that I could be here on the ground in Korea, working directly with Korean institutions, government bodies and ministries, as well as also supporting Norwegian actors with their outreach and collaboration with Korean partners. So to kickstart this, a few weeks ago, actually, a delegation visited Korea from the Ministry of Education and Research and the main public agencies for education and research in Norway. And together we visited over 13 different Korean institutions and ministries. And among them were MOOF and KOPRI, where we discussed Arctic and polar research collaboration. And finally, I would just like to repeat that our new ambassador that you heard from earlier today also has long experience with and particular interest in Arctic affairs. So I feel very confident that our embassy will be the driving force, continuing and expanding our country's Arctic research collaboration in the years to come.
That is wonderful. Thank you so much, Councillor Lee. I think the audience here also agrees that having Korea on the prioritized list is definitely a landmark. Now, turning over to Ms. Madsen. Efforts to further Arctic cooperation include not just science and research, but also policy. And as we heard from your ambassador, in 2021, the Ministry of Higher Education and Science of Denmark and the Ministry of Oceans and Fisheries here in Korea signed an MOU. What is the purpose of the MOU, and what do the two partner ministries plan when it comes to the implementation of the MOU?
Yes, thank you. Actually, the MOU was signed last year during the Arctic Partnership Week. It was a testament to the long collaboration between Denmark and Korea in science in general, also in green transition. We have an existing collaboration in the Green Growth Alliance, which we signed 10 years ago. And it was only natural to move this also into the polar research, especially because of the strong connection to climate change and climate research. What was also mentioned in the earlier presentation from Dr. Linden Burnley from DTU Space, they have a very strong collaboration with KOPRI and KAI on drone research in Greenland on the glacier melting. And the MOU was very much intended to also to support this existing collaboration, but also to further future collaboration for the benefit of Danish and Korean researchers. There is a number of activities that can be done as part of the MOU. Of course, joint research is one. It can also be exchange on policies, exchange of experts, and similar activities. A key part of implementing the MOU is the organization of a steering committee. We're still working on this, but we expect to have a committee with the representative from Korea, from both the research community and government, and similarly from Denmark, from government side, and from the Danish research communities. We also hope that our colleagues in Greenland and Faroe Islands will take part in the steering committee, so it can also include the local stakeholders. And as part of this steering committee, we can discuss what is going to be the future activities that best serves the interest of the research communities in all locations.
So the steering committee will have a key role when defining also the actions going forward.
It will be a key role. Of course, it's not going to limit what the research can do. There'll always be space for bottom-up research done outside, whatever the steering committee decides. But from the more central point of view, the steering committee will be very important in actually focusing on the joint activities taken from a more government side to best fit also the interests of both, of course, government policies, but also the needs of the research community.
Thank you for that precision, Ms. Madsen. Now, Dr. Lee, you mentioned that it was difficult to pick up one great success, though you referred, for example, to the Arctic vegetation research. But if we look at the next 20 years, what do you see as the most significant challenge that Korea's Arctic program will have to face in the future? And why do you think so?
Going forward in the next 2 decades, I think the greatest challenge would be the North Pole research by the next ice-breaking research vessel. By 2027, we will be building the next IBRV, and afterwards, we will be conducting a Central Arctic Ocean monitoring with this vessel, reaching all the way up to the North Pole. But as you all know, the thick sea ice needs to be broken to venture into the top of the Earth, which is very, very challenging. And to do this, international partnership is essential. So we hope that the second IBRV can be also used with KOPRI's Hakon, the IBRV of Norway, to venture into the high north up to the North Pole. And for this international joint expedition, we will need to engage in close dialogue. Just as northern Greenland, where there are no research stations, science research is absolutely challenging. This summer, in Svalbard, I supported our research team up in the northern Greenland. So in order to access where there is no research station, you have to take all the tents, the fuel, the food, as well as the equipment for research. Going from Svalbard to northern Greenland, it takes about 2 hours by a light airplane with 14 people on board. It is very, very difficult to carry all those equipment. And after the research is over, the researchers has to travel back to Svalbard. But because of the weather conditions, they were stranded there for 5 days because the plane could not take off. And entering and getting out of Greenland can both be very challenging. And in the remote areas of the Arctic, conducting research in the next 20 years will present one of the key challenges.
Thank you, Dr. Lee. I believe that with the improved infrastructure, research infrastructure in place, hopefully some salvation will be coming our way.
Yeah, I hope so.
Councillor Lee, Dr. Lee and all the previous speakers really have pointed out the importance of sustained investments in observation and monitoring in the Arctic. We know that there are various policy efforts going on from the government and research councils regarding research funding. But how would you comment the funding opportunities for collaborative research projects relevant to Svalbard and the Arctic from a Norwegian perspective?
Yes. Well, first let me start by just repeating our ambassador's statement that research and knowledge creation is very much at the heart of Norwegian both Arctic policy and research policy. And I think that given both our country's emphasis on Arctic and polar research, and with the inclusion of Korea in this new panorama strategy, I hope that even more joint research can be conducted in the future. However, as you mentioned, as always, when it comes to ambitious research, stable funding is a crucial factor. So therefore, I am also very happy to share that the Norwegian Research Council have a large Svalbard research call coming up early next year with a total amount of 6.6 billion won. And I think that this call is of very high relevance for Korean researchers. Now, this goes for both those that already cooperate with Norwegian partners, but also for Korean researchers that would like to collaborate with Norwegian researchers in the future. So let me just highlight the few things that makes this call especially relevant for Norway-Korea collaborations. Now, firstly, one of the requirements in this call is that the project must have at least one international partner. And although this is encouraged in all of the Norwegian Research Council's calls, for this particular Svalbard call, it is made a requirement. And this is done so that research shall contribute to increased international cooperation. And secondly, in the last round of evaluation of project in this research call, the Research Council will give priority to projects that include international partners that also has their own funding. So this means then that if Korean researchers can show to their own research funding received from the Korean side or international sources, then the project will be ranked higher and therefore increasing the probability of actually getting funding. So I think for Korean researchers that already have funding or are planning to apply for funding anyway, this might be a great opportunity to join forces with some Norwegian colleagues. So I really do hope that many of the Korean research environments will reach out to Norwegian partners and look into possible projects so that even more joint research than we already have today can be conducted in the future. And of course, let me also emphasize that the requirement here is at least one international partner. So this is also a great opportunity to collaborate across several countries. And finally, of course, I would be happy to share this English version of this call when that is available and ready for people to see.
Thank you so much, Councillor Lee. I think that will be much appreciated, and I believe that venues such as the Arctic Partnership Week and arenas such as this are a perfect opportunity to actually discuss also not just the ongoing, but also the future potential partnerships. Ms. Madsen, the recent discussions focused on Arctic research also highlight the need to improve communication with Arctic indigenous population and the Arctic local population. We also heard that, for example, from the Arctic Passion presentation by Dr. Sundfjord. And this applies very much in Greenland. Are there further plans on the governmental level to facilitate communication with the population of Greenland?
That's a really good question. The MOU in question that was entered last year is between the Kingdom of Denmark and the Republic of Korea. But as I mentioned, the steering committee that we plan to establish to actually plan the joint activities, we really hope that we will see representatives from Greenland and from the Faroe Islands to take part of the steering committee, to feed in the perspectives of local researchers, but also the local community more in general. And I think this is very important to have this involvement in the projects. So that's one way of doing it, to simply have stakeholders on board in the more central planning. Another activities that has been previously done was last year as part of the Greenlandic Science Week. We had a pilot seminar called Connect, which had the representative from Korea, Denmark, and Greenland participating in a seminar in Greenland. And I think this is also something we can build and to take some of the experience from Korea. Can we do something like this in the future and also have a better participation of the local stakeholders in our activities, not only on the research side, but also for the community side. I think this is very much something we should discuss with the researchers that have also the connections out in the community where they're based. I think Michael Linton-Wørne from DTU also suggested or pointed to some of the projects they are planning to do on drone research, which could be very interesting to the community in that area. So this is definitely something we need to focus on, and we will look into this in the future.
You did mention the Connect project that was conducted in Nuuk, and I just wanted to follow up asking, do you already have, or have you already identified some best practices in terms of local contact, or is there perhaps a source that you could guide us to?
In Greenland, we have the Arctic Science Hub, International Arctic Science Hub, which very much works as a connection point to the Greenlandic researchers. They're a little bit like the Innovation Center Denmark here in Seoul. They work as an entry point into the community. So they are a good place to reach out if you know, also Korean researchers are looking to connect on a more informal basis to the research community in Greenland. So that's one area that I could suggest to look at.
International Arctic Science Hub. Excellent recommendation.
Yes.
Thank you so much. Now, it is time to open the floor for questions from the audience. And I would also like to point out that we have President Kang from the Korea Polar Research Institute amongst us as well. So there is plenty of expertise here in the audience. Please, go ahead. Could we have a microphone?
Thank you for the great comments and discussions. I am Lee Ji-young from KOPRI's International Cooperation Division. I have a question for Ms. Kristin Lee from the Norwegian Embassy in Korea. Last October, the UVEN ambassador and the Science and Higher Education Ministry of Norway visited our institute, KOPRI, and it was a great opportunity for us to demonstrate and explain our research efforts. And they shared the news that Korea was included in the Panorama strategy, and you reaffirmed that point here for us. And I was wondering why Korea was selected in the Panorama strategy and the process leading up to that selection. And how do you think that will help our cooperation between our two countries going forward? Thank you.
Yes, thank you. And yeah, you're right. We had a very nice and interesting visit. The delegation that was there, and also together with our ambassador. So thank you for hosting us. As for the selection process, it was the strategy when it was first implemented in 2016. It was 6 countries, and then it was extended in 2021, as I said, with 3 countries. And now Canada and the US were included, but that was just because they integrated the North America strategy into the existing ones. So as I said, Korea was the only new country. And the process for choosing them, I don't know specifically all the details. I wasn't at the ministry at that point, but I know a lot of research and a lot of preparation work were conducted looking into which main countries that were relevant and that were high performing when it came to education, research and innovation. And of course, as we know, South Korea is an outstanding country in that degree, with many high-ranking universities, a lot of investments both from the government side and the business side in research and R&D. So I believe that based on the performance that Korea already did in these important fields, then it pointed itself out as being a very interesting country for Norway to both learn from and to collaborate more with. And also, as we discussed at our meeting at KOPRI, and as the delegation also discussed at their meeting with Ministry of Oceans and Fisheries, both Norway and Korea also have very similar policy interests and priority themes within their policies related to oceans and fisheries, climate, science, etc. And as for how I think the strategy will help, well, firstly, like I said previously, I wouldn't be here if it weren't for the strategy. The strategy managed to create funding so that the Ministry of Education and Research could actually have this position at the embassy, so that they would have someone locally in Seoul to help push this collaboration and this work further. And I think that just by being a priority country, it's very well established that there's something that we should work for, increasing these efforts of collaboration. Thank you.
Thank you, Councillor. Are there further questions from the audience? If not, I have one at backhand. This is a joint question to all of the panelists, and President Kong, if you feel like answering, we would be pleased to hear from you as well. But one of the key takeaways from all the presentations today has been really the need for large international, or for international collaboration within the science. Going forward, in your view, is there a greater need for large international projects rather than national or bilateral projects when working within the Arctic? Dr. Lee, would you like to start?
국제 공동 연구가 사실은 아주 작은.
So I think international collaborative research starts small, where there are common interests between researchers. So that is the starting point. And for this to grow into a larger project, the national interest and government interest is very important. And recently, one of the most important Arctic projects was the Mosaic project. And at first, when Mosaic was proposed, from the first proposal until we actually put a vessel out in the Arctic, it took 10 years because I was a part of the very initial stages. And I wondered whether this would actually be possible. But in Germany, the funding first came, and once the government grants started to come through, many different countries took interest and together pooled funding to support Mosaic, which was an important project. So international cooperation in research definitely requires government support.
Thank you. What about any of our online participants? Do you want to add up on that? President Kang, please.
As I started polar research, I felt very keenly how international collaboration is important. And for smooth going of polar research, mutual trust is essential. This means that we should not be completely reliant. We need to build our own capabilities to be able to give something back to the other leaders of Arctic research in order for us to truly become a substantial partner. So multilateral research is important, but first I think we need to start by building trust between two different countries. And watching these series of seminars during the APW, I feel that Korea is gradually building trust with the world, and in particular today, with the Arctic Frontier, where you are the executive director, Ms. Fredrickson, we'd like to take more part. International cooperation is important in any area because all these collaborative projects can take place through international collaboration. In Asia, countries such as China, Korea, and Japan, we have some language barriers and distant barriers. We would love to take more part in the EU projects, and Norway is really the model for us. We would love to take more part in the Arctic Frontier led by Norway so that KOPRI could take a more leadership role in addressing global challenges as a key stakeholder and an actor. And for that, I'd like to thank you all and thank all participants for being here.
Thank you so much, President Kang, for those remarks. And I believe that what we have heard in this afternoon's seminar definitely reinforces the fact that Korea is on a great path when it comes to building trust and showing its own capabilities. Excellencies, ladies and gentlemen, it is time to wrap up. We have learned today that we're able to predict the future by looking at the past. We've also heard that now that Russia is excluded from the Arctic collaboration, also within the field of science, that is a big loss, especially in terms of data monitoring. But in these troubled geopolitical times, international collaboration is definitely needed more than ever. One potential way of going forward could, for example, be the utilization of drone technology. We also learned that science can help us understand human history of specific region, or even the northernmost settlements on Earth. And we have also heard from these last panels that governments definitely prioritize and also concretely facilitate Arctic research. So there are opportunities both in Norway, in Kingdom of Denmark, and here in Korea. And I think that's a great way for us to end tonight's seminar. Thank you so much for attending.